Let's solve Unit 1 questions. The first question, which of the following is false? This question is from group theory. Let's see the statements first. Every field is an integral domain. Every integral domain is field. Finite integral domain is field. The ring ZP of integers, module P, it is actually modulo P, is field if and only if P is prime. I am just thinking about the aspirants' mindset when they look at this question in the exam hall. Before directly getting into the statements, we have to have some kind of learning regarding all these terms. A ring is a set of numbers with two operations, namely addition and multiplication. Integers Z form a ring. We know the notation for integers will be Z, the capital Z. So they form a ring. Addition behaves like normal integers. They are commutative, it has 0 and negatives also exist. Multiplication is associative, but not every element must have an inverse. What about field? Field is a special kind of ring where every non-zero element must have a multiplicative inverse. That is, for any a that is not equal to 0, there exists b such that a into b will be equal to 1. They say there exists an inverse for every a. Example, we have rational numbers, real numbers and complex numbers. They are all fields. Now the first statement, every field is an integral domain. The statement is saying that the field has no zero divisors. That is, you cannot get 0 by multiplying two non-zero numbers. What is the definition stating here? It is talking only about the non-zero element, which is perfectly applying to this particular statement. And from the example rational numbers q, we can say that they also form an integral domain because rational numbers are given as field. So what are rational numbers? We will have the integers together and any number that is in the form of p by q, where q should not be equal to 0. So this particular statement is perfectly true. Regarding group theory, everything is abstract algebra. There are explanations, there are examples for this. You can explore a lot if you are interested to do. But if you just want to learn about this question, this definition and the related example will be more than enough. Now the second statement says every integral domain is field. In a ring of integers Z, the only element that has inverse are 1 and minus 1. It is because when you multiply 1 into 1 you get 1, and when you multiply minus 1 into minus 1 you get 1. But for 2 there is no integer b such that 2 into something will give you 1. If you take 2, you need 1 by 2 which is equal to 1. Here 2 and 2 will get cancelled. But what is this 1 by 2? This is not integer. When you compute 1 by 2, you will get 0.5 which is falling under rational numbers. Here the question is only about integral domain. So inverses are possible only for two integers, that is 1 and minus 1 is what they say. You cannot find inverses for other integers. The solution would be b is equal to 1 by 2, which is not a part of z. When you are not able to find inverse, here they have given for any a that is not equal to 0, there exists b such that a into b is equal to 1. Now you can relate this particular example to this particular statement. So Z is an integral domain, but 2 has no inverse in this integral domain. So the integral domain is not a field. We are marking this particular statement as false. So the false statement here will be statement number 2. We are marking this answer here. Now from this we can understand third statement and fourth statement are true. We will just see how they are true. Finite integral domain is field. When they say it is every integral domain, we are marking it as false. What about finite integral domain? So some part of integral domain, we can mark it as field. So let's see an example here. Let's take Z5, that is integers modulo 5. When you divide any integer by 5, you will get some remainder. That remainder will be the elements of this particular integers modulo 5. This has only 5 elements. Whenever you divide any integer by 5, you will get only any of these 5 elements. Say for example, when you divide 10 divided by 5, the quotient is 2, but the remainder is 0. When you divide 12 by 5, the quotient is 2, the remainder is 2. When you divide 29 by 5, the quotient is 5, the remainder is 4. So here it is not talking about every integral domain. Here it is talking about finite integral domain. Finite means it is countable number of elements. It has no zero divisors because 5 is prime. Every non-zero element has a multiplicative inverse is what the field definition is telling. Apply this here. Will you be able to get 1 using this integers modulo 5 with all the non-zero elements? Yes, you are getting. When you multiply 1 and 1, you get 1. When you multiply 2 and 3 and apply mod, you get 1. When you multiply 4 and 4 and apply mod, 16 mod 5 will give you 1 again. So there are inverses for these particular elements. So when the domain is finite, it means when it is countable, we can say it is a field because it is having multiplicative inverse for all non-zero elements. So we can conclude Z5 is both a finite integral domain as well as a field. When both these characteristics are true, we can mark option number 3. Finite integral domain is definitely a field. So this is true. Now the fourth statement, it is somehow related to this example only. The ring ZP of integers. So we can apply Z5 of integers. Modulo P is modulo 5 is field if and only if P is prime. Here the example states that 5 is prime. Now we have to check whether any number other than prime number will result in field or not. Let's take Z6. This is finite but not an integral domain. So here the possibility of Z5 is whenever you multiply any two non-zero elements, you will end up with 1, 2, 3 and 4 but not 0. It should never result in 0. That's what they say, it has no zero divisors. But here when you go for Z6, Z6 will have 0, 1, 2, 3, 4, 5. So there are 6 elements here. When you multiply 2 integers, 2 into 3, you can get 6. 6 mod 6 will give you 0 here. Once you get 0 here, it fails that particular condition of field. So when the number given after modulo, if it is prime, then we can say it is a field. When it is not a prime number, then we can say it is not a field. So the statement is saying if and only if it is prime, then we can say the ring is a field. So this statement is also true. 1 into 1, 1 into 2, 1 into 3, 1 into 4. Any possibility you will get 0? No. Then you have 2 into 2, 2 into 3, 2 into 4. Any possibility here? 4, this is 6 and this is 8. So everywhere you will have remainder, that is non-zero. What about 3 into 4? Again it is 12. So nowhere you get 0 for this particular multiplication as long as the number is going to be prime. That's why I gave you the example for Z5 and Z6 and differentiated how statement 3 and 4 are true. Next question. If the set S is equal to the matrix with the elements A0, 0, B, where A and B belong to the set of integers, when this S matrix is a subring of the ring M2 of 2 cross 2 matrices, over the integers, then S is a, they are asking whether it's left idle, right idle, both the ideals or neither the ideals. Actually, first we'll understand what are the terms here and then we'll get into the solving part. This is a set of 2 cross 2 diagonal matrices with integer entries. That's all we can understand from what is given in this particular S. What does ring theory say? So we know the ring has two kinds of operation. One is addition and the other one is multiplication. Regarding addition, this forms an abelian group. It means it has four kinds of properties. It is closed, it is associative, it is having identity element 0. So any number when you add with 0 you will get the same number, and you have inverses. Whether it is satisfying for field or not is not an issue for this particular question. When you go with the concept of abelian group, it has inverses. What about multiplication? It is closed, it is associative, and it distributes over addition is what they say. Distributes in the sense, instead of having 2 into 3, you can go for 2 plus 2 plus 2. You can take it in that angle. They have given this particular matrix as an example here. M2 of Z means the set of all 2 cross 2 integer matrices. So here 2 cross 2 is given as 2 and Z mentions that it is a set of integer matrices. So on the whole, this particular matrix is a ring. Now our work is not to prove whether M2 is a ring or not. Maybe this set of statement or this example might help you in some other question. That's why I am giving you this detail. Here we have another term called subring. So what is a subring here? The subring S of a ring R is a subset of R. So when we say set subset, we know what is the meaning. Group subgroup, we know what's the meaning. Similarly, ring subring is also the same way. Subset of R that is itself a ring under the same operations as R. It means whatever R can do, S should also be able to do. Then only it can be called as subring. So when you say S is a subset of R, this can be taken as a subring if it has 4 characteristics. It should be non-empty. It means S must contain at least one element. It can usually be the 0 element. It is closed under addition. So when there are two elements A and B, A plus B should also belong to S. It must be closed under additive inverses. So if A belongs to S, negation of A will also be belonging to S, or you can say minus A directly. Then we have closed under multiplication. If A and B are two elements, then A into B, the product should also belong to S. If you have all these 4 properties, then we can say S is a subring of M2 of Z for this particular problem. So here they have given the S is a subring of the ring. I am just trying to tell you what is a ring and how S becomes the subring. So this is the context of the question. Now we are getting into the main part, the options. What is idle? Idle is a special subset of a ring. So it's a subring as per the question, but idle is, it's again a subset but a special subset that absorbs multiplication from elements of the ring. What is absorbs multiplication? You cannot take the plain meaning, but if you apply the plain meaning, that is only true. What is left idle? S is a subset of the ring M2 of 2 cross 2 matrix. This is called left idle if it is closed under addition. If we take any two matrices, 2 cross 2 matrices A and B, and when you do addition, you should end up with the elements that belongs to S. The next property is it absorbs multiplication from the left. So here they said it's absorbing multiplication. So here it is from the left. So for any R, for any matrix that belongs to M2 of Z, and for any matrix that belongs to this particular S, the multiplication of R into A belongs to S. So this is belonging to the main ring and this is belonging to the subring. The main ring into subring multiplication should belong to the subring, they say. Only then we can conclude it is left idle. What about right idle? The same case with right side multiplication. This subset is right idle if it is closed under addition and it absorbs multiplication from the right. So here R will be placed in the right side. A into R belongs to S. In a ring of 2 cross 2 matrices, the set of matrices with 0 second column can form a left idle. I will give you with respect to this example itself. 0 second column means this one, and you can have any entries like this. This can be called as left idle. In the same matrix ring, the set of matrices with 0 second row can form a right idle. It means when you have 0 second row, this becomes the right idle. Now just understand only these two statements. Does the matrix listed in the question have this particular format? No. From this itself you can mark it is neither left idle nor right idle. We can mark option number 4 as the right answer. S is not a left idle or right idle of M2 of Z. So the question itself is not a left or right idle. Since multiplying by general matrices introduces off diagonal entries, the given matrix is diagonal matrix. Only the diagonal elements are filled here. Matrix in S must be diagonal means the off diagonal entries must be 0. Only then A into R and R into A can belong to the subring or the capital S matrix is what they say. We will take the addition property first. Let's take two matrices A and B. A can be taken as A0, 0B and B can be taken as C0, 0D. So when you want to add A plus B, what happens here? A plus C will come here, 0 plus 0 will stay here, 0 plus 0 will stay here, B plus D will be coming here. Is the diagonality preserved here? Yes, it is preserved. One property is true. It is closed under addition. Now we have to check for multiplication. So the first multiplication we have to check is R into A. So let this be any ring matrix that contains integer. I am going to place it as 0, 1, 0, 0. They say A belong to S. So we will take this capital A to be the same matrix that is given in the question, A0 and 0B. What is R into A? Now we have to multiply and check. R into A will be 0 into A is 0 plus 1 into 0. Then for the second column 0 into 0 plus 1 into B. So how will you do multiplication? 0 into A plus 1 into 0, then 0 into 0 plus 1 into B. So the first row with the first column and the first row with the second column. Now we will go for the second row and first column. This will be 0 into A and 0 into 0. And now the second row with second column, 0 into 0 plus it is 0 into B again. What you will get is 0 plus 0 will give you 0. 0 plus 1 into B is B. Here also you will have 0. Here also you will have 0. Now do you get a matrix that is similar to capital S that is given in the question? No. What did they say? The matrix in S must be diagonal. Is this a diagonal matrix? No. When the multiplication does not follow this particular property, we can say it is not left idle. Now we will check for right idle. So we will place A first. It is A0, 0B. Then we will place the same R. Now we will go for A into R. It is A into 0 plus 0 into 0. So the first number here it will be 0. Then we will have A into 1 plus 0 into 0. So here we will have A. Then we have 0 into 0 plus B into 0. It is 0 here. Then 0 into 1 plus B into 0. This is also 0. So is this matrix a diagonal matrix? No. So this is not right idle 2. So we can prove it in this way. Only when the elements are diagonal, that means only when the off diagonal entries are 0, we can say A into R belongs to S or R into A belongs to S. Here they don't belong to S and here also they don't belong to S. So remember the general format. When you want a matrix to be left idle, how should the matrix be? It should be in the form of 0 second column. So any entry can be coming here. What about right idle? It is 0 second row with any element in the first row. So unless you have the matrix in this form, there is no possibility to make it left idle or right idle is what I wanted to say. Next question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. The order of the group Z5 under multiplication divides the order of the group Z13 under multiplication. This is the assertion. The reason is the order of a subgroup of a group divides the order of the group. So we have to solve this now. Zn usually means the set of integers under modulo n. So we have already discussed the example for Z5 and Z6 in the previous question. So what does Zn contain? It contains the number 0, 1, 2 up to n minus 1. When it was Z5, the numbers were from 0 to 4. When it was Z6, the numbers were from 0 to 5. So n means n minus 1. That is the limit here. But for a group under multiplication, we cannot include all of Zn because not every element has a multiplicative inverse. It means when you multiply two elements and find the modulo, it should result in 1. So take only the units modulo n, that is the numbers that are co-prime to n. Only then you will have the possibility of getting 1. This set is called Zn under multiplication. So this is what is defined here as the group Z5 under multiplication. Now we have to find the order of the group. Order means it is the number of elements of that particular group under multiplication. So this is given by Euler's totient function. This totient function is the number of integers between 1 and n that are co-prime to n. So what is co-prime here? Co-prime numbers are a pair of numbers that have only one factor in common, which is 1. Phi of n is equal to n minus 1 when n is prime, because every number 1, 2, till n minus 1 is co-prime to n. When you take 1 and 5 it is co-prime, 2 and 5 it is co-prime, 3 and 5 it is co-prime, 4 and 5 is also co-prime. This is what they say, any number and its co-prime. So this is for the case where n is prime. When you take n to be 6, a non-prime number, 2 and 6 will have a common factor 2 other than 1, 3 and 6 will have a common factor 3 other than 1, 4 and 6 will have common factor 2 other than 1. So there are possibilities for having factors other than 1 in case of non-prime. That's why they have specified it as if n is prime. Now why are we learning all this? They have told the order of the group Z5 divides the order of the group Z13. So we have to find the order of Z5 group now under multiplication. Since 5 is prime, we can apply this phi of n formula. Phi of n is equal to n minus 1, 5 minus 1, which is equal to 4. And what about Z13? Since 13 is also prime, we can go with 13 minus 1, which is equal to 12. So here we can have 5 and here we can have 13. So the order of Z5 group will be 4 and the order of Z13 group will be 12. Now exactly translate this. 4 divides 12. Is it true? Yes, it is true. So 3 into 4 will give you 12. 2 into 6 will give you 12. So definitely 4 is a divisor of 12. So in that way we can say 4 divides 12 is true. So instead of seeing this as a complete statement, order of group divides order of group, you can take this as 4 divides 12. That's all we need to find. What about reason? The order of a subgroup of a group divides the order of the group. This is Lagrange's theorem. The statement is, if H is a subgroup of a finite group G, then H divides G. That is, order of H divides order of G. Is this the same statement? There is a small change. They have given of a group. So when you take groups, there are two kinds of groups, finite groups and infinite groups. Regarding mathematics, every word is important when you are generally listing something. When you say it's a finite group, it is restricted to finiteness. When you say it's infinite group, then it is restricted to infinite. But when you generalize it to be a group, both the qualities or both the characteristics are included. It means it must include both finite and infinite. But this theorem is stated only for finite group. From this we can say the statement fails if the group is going to be infinite. So we cannot generalize this statement to be true without knowing what kind of group they have mentioned. So R is not correct. R is false. So what will be the answer? A is correct, R is not correct. Option number 3 will be the right answer. So the question is ending here. Now we will go for an extended learning. Now R is going to be right. They are going to say R is applied only for finite group. If that is the case, R will become correct. Now we have to check whether R is the correct explanation of A. There is no subgroup relationship asserted between them. Z5 is not a subgroup of Z13. They say the order of the group. No subgroup is mentioned. That's what they say. No subgroup relationship is given. Lagrange theorem does not apply across unrelated groups. It applies only between subgroup and the group. So Z5 and Z13 are unrelated. Now our work is to say that both are unrelated. Elements of Z5 will be 1, 2, 3, 4. We have to take only the non-zero elements. Elements of Z13 will be 1, 2, 3 up to 12. There are common elements 1, 2, 3, 4. But the operations are different, they say. So we can conclude Z5 is not a subgroup of Z13 under multiplication. What is this? Operations are different. I'll just give you some example. If you take under Z5 in multiplication, 2 into 3 will give you 6. What is 6 mod 5? This will result in 1. So 2 into 3 will result in 1. You got this? Now we will go for Z13 under multiplication for same 2 into 3. 2 into 3 will give you 6. 6 mod 13 is again 6. So they say the operations are different because you are going to take the mod value under two different prime numbers. So you can never say they are a subgroup. So even if R was given right, R cannot be the right explanation of assertion A. But as for this question, R is not correct is the right answer. Only A is correct. Next question. Given below are two statements. One is assertion and the other is reason. What is the assertion? Let R be a binary relation as defined below. So what is this A here? N cross N. It means natural numbers. A comma B, C comma D belongs to R if and only if A is less than or equal to C or B is less than or equal to D. This binary relation R is a partial order. What about the reason? A binary relation will be a partial order if this satisfies reflexive, antisymmetric and transitive property. So what is a partial order relation? When it satisfies reflexive, antisymmetry and transitive, it is called partial order. So reason is definitely correct. We will go with true. What about A? We have to work it out. This is a gate question. What is the condition given here? A less than or equal to C or B less than or equal to D. There can be a case where A less than or equal to C and B less than or equal to D. There is a difference between approaching and or here. Let me tell you the difference. And means all conditions are satisfied where you have to prove it is a partial order. It means definitely you will have reflexive, antisymmetric and transitive properties. When we say antisymmetric, definitely we will say x is equal to y. It must be proved. When they say in mathematics, prove something, it is definitely true. That is what and specifies. What about this or? Or means at least one condition is satisfied. When the operation is or here, we have to test whether it's a partial order. It means we can use one counter example that works against it and disprove that the given relation is not in partial order. Regarding this particular relation, it is reflexive but antisymmetric property fails. Once this particular property fails, we can say it is not a partial order. And regarding transitivity, it can hold true for some cases. Again, it is not guaranteed for all. If the condition was given as and, you must prove it. If it is or, you have to disprove it using one counter example. So let's start with reflexivity property. So let's take a comma b that belongs to R. As we have here x comma x belong to R. So how can we take this? A is less than or equal to A, B is less than or equal to B. So this particular property is true because we have A equals A, B equals B here. Now we will go for antisymmetry. We will have two pairs here, A comma B and C comma D. This belongs to R. What does this mean? A is less than or equal to C and B is less than or equal to D. This is X relation Y, and for Y relation X we can keep it as C comma D, A comma B belongs to R. This means C is less than or equal to A and D is less than or equal to B. Under what condition this will be true? If A is equal to C and B is equal to D, this can be true. Otherwise it is false. Now what is this particular A cross A? It is a part of natural numbers. Natural numbers means I can put any numbers there. My work is to give a counter example and say that antisymmetry property is false. So let me take A comma B to be 1 comma 5 and C comma D to be 2 comma 4. Are A and C equal here? B and D equal here? No. Just check the property. 1 is less than 2 or 5 is less than 4. It is true. What about 2 comma 4 and 1 comma 5? 2 is less than 1 or 4 is less than 5. So this particular part is true only since the condition is either or. At least one condition got satisfied here. It is fine. But are A and C equal? 1 is not equal to 2 and 5 is not equal to 4. So antisymmetric property fails and reflexivity alone holds. Once one of the three property fail here, automatically you can say it's not partial order. So definitely we can mark A to be wrong. So relation R cannot be partial order. So A is not correct but R is correct. Option number 4 will be the right answer. So let me even do it for transitivity so that I can give you a counter example. Let's take A comma B and X comma Y. This will be A less than or equal to X and B less than or equal to Y. So this R will be retained here everywhere. And what about the next one? X comma Y and C comma D. This implies X is less than or equal to C or Y is less than or equal to D. Now just take the relation alone. This is given as A less than or equal to X is less than or equal to C, or B is less than or equal to Y is less than or equal to D. So from this what we can say? A comma B, C comma D can be expressed as A less than or equal to C or B less than or equal to D. So A is less than X but X is less than C. So from this itself we can say A is less than C. Now we will have a counter example. Let's take A comma B to be 5 comma 5, X comma Y to be 6 comma 4 and C comma D to be 3 comma 3. So ultimately 5 is greater than 3 and 5 is greater than 3. At both the stage it is getting failed. When you apply any natural numbers for A, B, X, Y and C, D, it is not guaranteed. It is true for all cases. Take a bridge. And operation means it's like building a strong bridge. So we have to say every beam is strong. Without the beam being strong, you cannot build a bridge. Or is like checking for water leakage. Even if you find a small hole, you cannot say it is waterproofed. So in that way, in OR we have to go for counter example, and in AND somehow we have to prove it. Since the question is talking about OR, we are saying it is of not partial order. If the question was with AND, we can say it is partial order. Next question. This is a repeated question from NET previous year question. Which of the following statements are true if universe of discourse for all variables consists of all integers? So we are restricting to integer here. The first statement A. For all n, there is a m where n square is less than m. No matter how large n can be, for every n we can always find a m that is bigger than n square. So when they say n square less than m, we can take it as m is equal to n square plus 1. At least a number will be bigger than that. We don't have limit for integers. So always there will be a number is true only. So A is definitely true. What about B? There is a n value and there is a m value for which n plus m is equal to 4 and n minus m is equal to 2. We can take 3 plus 1 is equal to 4 and 3 minus 1 is equal to 2. So this will be n and this will be m. So there is a combination available and the quantifier used here is existential, which means even if one value is true, you can mark it true. This has a solution over the integers n is equal to 3 and m is equal to 1. So this statement is also true. What about C? There is a n value, there is a m value, n square plus n square is equal to 5. So roughly we can say 1 square plus 2 square is equal to 1 plus 4 which is equal to 5. Since we have existential quantifier here, definitely C is also true. It has a solution over the integers. This is true and there are 8 solutions. How there are 8 solutions? When n is equal to plus 1, you can have m is equal to plus 2, m is equal to minus 2. When n is equal to minus 1, you have m is equal to plus 2 and m is equal to minus 2. M is equal to 1 and m is equal to minus 1, then n is equal to 2. So this will be 2 comma 1 and 2 comma minus 1. What about n is equal to minus 2? Here we will have m is equal to 1 and m is equal to minus 1 again. 1, 2, 3, 4, 5, 6, 7, 8 solutions are available. Next we will go for D. There is a m value for all n such that m plus n is equal to 0. The meaning of this particular expression is only one value is there for all other value is what they say. There exists an integer m such that for every integer n, m plus n is equal to 0. It means this m will stay the same and n will alone keep changing. When you want to bring 0 in addition, only when you have the negated value there is a possibility. Say for example, for 1 you should have minus 1, for 5 you should have minus 5. If you take only minus 1 for all the numbers, it is difficult to bring it to 0. If m plus n is equal to 0, then m is equal to minus n. So they are rewriting this equation for all integers n. For n is equal to 1, m is equal to minus 1. For n is equal to 2, m is equal to minus 2. This is false. M will differ for every n is what they say. Definitely D is going to be false. You have to interpret the expression in the right way, else you might make a mistake. What about E? For all m, there is a n. It is not about m or n, it is about existential universal order here and universal existential order here. Now the meaning is correct. For all m, we have a n. It means for every m, the n will be different. This is possible. For every integer m, there exists an integer n such that m plus n is equal to 0. So here we can say this is true because for any integer m, we can simply choose n is equal to minus m. The example that they have given in D statement is what you can apply here. This order of quantifier has to be interpreted in the right way, otherwise you might mix up D and E. Here E is definitely right. See, they have given one answer option with D and one with E. If you make a mistake in interpreting the meaning, this question is gone. So you can look at the mathematical logic playlist in CS Connect series available in this channel. It is available in English. Please do watch those videos and understand how to find the meaning of the expression. So the answer will be option number 3, A, B, C and E only. Next question. Which of the following logical implications are tautology? It means when you solve this particular expression, you should end up with true value. If you have learnt about rules of inference, there is one inference that is mentioned in one of the options. It is C. C is a form of modest ponens. P and P implies Q. It means if P is true and P implies Q is true, then Q must be true. We have seen about this rules of inference in unit outline videos as well as in rules of inference videos from CS Connect series mathematical logic playlist. So if you want to know about rules of inference, if you want to have real examples, you can watch those videos. So as of now, we know C is true. In the examination hall, if you know C is true from modest ponens rule, then you can rule out 1 and 2 from the answer list. What you can do to save your time is, taking C to be the right answer, check A and D alone. So if you want to check A, you go with A. Find whether it's a tautology or not. If it is a tautology, then option number 3 will be the right answer. If it is not a tautology, then you can go with option number 4 as the right answer. In case if you start with D, the same case. If D is a tautology, then mark option 4 as the right answer. If not, mark 3 as the right answer if you know C is the form of modest ponens. If you have that idea, just by solving only one logical implication, you can complete this question. This strategy can be followed in the examination hall, but this strategy I cannot follow here for solution videos. So I will start solving from A. Let's take A. So we have an expression here inside the square brackets, negation of P and P or Q. First we will try to reduce this and then we will apply implies operator. So this can be taken as negation of P and P. We are going to apply this inside the distributive law. We will keep disjunction outside. Then this will be negation of P and Q. So what is negation of P and P? It is false. So false or something will be this something only. So we will go with negation of P and Q. Now we will take the complete expression. Instead of this, we have solved it to negation of P and Q. So we can take it as negation of P and Q implies Q. Now you have to apply the implication formula. What is P implies Q? Throughout all the implications you are going to apply this. So this is negation of P or Q. So here this is the P term completely and this is the Q term. So you are going to negate it and then apply the expression completely. You have to use disjunction and then bring Q here. Now we will apply negation inside. Negation of negation P. Negation of conjunction will turn to disjunction and then we will apply negation of Q. Then again disjunction Q will be from here, it will be retained as it is. What is negation of negation P? It is P. Then we have disjunction negation of Q or Q. This particular expression will be solved to true. Say for example, if this is going to be 0, then this will be 1. If this is going to be 1, then this will be 0. So 1 or 0, 0 or 1 will give you 1 only. So this will be P or true. Anything with true will give you true only. So here A is definitely a tautology. C is already modest ponens. We have found that A is a tautology. From this itself we can mark option number 3 as the right answer, just based on this modest ponens rule. Now we will go with B expression. This is negation of P implies Q. When you have square brackets like this, then you can go solving it first and then apply the implication. Here you don't have square brackets, so we can directly use P implies Q. Now this is going to be P and the whole expression is going to be Q. So here we will have negation of negation P. So I am going to negate the P part, turn this as disjunction, and the Q part will be staying as it is. Now I have to apply negation of negation P. This will give me P or P implies Q. What is P implies Q? It will be negation of P or Q. So P or negation of P or Q. What is this? It is true. So true or Q will give you true again. B is also a tautology. So this is a tautology. This is also a tautology. So let's go for C. We have an expression in square brackets. P and P implies Q. Now we will solve this first. P and negation of P or Q. Now we will apply the conjunction inside. This is P and negation of P or P and Q. What is conjunction of 0 and 1? It is going to give you 0 only. This is false or P and Q. So ultimately you will have P and Q expression alone. So this particular expression is now P and Q. Then you have an implication with Q. So this will be implies Q. So understand, I am just solving this particular square bracket first, reducing it and then applying the implication as we did for A. Now we will apply P implies Q formula directly. So this will be negation of P and Q or Q. Now negation will be applied inside. Negation of P, conjunction negation will become disjunction. Then we have negation of Q or Q. So what is this? This is true. So negation of P or true. Anything or true will give you true only. Here also it is ending up with true, so C is a tautology. Now definitely we know D is false. Now we will find how it is false. Let's take the expression negation of P implies Q. We will take the complete term as P and this one as Q. So this is negation of negation P implies Q or Q. Negation and negation will become P implies Q or Q. Now this will be negation of P or Q, this part. Then again or Q will stay as it is. What is 1 or 1? It is 1 only. 0 or 0 is 0 only. So here we can take it as negation of P or Q. It is not ending up with true value, so this is not a tautology. Next question. If Kn is complete simple graph of n vertices and Km, is complete bipartite graph, then arrange the following non-planar graph in ascending order on the basis of the number of crossings. Non-planar graph means you cannot draw the graph without edges crossing it. So definitely crossing edges will be there. In planar graph, we will be drawing the same graph without edges crossing. So they have clearly given it as non-planar graph, and now they have asked us to calculate the minimum number of crossing and then arrange those values in ascending order. So this Kn is for complete simple graph and this Km, n is for complete bipartite graph. In graph theory, the crossing number of a graph is the minimum number of edge intersections. So when you draw edges between vertices, if there is intersection of edges, then we call it as crossings. So this minimum number of edge intersection is what we call as crossing number. So we have to find the crossing number. There is a formula for simple graph as well as for bipartite graph. Complete graph Kn where n is less than or equal to 10. We have the formula crossing of Kn is equal to 1 by 4 into floor of n by 2, floor of n minus 1 by 2, floor of n minus 2 by 2 and floor of n minus 3 by 2. All these terms will be multiplied together. What about bipartite graph? Km, n. The crossing of Km, n is equal to floor of m by 2 into floor of m minus 1 by 2 into floor of n by 2 and floor of n minus 2 by 2. While solving this, you have to be careful with the floor values. Then there is a value called 5 by 2 and there is a value called 4 by 2 in floor. You have to directly not cancel these values thinking that it is multiplication. This is wrong. When floor symbol is given separately, what you should do is you have to solve this first. 5 by 2 is 2.5, floor of 2.5 is 2. 4 by 2 is 2, floor of 2 is 2. You have to bring it to this format only and you should not do it in this way. You cannot directly cancel it with the floor symbol. There is a possibility of doing this mistake in angiousness. That's why I am telling you here. Now let's solve it. A will be K6. K6 is equal to, we have to go with this particular formula, 1 by 4 into floor of n is 6 here. So it is 6 by 2. 6 minus 1 is 5 by 2. Then we have 6 minus 2, so it is 4 by 2. Then we have 6 minus 3, it is 3 by 2. Now 1 by 4 will be taken as it is. 6 by 2 is 3, floor of 3 is 3. Only when we have decimal point we have to go for floor, otherwise a simple division will be more than enough. 5 by 2 is 2.5, so floor value will be 2. 4 by 2 is 2. 3 by 2 is 1.5, so the floor value will be only 1. So here it is 2.5. Now we can cancel. 2 2s are 4, it will get cancelled and the value of K6 will be 3. So we will mark here as 3. Then we will go for K7 which is B. K7 is equal to 1 by 4 into floor of 7 by 2, floor of 7 minus 1, 6 by 2, floor of 7 minus 2, 5 by 2, floor of 7 minus 3, 4 by 2. 1 by 4 into 7 by 2 is 3.5. The floor value is 3. Then we have 6 by 2 which is 3. Then we have 5 by 2 which is 2. Then 4 by 2 is 2. Again we can cancel 2 2s are 4. So 3 into 3 will give you 9. K7 will have a value of 9. Next we will go for C. C and D are bipartite graphs. So K4, 4. M is equal to 4 and N is equal to 4. The formula will be floor of M by 2. Here M is also 4, N is also 4. So we need not confuse much. M by 2 is 4 by 2. Then m minus 1 by 2 will be 3 by 2. Again for n we have n by 2 and n minus 1 by 2. So again we will have 4 by 2 then 3 by 2. 4 by 2 is 2, 3 by 2 is 1 with floor, 4 by 2 is 2 and 3 by 2 is 1 with floor because we will generate 1.5 out of this division and we have to make it to 1. What is 2 into 2? It is 4. So we will write the value 4 here. Then we will go for D. This is K 5, 5. M is equal to 5 and N is equal to 5. So this will be 5 by 2 in floor, into 4 by 2 in floor. Similarly, floor of 5 by 2, floor of 4 by 2. 5 by 2 is 2.5. So we have to take the floor value as 2. 4 by 2 is 2. 5 by 2 is 2. 4 by 2 is 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16. 16 will be the value for D. Now arrange it in ascending order. 3, 4, 9, 16. 3 is A, 4 is C, 9 is B and 16 is D. Option number 3 will be the right answer. Next question. Arrange the following prefix expressions in ascending order on the basis of their values. How will we evaluate this? We have to start from the rightmost side of the expression. So take the expression like this. This is right side and this is left side. We have to start from this end. If it is an operand, we have to push it onto a stack. If it's an operator, we have to pop two operands from the stack, apply the operator and push the result back to the stack. So let's take plus 1, 2. When it is an operand, you have to start this way. So 2 you will be pushing, then 1 you will be pushing. When it is plus, you will pop out these two. 1 plus 2 which is equal to 3. Then the result will be pushed back to the stack. This is how we will be doing prefix expression evaluation. Here instead of having top to bottom stack, we will use left to right stack so that it will be easy for us to calculate everything in a single screen. Earlier I showed you for the same question top to bottom stack as well as the horizontal representation. This time we will completely do it horizontal representation. We will start with A now. So let's start from the rightmost side. We have 3, we have 4, we have 8, then we have division symbol. Once you have division symbol, you have to pick two operands. So when you find the symbol, just take these 3 alone together. What is 8 divided by 4? This is equal to 2. So 2 is here. The rest of the cells will be as it is. Now where is the operator? It is here. So you have to pick two operands. What is 2 into 2? It is 4. So we will have 4 here. What about minus operator? We have 4 and 3 as operands. 4 minus 3 will give you 1. A's expression will be evaluated to 1. Next we will go for B. Where is the operator from the rightmost side? It is here. So we have to pick these two operands. 4 into 2 will give you 8. Now again you have only operands here. Here is the operator. So you have to pick these two. So 3 and 6 in multiplication. 3 into 6 is 18. So we have 18 here. Now for the minus, we have two operands. 18 minus 8 will give you 10. So this is 4 into 2. This is 3 into 6 here. And this is 18 minus 8. Now we have 10 power 5. So whenever you see this particular arrow mark in the up direction, you have to take it as the exponent operator. So this is power. This can be taken as 10 power 5. 10 power 5 is 1 lakh actually. So this is 1 lakh. They are asking for ascending order based on the evaluated values. So for that only we are making note of this. So this can be taken as 10 power 5 itself, or you can change it to 1 lakh. Now we will go with C expression. Find the operator from the right side. It is minus. So we are picking 4 minus 2. It was 2. Then we are picking division operator. 6 divided by 2 will give you 3. We have 3 here. Then we are picking exponent operator. 2 power 3. 2 power 3 will be 2 into 2 into 2, which is equal to 8. Now we have 3 power 2. This is 3 square, which is equal to 9. Now we have minus between 9 and 8. What is 9 minus 8? It is 1. What is 1 plus 3? It is 4. The answer for C will be 4. Let's get on to the final D expression. Here we have the operator, so we will pick only the next two operands. What is 1 plus 1? It is 2. Now we have exponent operator here, so we are picking these two operands. So this will be 3 power 2. What is 3 power 2? It is 9. Here it is 1 plus 1, which is equal to 2. So 3 power 2 is 9. Then we have plus operator along with two operands. What is 9 plus 3? It is 12. Then again we have plus operator for 3 and 12. So 3 plus 12 will give a value of 15. We have 15 here, and the last rightmost operand has not been used till now. So we have multiplication operator. Altogether this is 15 into 3, which is equal to 45. So the D value will be 45. Now let's arrange it in order. 1 for A, 4 for C, 45 for D, and 10 power 5, which is 1 lakh, is for B. The order is A, C, D, B. Option number 2 will be the right answer. Next question, match the list 1 with list 2. Boolean identities are given. In discrete mathematics books, you have Boolean algebra content. In that, we have Boolean identities along with their names. So let's first match them. Where is domination law? It is here. This will be A. Associative law is here. Distributive law is here. Absorption law is here. Now what is domination law? X plus 1 is equal to 1. The Boolean value is getting dominated here. So A will be mapping to 1 in list 2. Then for associative law, we are going with X plus Y plus Z with braces here, which is equal to X plus Y. Then Z under addition. This associativity is found in list 2 4. A1 B4 is available only in this particular option. For C, distributive law, they have given X plus Y Z. This is X plus Y into X plus Z. C will be mapping to 2 in list 2. Then for D, we have absorption law. X plus XY is equal to X. So this will be list 2 third one. So D will be mapping to 3. So what is X plus XY? We will take this X outside. It is 1 plus Y. What is 1 plus a variable? It is 1 only. So this is how we are bringing it to X. So option number 2 will be the right answer. Next question, match the list 1 with list 2. List 1 has name of the methods while list 2 has the problem type. This part is taken from optimization part of the unit 1. Every problem type has different methods of solving it. Let's start with list 2. Integer programming problem can be solved using branch and bound method, cutting plane method, Go-Morris method. For integer cases, we can apply dynamic programming too. A maps to 1. Then we have transportation problem. In that we have northwest corner rule, least cost method, Vogel's approximation method. If you have learnt about transportation problem, definitely you must have come across these 3 methods. So whenever you take transportation problem, when you just convert into cost matrix, the north-west part, if this is north and this is west, you have to start from this particular cell, they will say. This is one way of solving. Least cost means among all the cells, whichever has the least cost, from that cell you have to start solving. That's how the methods have come up. Based on where you start, these methods will have different names. Apart from these 3 methods, we have modified distribution method and stepping stone method. So northwest corner rule is the method for solving transportation problem. B will be mapping to 3. A1, B3 is available only in one option. Actually, if you are not used to quadratic programming problem or nonlinear programming problem, if you have idea with integer programming and transportation problem, you can complete this match is what I am trying to tell you. Now we will get on to the next problem type. It is quadratic programming problems. We have Wolf's modified method, Belay's method, interior point methods, active set method. Quadratic problem is solved by Wolf's modified method, which is in D. So D will be mapping to 2 here based on this. Then the final problem type will be non-linear programming problem. We have Lagrange multiplier method, Kuhn-Tucker conditions, KKT method, gradient descent method, Newton's method, penalty and barrier methods. So based on this we can conclude C will be mapping to 4, D2, C4 is here. Option number 2 will be the right answer. Now we have to learn about the list 1 terms and the list 2 terms. So we will start learning. Integer programming requires solutions where variables must take integer values. Branch and bound systematically explores subsets of solutions by branching into smaller problems and bounding their possible values. If a branch cannot lead to a better solution, it is discarded. We will be forming nodes after nodes, and whichever is fine we will be traversing the same route. Similar to branch and bound mechanism in data structures and algorithms, here also we have. The next learning will be on transportation problem. This deals with minimizing cost of distributing goods from sources to destinations. The northwest corner rule is a simple heuristic that starts allocation from the top left, as I told you earlier, the northwest cell of the cost matrix, and proceeds step by step until supply and demand are satisfied. The next will be non-linear programming. We are just going by this particular order. Non-linear programming involves optimizing functions that are not linear, often subject to constraints. Lagrange multiplier method introduces auxiliary variables to transform constrained optimization problems into unconstrained ones, making it easier to find maxima or minima. Why am I giving you these terms is next time the terms can be involved. Say for example they can ask which problem will have supply and demand satisfaction. Then you can mark transportation. They can ask where is maxima minima used. You can use it in non-linear programming. Any term or any statement can turn out to be a question. The final one is quadratic programming. This deals with optimization problems where the objective function is quadratic and constraints are linear. Wolf's modified method is an iterative algorithm designed specifically for quadratic programming. This improves efficiency compared to general non-linear methods. If they ask you which is the most efficient method in quadratic programming and they give you 4 methods, you should be able to mark it as Wolf's modified method after this particular learning. With this we are completing Unit 1 solutions. Let's solve Unit 2 questions. Arrange the following events in correct order when an interrupt occurs during instruction execution. Save program counter and status register. Fetch interrupt vector from memory. Execute the interrupted instruction completely. Transfer control to interrupt service routine. Restore PC and register after interrupt service routine. This question is not new. This is a previous year question. The statements that have been used are taken from different sources. So the first step will be execute the interrupted instruction completely. So the CPU must be doing some work. It has to complete it first before it responds to the interrupt. Most architectures ensure the current instruction finishes before servicing the interrupt. This avoids leaving the CPU in an inconsistent state. The only option that starts with C is option 3. The next step will be save program counter and status register. It is A. Context saving is essential so the CPU can resume execution later. The PC, the program counter, points to the next instruction and status flags preserve mission state. It has to finish the work it is doing, then it has to save the program counter and the status register. After that, it will be fetching the interrupt vector from memory, which is B. The interrupt vector provides the address of the interrupt service routine. This is often stored in a predefined table. And after that step, the control is transferred to the interrupt service routine. The CPU jumps to the ISR address and begins execution of the handler routine. So this will be D. And the final step will be restore program counter and registers after the interrupt service routine. Once the ISR finishes, the saved context is restored. Execution resumes from where the program was interrupted. Only the current instruction or the interrupted instruction will be executed completely. The program counter is going to point out the next instruction. So that will be saved. And that part is what they say it will resume from where the program was interrupted. So the order will be C, A, B, D, E. Option number 3 will be the right answer. Next question. Which of the following are characteristics of RISC architecture? Again, this question is not new. This has been asked in the previous year question paper. The concept of RISC architecture involves an attempt to reduce execution time by simplifying the instruction set of the computer. Let's see the characteristics one by one. They are asking which are the characteristics of RISC. Large instruction set with many addressing modes. It is actually addressing modes. Fixed instruction length. Emphasis on software rather than hardware. Simple instruction that execute in one cycle. Based on the particular statement that we saw just now, we know D is definitely there in the answer, but there are 3 options involving D. So we will just see statement by statement. Let's start with A. Large instruction set with many addressing modes. This is the characteristic of CISC. So RISC will be reduced instruction and CISC will be complex instruction. So here RISC uses a small simple instruction set with limited addressing modes. Since we have come to CISC, we will just learn about CISC. What are the other major characteristics? A large number of instructions, typically from 100 to 250. Some instructions that perform specialized tasks and are used infrequently. A large variety of addressing modes, typically from 5 to 20 different modes. Variable length instruction formats. So from this we will know B is also true. Then instructions that manipulate operands in memory. So these are the major characteristics of CISC architecture. So now we will get on to B statement. Fixed instruction length. This is true. RISC instructions are typically of fixed length, which simplifies decoding and pipelining. So B is definitely true. The moment you come to know that A is not a part of the answer, at that time itself you can rule out option 1, 3 and 4 and conclude option number 2 will be the right answer. So what about C? Emphasis on software rather than hardware. RISC shifts complexity to the compiler or software, keeping hardware simple and fast. The next characteristic, simple instruction that execute in one cycle. RISC instructions are designed to execute in a single clock cycle, enabling efficient pipelining. So B, C and D are definitely the characteristics of RISC architecture. What else are there? We'll just go through. RISC processor has relatively few instructions, relatively few addressing modes, memory access limited to load and store instructions, all operations done within the registers of the CPU, fixed length easily decoded instruction format, single cycle instruction execution, hardwired rather than micro-programmed control. What is the meaning of the 7th characteristic? Hardwired control is faster and simpler, which is actually stating that keeping hardware simple and fast. By using hardwired control, RISC avoids complex hardware-based microprogramming. That is what we call as microprogrammed control. So here they say hardware is simple and fast, and hardwired control is faster and simpler. This is the point that we have seen in statement C. So just have a comparison. Here there are large number of instructions, here it is few instructions. Here the addressing modes are more, here it is few. The memory is limited to load and store instruction here. Here some instructions perform specialized task they have given. The fixed length instruction format and the variable length instruction format. So all are single cycle instruction in RISC and all the operations are done within the registers of the CPU. Here instructions that manipulate operands in memory is the characteristic of CISC. So already you must have learnt about the comparison of RISC and CISC. Just go through them while you are revising in the last month of the examination so that these points will be retained in your mind. Next question, given below are two statements. One is labeled as assertion and the other one is reason. What is assertion here? Instruction pipelining improves CPU throughput. Pipelining allows multiple instructions to be overlapped in execution. So that is the use of pipelining. This will increase the number of instructions completed per unit time. This is what we call as throughput. So definitely pipelining is improving CPU throughput because they have given it will increase the number of instructions completed per unit time. A is definitely correct. Now let's go for reason R. Pipelining decreases the execution time of each individual instruction. Pipelining does not reduce the execution time of a single instruction. Each instruction still takes the same time to pass through all the stages. The overall throughput is improved, not the per instruction latency. Latency means the delay. So here we know reason R is wrong. A is correct but R is not correct. Option number 3 will be the right answer. Next question. From here, all these 5 questions are dependent on this particular passage or this particular context. So let's read the passage. A system transfer data blocks of 2000 bytes with programmed input output. So this 2000 bytes is with respect to programmed input output where each byte transfer takes 6 CPU cycles. This is also with respect to program input output. Now let's pause here. With direct memory access, the block transfer takes 3000 cycles in total. With CPU setup overhead of 200 cycles. Whenever DMA is involved, you will have the CPU setup part. Additional cycles will be there. So this part is DMA. The CPU clock is 1 GHz. Answer the following 5 questions based on this paragraph. These are not really complicated questions. They are very simple questions. The only thing is we have to know how to solve it. That's all. So let's solve it now. How many CPU cycles are spent using programmed input output? Programmed input output requires the CPU to handle every byte transfer directly. The block size is given as 2000 bytes. In programmed input output, as per the question, each byte transfer takes 6 CPU cycles. So the total CPU cycles is given by number of bytes into cycles per byte. So what is the number of bytes here? It is 2000 bytes into cycles per byte. It means each byte transfer is taking 6 CPU cycles. So here it is 6 cycles per byte. So byte and byte will go and we have 12,000 cycles in total. This will be the answer. Option number 3, 12,000 will be the right answer. This is a simple multiplication. I have just done it along with the units to make you understand how we get cycles as the unit. That's all. If you don't wish to go with unit for these 5 questions, well and good. Just multiply 2006 and say it is 12,000. Next question. How many CPU cycles are spent with DMA? The story of DMA is different. Programmed input output is where heavy CPU involvement will be there. But in DMA, there will be minimal involvement of CPU. Minimal CPU overhead with faster block transfer. Overhead means the extra CPU work required to set up and manage the DMA transfer. The CPU doesn't move each byte as we saw in programmed input. It doesn't happen in DMA, but it has to configure the DMA controller. It means once the particular setup is over, for that only CPU will be working. After that, the control will be totally given to the DMA. The question here is, how many CPU cycles are spent with DMA? How far the CPU is going to work in DMA? So I said until the setup only it is going to work. After that, the control will be going to the DMA. The CPU only spends 200 cycles, that too for the setup they have given. Setup overhead of 200 cycles as given in the question. The 3000 cycles that are mentioned for DMA are consumed by the DMA controller and not the CPU. So the CPU cycles that are spent with DMA will be 200 only. Option number 1, 200 cycles will be the right answer. In case if the question is, what are the total cycles that are spent with DMA, at that time you can add 3000 plus this setup overhead and make it to 3200. This is for the total DMA we can take. So when you involve DMA, what happens? The DMA cycles have to be taken into consideration. At the same time, the CPU setup overhead also should be taken into consideration. But when you take only CPU into consideration, only 200 cycles are needed here. Next question, how much CPU time is consumed by programmed input output? The programmed input output cycles is equal to 12,000 cycles from the earlier calculation. The CPU clock speed is given as 1 GHz. So 1 kilo is mentioned as 10 to the power 3, 1 mega is 10 to the power 6 and 1 giga is 10 to the power 9. So 1 GHz can be written as 1 into 10 to the power 9 cycles per second. Why are we changing hertz to cycles per second is, when you want to mention CPU clock speed, it will be in the form of cycles per second, so that the unit stays the same in numerator as well as denominator. The CPU time is given by the number of cycles divided by the clock speed. So what is the number of cycles here? It is 12,000 cycles. And what is the clock speed? It is 1 into 10 to the power 9 cycles per second. Cycle will get cancelled and second will go to the top. Now 12,000 can be written as 12 into 10 to the power 3, and this 10 to the power 9 can also be taken to the numerator as 10 to the power minus 9. What is 3 minus 9? It is 6. So 12 into 10 to the power minus 6, and the seconds that went to the numerator will be retained here. What is 10 to the power minus 6 seconds? It is 1 microsecond. So this will be 12 microseconds. Option number 1, 12 microsecond will be the right answer. So in order to calculate time, you are dividing number of cycles by clock speed. The number of cycles calculation is taken from the first question of this particular paragraph, and the clock speed is given in the question. Next question, how much CPU time is consumed by DMA overhead? Now they are asking only with respect to overhead, not the total time. DMA overhead is equal to 200 CPU cycles. This is the setup cost the CPU spends to initiate the DMA transfer, and the CPU clock speed is taken as 1 GHz from the question, which is 1 into 10 to the power 9 cycles per second. We have brought this to the same unit. Now CPU time that is being asked for the overhead will be number of cycles divided by clock speed. What is the number of cycles? It is 200 divided by what is the clock speed? 1 into 10 to the power 9 cycles per second, and this is just cycles. We can cancel it. Seconds will go to the numerator. This will be 2 into 10 to the power 2 into, we are bringing 10 to the power 9 to the numerator. The seconds will be retained as it is. So 2 minus 9 is actually 10 to the power minus 7. From the options we understand that microseconds is involved here. So how can we write this particular 10 power minus 7 is, we can split it as 2 into 10 to the power minus 1 into 10 to the power minus 6 seconds. Now this particular part will be converted as 10 to the power minus 1 microseconds. What is 2 into 10 to the power minus 1? It is 2 divided by 10, which is equal to 0.2 microseconds. Again, here also we have option number 1, 0.2 microseconds as the right answer. One thing you have to be very cautious is, you have to check for the microseconds part and adjust it accordingly. Because here the confusion can be 2 into 10 to the power minus 7 can be marked as 2 microseconds. But that is wrong. You shouldn't do that mistake. Here it is 3 and here it is 12. That is a different value. But 0.2, 2, 20, all these are similar values that have only 2 as the number. Just based on the 10 to the power only, the answers will be differing. So you ought to be careful in these stages. Now this is for the question. What about the total DMA time along with the transfer and overhead? So here we have total DMA cycles that we calculated alongside 3200 and the clock speed is given. So the number of cycles is 3200 and this is 1 into 10 to the power 9. Now this can be written as 32 into 10 to the power 2 divided by 10 to the power 9. So bring it to the numerator, 32 into 10 to the power 2 into 10 to the power minus 9. So this is 32 into 10 to the power minus 7. So we have to bring it to microsecond. What we will do is 32 into 10 to the power minus 1 into 10 to the power minus 6 seconds. So what is 10 to the power minus 1? This is 32 by 10 microseconds, which is 3.2 microseconds. So the total CPU time here is 3.2 microseconds. So this part is done only for understanding. Maybe if you get a similar question next time, you should be able to calculate. For that purpose only I gave you this. The question ends up here and this is the answer for the question. This is for your learning purpose. Next question and the final question for this particular passage as well as for the unit. Which is more CPU efficient for large block transfer? Let's take programmed input output. The CPU is going to handle every byte transfer. So we have 12,000 cycles. All these are done by the CPU. The CPU time scales linearly with block size. So when the block keeps increasing, the time will also keep increasing. For large blocks, this becomes heavy and inefficient because the CPU has to do everything. What is the DMA story here? The CPU only pays a small setup overhead. As per the paragraph, it is 200 cycles and the transfer cost is handled by the DMA engine, that is 3000 cycles. So the CPU is far less involved here. 12,000 cycles for programmed input output and just 200 cycles for the same block of data they have given. So we can say DMA is more CPU efficient for large block transfers. So we are going with option number 2 as the right answer. We are ruling out option 1. Now the third option is, they say both programmed input output and DMA together. DMA uses fewer CPU cycles for the 2000 byte block. So they are not equally efficient. That's why we are ruling out even option 3. What about depends on block size? In general systems, very small blocks can make DMA setup overhead relatively costly, sometimes narrowing the gap. Say for example, if the data is going to be too small, only 100 bytes or something, it will take 200 cycles just for setting up. So at that time, DMA might not be efficient. However, with the given parameters in the passage, 2000 bytes is given there. DMA is decisively better, 200 versus 12,000 CPU cycles, or you can take the total cycle, 3200 versus 12,000. Which is better here? This one is quite efficient. Even along with the DMA controller cycles, I am just adding up and telling you. So the setup and the DMA cycles together, it makes only 3200. Whereas for the 2000 bytes same data, we are taking 12,000 cycles in programmed input output. So for large blocks, the advantage of DMA only grows because programmed input output scales with bytes while DMA keeps CPU involvement minimal. So it is nothing to do with depends on block size and all. With this we are completing unit 2 solutions. Let's solve unit 3 questions. A normalized matrix that maps a 3D window specified by coordinates 1, 1, 1 and 4, 5, 6 onto a viewport specified by coordinates 2, 4, 2 and 8, 10, 8 is. The moment you see 3D window, you must have understood its computer graphics. What is normalized matrix? In computer graphics, whether it's 2D or 3D transformation, a normalized transformation matrix is the matrix that maps a given window, the rectangular region, into a viewport from a bigger window to the window of your device. Say for example, the bigger window can be taken as the large screen, a system screen, and the viewport can be considered as a mobile screen. So the device coordinates will be totally different, but you have to map the rectangular region accordingly in the device. So for that purpose, we need normalized transformation matrix. The window coordinates are specified and the viewport coordinates are specified. They are asking what is the normalized matrix that will map the window to the viewport. It's a new kind of problem in UGC NET exam. So let's see. The window, that is the world coordinates are given. We will take the first coordinates as the minimum corner. So minimum corner will be 1, 1, 1 specified by windows minimum. Maximum corner will be 4, 5, 6 given by window max. Why are there 3 coordinates here? Usually when you take axis, it is just x and y. So why did z come here? It is because we are talking about 3D window, 3 dimensions. If it is 2D, we can stop with x and y, but since it is 3D, we are including z coordinate also. So this is window, the world coordinates. What about the viewport coordinates? That is the device coordinates. The minimum corner is 2, 4, 2 and the maximum corner is 8, 10, 8. So minimum corner is viewport minimum and maximum corner here is viewport maximum. The normalized transformation matrix is given by this particular matrix. So what is this Sx, Sy, Sz? They are the scaling factors. It means a scaling transformation is applied. And what is this Tx, Ty and Tz in the last column? They are the translation offsets. From this you should understand there are 2 different operations involved. One is scaling and another one is translation. This translation is done along the scaling is what you have to understand. Now we will start with the calculation. What should we find first? We have to find the size of the window and size of the viewport. So window size W is given by W max minus W min and viewport size is given by V max minus V min. So here we have to calculate this for every dimension. This is x, this is y, this is z. This is x, this is y, this is z. Let's take wx. What is the x coordinate in max? It is 4. What is the x coordinate in min? It is 1. What is 4 minus 1? It is 3. What about wy? It is 5 minus 1. So 5 from w max y coordinate and 1 from w min y coordinate. This is 4. What about wz? So w max z coordinate is 6 and w min z coordinate is 1. This will be 5. What about viewport size now? Vx is equal to 8 minus 2. The V max x coordinate minus V min x coordinate. This is 8 minus 2 which is equal to 6. What about Vy? The y coordinate is 10 in max, 4 in min. So it is 10 minus 4 which is equal to 6. What about Vz? This is 8 from z coordinate V max and 2 from z coordinate V min. So it is 8 minus 2 which is equal to 6. So we have found the window size with respect to x dimension, y dimension, z dimension as well as the viewport as per the dimensions x, y, z. Now we have to go with scaling. The first transformation, the scaling factor is given by S is equal to viewport divided by window size. So this applies to all the three dimensions. Sx will be Vx divided by Wx, Sy will be Vy divided by Wy, Sz will be Vz divided by Wz. Now what is Vx? It is 6. What is Wx? It is 3. 6 divided by 3 will be 2. What about Vy? It is 6. And what is Wy? It is 4. Here we have 2 3s are 6 and 2 2s are 4. Since the options have fractional parts, we are stopping it with 3 by 2. What about Vz? It is 6. And what is Wz? It is 5. We will retain 6 by 5 as it is. Just finding the scaling factor itself, you can conclude option number 1 to be the right answer. I am telling you to mark the answer before I complete the problem. Why? Because in the examination hall, if you have only these many details enough for the answer, then find them and then mark the answer. This is what I am trying to tell you in examination point of view. Examination point of view is different, learning point of view is different. In case this 2, 3 by 2, 6 by 5 is going to be retained in all the 4 options, then the only savior will be Tx, Ty and Tz. So always know how to do a problem completely, but for examination point of view, if you are able to find the answer with second step or third step, just stop, I am telling you. Now let's go for translation. Translate the window's minimum corner to the viewport's minimum corner after scaling. Minimum with respect to x coordinate, minimum with respect to y coordinate, minimum with respect to z coordinate is what they have mentioned here. So we have to translate the window's minimum corner. So we are going to use W min values to the viewport's minimum corner, which is V min values after scaling, where we are going to apply Sx, Sy and Sz. So let's start with Tx. V min is 2. 2 minus W min is 1 into Sx value is 2. So what is 1 into 2? It is 2. So Tx is equal to 0. So as per the first option, the Tx value is 0 here. What about Ty? V min for y coordinate is 4 minus W min is 1 into Sy value is 3 by 2. So this is 4 minus 1 into 3 by 2 is 3 by 2. 2 4s are 8. 8 minus 3 by 2, this will give a value of 5 by 2. So Ty is 5 by 2, this is also fine. Next Tz. So V minimum is 2 again. Then we have W minimum in Z is 1. Then Sz will be 6 divided by 5. So 1 into 6 by 5 is 6 by 5. This is 2 minus 6 by 5. 2 5s are 10. 10 minus 6 divided by 5. This will give a value of 4 by 5, which is matching here. So what is the normalized matrix? Let us write it again here. Let's have Sx value, it is 2. Then Sy value, it is 3 by 2. Sz value is 6 by 5. The remaining places will have 0 here. What about the translation values? It is 0. For Ty it is 5 by 2. For Tz it is 4 by 5. And the last row will have 0, 0, 0 and 1. So this will be the normalized matrix and this is exactly matching in option number 1. Next question, which of the following is not true about constructor? Constructor questions are repeated. So if you had a learning already, this question must have not taken a lot of time for you. Statement 1. When an object is created and initialized at the same time, a copy constructor gets called. What is actually a constructor? It's a method or a function that is written inside the class with the same name as the class. When you want to initialize some values, we make use of the constructor. So here they are asking about which is not true, but this statement is actually true. When an object is created and initialized at the same time using another object of the same class, copy constructor is invoked. It means it is called. A copy constructor is called when a new object is created and initialized from an existing object. Here, object 1 belongs to my class and object 2 also belongs to my class. When a new object is created from an existing object that belongs to the same class, at that time copy constructor is called. So first statement is definitely true, but it is not the answer because they are asking for not true. What about second statement? They do not have return types, not even void. Constructors in C++ never have a return type, not even void. They are special member functions used only for initialization. Just to initialize values we are using them. So there is no need to have return type at all and they cannot have return type. So statement 2 is also true. Statement 3 says they can be virtual. Constructors cannot be declared virtual in C++. So this is the false statement here. Virtual functions rely on the virtual table which is set up after the constructor runs. Therefore, making a constructor virtual is meaningless and disallowed by the language. It is not at all in the rule list of C++, so forget about it. Now the final statement. They cannot be inherited, though a derived class can call the base class constructor. This is also true. Constructors are not inherited. In C++, constructors are special member functions tied to the class itself. They are not passed down to the derived classes like normal member functions. Each class must define its own constructors. Usually when you have other member functions that can be used by the derived class. So here inheritance will not be possible because every class should have its own constructor. But derived classes can call base class constructors. This is possible. When you create an object of a derived class, the base class portion of that object must also be initialized. This is done by explicitly calling the base class constructor in the initializer list of the derived class constructor. So for that purpose, definitely the derived class can call the base class constructor. If you don't specify one, the compiler automatically calls the base class default constructor. Whether you explicitly do or not, the compiler will automatically do is what they say. So constructors are not inherited. At the same time, the derived classes have the capability to call the base class constructors because when the base class portion of the object has to be initialized, the constructor of the base class has to be called. I hope these 4 statements could have given some more learning on constructors. Option number 3, they can be virtual is the only false statement about constructors. Statement 3 is not true about constructor. Next question, assertion and reason question. This is about Bezier curves and B-splines. They belong to computer graphics. What does the assertion say? The control points have only local control over the shape of the B-splines. And the reason says Bezier curves do have local control. Already we have come across Bezier curves and B-splines explanation in unit outline videos as well as in 1 or 2 previous year question paper. Let's see about Bezier curves. Control points in Bezier curves do not have local control. Changing one control point affects the entire curve because the curve is defined globally by all points. You could have seen the curve given and the control points will be specified by dots, and changing one particular control point will affect the entire curve is what they say. So definitely we know R is wrong. What about B-splines? Control points in B-splines do have local control. Moving one control point only affects the curve in a limited region and not the entire curve as it happens in Bezier curves. This is one of the main advantages of B-splines compared to Bezier curves. So from this we can understand assertion is correct but reason is not correct because Bezier curves have global control and not local. So from this we can mark option number 3, A is correct but R is not correct as the right answer. Next question, it is again an assertion and reason question. What is the assertion? We can build an object from a class containing a pure virtual function. What about the reason? A class containing a pure virtual function is called an abstract class. This is definitely right. Pure virtual functions are actually declared with is equal to 0 in a class. An abstract class is a class that contains at least one pure virtual function. So a class containing a pure virtual function is called an abstract class is absolutely true. You cannot build an object from that class. We can only create objects of its derived classes that implement all pure virtual functions. So they say we can build an object from a class containing a pure virtual function. It is actually wrong because they say we can create objects only from its derived classes. And reason is definitely correct. Here the answer will be option number 4. A is not correct but R is correct. This will be the right answer for this question. Next question, for implicit type conversion, arrange the following from a lower size type to a higher size type. Usually we will explicitly convert a type to another type for our own purpose in programs. Implicit type conversion means when you have two different data types under a single operation, the compiler will automatically convert the lower types to the higher types. So they are asking for the arrangement from lower to higher types. Say for example, int and long. So comparatively we know int is smaller, long is higher. When you have a variable a from int and b from long, in a plus operation, the result will be implicitly converted to long because among int and long, long will be of the higher type. So now we will learn about implicit type conversion. This conversion is when compiler automatically converts one data type into another data type during an operation without the programmer explicitly asking for it. You won't specify but it will do automatically. This happens automatically at compile time, ensures that operations between different types are valid. Usually converts the smaller type to the larger type in order to avoid data loss. Imagine there is a number called 11112222 in long and int is going to have just only 4-digit numbers. Just for example I am saying, okay. Just 1111. If I have a variable called c that is going to store the sum, if it is long, it will store the sum of this big number. In case if it is going to be declared as int, then definitely there will be data loss is what they say. This also converts between integer types and floating point types when needed. Say for example, 1 plus 2.0 will be taken as 3.0 only. So float comes in the higher range. When we program, we definitely know int is smaller than long, int is smaller than float, we definitely know. But here just look at the options given: double, unsigned long int, unsigned int, long double, long int. Now we will see an example of how this is happening. So int a is equal to 10 and double data type b is equal to 5.5. Double result is equal to a plus b. So this is how we explicitly state result to be double and the result will have 15.5. Here we didn't mention a to convert to double and then do addition with b. We just mentioned a as int and b as double. Here the compiler promotes integer a to double before addition. This is implicit type conversion. Implicit type conversion is the compiler's way of automatically promoting or widening data types so that mixed type expressions can be evaluated safely. Now we will see what is the order from lower to higher precision format. From character it will be converted to short, from short it will be converted to int, from int it will go to unsigned int, from unsigned int it will be converted to long, from long it is unsigned long, from there it is to float, from float it is to double, from double it will go to long double. So in case the fight is between int and float, float will be higher. If the fight is between long and double, it will be double in the higher end. So let's mark all the options now. Double is A, unsigned long int or unsigned long, both are actually same. This is B. Then we have unsigned int, this is C. Long double is D, and long int or long, this is going to be E. So whether int is present or not, it is int only, so we can include it here. What is the order from lower size type to higher type size now? It is C, E, B, A, D. Option number 4 will be the right answer. While you prepare for this particular question, you prepare this order in your mind, list the order in the exam hall, mark the options in the similar way and then find it. Otherwise, you will end up with unnecessary confusion. Next question, arrange the following applet life cycles methods in sequence. Start, paint, init, stop. We are starting a work, we are ending a work, that is given by start and stop, and in between we are going to paint, that is what we will do with applets. So definitely start, paint, stop will be the order. Now just take C init. Will we initialize and do the work or do the work and initialize? So we will generally initialize. So this C will stand first and this start, paint, stop. So this is start and this is stop, and in between we will do the work, that is paint. So ABD order is preserved only in option number 2, or you can take it as any work will be starting with init. So we can start with option C. So the only option that starts with C is option 2. If you have no idea about applet life cycle, this is how you have to think and answer. Now let's see the solution. Applet life cycle methods. Along with these 4 methods, we have an additional method. We will see that also. When there is something to start, there is something to stop. Similarly, when there is something to initialize, then there should be something to destroy also. So the first will be init, which is C. This is called once when the applet is first loaded. This is used for initialization tasks like setting up variables, loading resources. And next method will be start, which is A, called after init and whenever the applet becomes active. That is whenever the user revisits the page. This is used to start animations, threads or other activities. What about paint? This is B. This is called whenever the applet needs to redraw its output. When the window is refreshed or uncovered, it has to redraw the output. This is used for displaying graphics or text, that is paint method. What about stop method? It is D, called when the applet is no longer active. Example, when the user leaves the page. Used to suspend animations, threads or release temporary resources. What about the final method that is not mentioned in this question? Destroy. This is called once when the applet is being completely removed from memory. So when it is loaded, we call init. When it has to be removed from memory, destroy is called. This is used to release resources permanently like closing files and network connections. So the order will be CABD. Option number 2 will be the right answer. Earlier I told you a simple story to answer if you are not aware of applet life cycle. The real learning starts here. So please learn this after watching this video. Apply all this process or thinking only during the examination, that too when you don't have any idea about the question. The applet life cycle begins with init method for setup, then start method to activate processes. Whenever the applet needs to show something, paint method is invoked. Finally, when the applet is paused or the user navigates away, stop method is called to halt execution. Next question, which of the following statements are true? The increment operator can be overloaded to perform decrementation of a variable. Is this true or false? Technically, it is possible to do it, but as per conventions or as per rules, we will say don't use increment operator for any other purpose like decrementing. That will become meaningless. If I say a method with plus plus, it has to give an idea for the coder or the developer or one who reads the program, that something is going to increment. If I go and decrement the value there, they will find it little bit annoying or confused. So for that purpose, usually we don't have that practice of writing decrement function for increment operator. But here they are asking whether this operator can be overloaded to perform decrementation or not. Yes, you can perform. Technically, the program will run without any errors. There is no doubt. This is technically possible. You can overload plus plus operator to decrement. The plus plus operator is meant for incrementing a value. If you overload this operator to perform decrement, it will technically compile and run, but this is considered a bad practice. The compiler expects plus plus to represent increment and not decrement. When you want to do decrementation, you have to go with overloading the decrement operator instead of using the increment operator. But this is all for general conventional rules of programming. But technically, you can do it. A is definitely true. What about B? It is necessary that a constructor in a class should always be public. Constructors can be public, protected or private. It is not necessary for constructors to always be public. So here this statement is definitely false. Once you confirm that B is false, remove 1, remove 2 and remove 4 from the answer list. You have the answer here. Let's go for C. Size of an object is equal to sum of sizes of data members and member functions within the class. Actually, you can calculate the size of data members, but do you think it is possible to calculate the size of member function? I don't think so. The size of an object depends only on its data members. Member functions are not stored inside each object. They are shared across all objects and stored separately in code memory. So what does function do? Whatever is passed inside the function as an argument or whichever object is going to ask that function to do some work, it is going to get activated. Till then, it is not going to initialize any variable or store the value of any variable. It is actually action doer. But data members are the ones who are going to actually hold values. If you want to calculate an object size, data members size will be more than enough. Say for example, you are going to increment a value. The variable will be picked from data member only. The value will be incremented. Again, the data member will only store that value. So member function is going to do the task. It is not going to store anything. In that context also you can think. Generally, member functions are not stored inside each object. They are shared and so they are stored separately is what they say. So C is also definitely wrong. So we can mark option number 3, A, D and E only as the right answer. These are the true statements. Now we definitely know D is true and E is true. So let's see those statements. A static data member is useful when all objects of a class are to share a common item of information. This is definitely true. Static data members are shared across all objects of a class. What about E? The this pointer always contains the address of the object using which the member function is being called. Yes, the this pointer refers to the current object that invoked the member function. So this statement is also right. We can mark D and E to be true definitely. Regarding this question, there will be two confusions. One is the plus plus operator. Can it be overloaded for decrementation operation? That is a big question. And the second doubt will be constructors can be private or protected or it should be only in public. So if you clear the confusion between A and B, you can have the answer seriously. But again you have to remember one thing. There is a term in polymorphism called operator overloading. If operator overloading is definitely a concept, plus plus operator can definitely be overloaded. Even if you think in this aspect, you can mark A to be true. I am just giving you additional points or additional thoughts so that next time when there is a confusion, you can bring all this to your mind and get an answer. Next question, which of the following statements are true? This is from computer graphics. So let's start statement by statement. Painter's algorithm is also called depth sort algorithm. The Painter's algorithm works by sorting all polygons by their depth, that is the distance from the viewer, and then drawing them back to front. This mimics how a painter paints a canvas, the background first, then foreground objects on top. Because it relies on sorting by depth, it is commonly referred to as depth sort algorithm. When you take foreground and background, foreground is closer to our eyes and background is behind that. So this algorithm will start from the background. So if this is going to be human eye and this is going to be the front picture and this is going to be the background, this particular algorithm will start painting this one. It will start working with the background. So this part is distant from the viewer. Here we say it is the depth, and then it works with the foreground. So the depth is reduced. So we can say depth sort algorithm. So if you are able to map this particular explanation with this little diagram, I think you can understand the meaning why Painter's algorithm is called depth sort algorithm. So from this, what we can conclude is A is true. What about B? Gouraud shading is an interpolating shading method. Gouraud shading works by computing lighting at the vertices of polygons and then interpolating the intensity values across the surface. This interpolation gives smooth shading across the polygon, avoiding the flat look of constant shading. So definitely it is an interpolating shading method. B is also true. Now see a contradicting statement. Gouraud shading is an averaging shading method as per C. This is definitely wrong. If it is going to be interpolating method, then it cannot be average shading method. Understand the meaning of interpolation. If you have come across numerical analysis and all, you could have come across interpolation term. Numerical analysis in mathematics. Actually, interpolation is if there are some missing values, you have to fill them up. So when you constantly shade, there is a possibility that you might miss some pixels of shading. Interpolating the intensity values is if you are going to fill those missing places in shading, definitely that will give you a smooth shading across the polygon. In Tamil we will say thitta thitta shade pandradhukum and the thitta maraikradhukum we will say. See, I can tell you like this. When you are shading like this is not completely shaded, right? There are at least some white points here. Take this to be a shading, there are some white points here. Interpolation will take the intensity values across the surface and it will fill those values. Compared to the earlier one, this gives a smooth shading. Filling the missing values, that is interpolation. Take it in that way, you can understand it better. So what about C? Gouraud shading is not averaging, it is interpolating. You are not going to calculate the average of the pixel. Take this to be the red pixel and this white pixel is left as it is. You are not going to calculate the average and fill this place. You are just going to interpolate. Based on the intensities, you are going to interpolate. You are going to fill it. So C is definitely wrong. Averaging would mean combining values directly, but Gouraud shading specifically interpolates vertex intensities across the polygon surface. What about D? The Z buffer algorithm finds the largest depth value Z. This is contradicting. This is definitely wrong. The Z buffer algorithm keeps track of the smallest, that is the nearest depth value Z at each pixel to determine visibility. Z buffer algorithm is about visible surfaces. So when it is visible surfaces, whatever I am able to see is in a nearer depth, I would say. See, in this example, this is smaller depth while this is going to be the larger depth. So visible surfaces is this particular area. So definitely the Z buffer algorithm has to keep track of the smallest depth value. When rendering, it means when it is presented in the screen, it compares the depth of a new surface with the stored depth and updates only if the new surface is closer to the viewer. So it finds the minimum depth, the closest object, not the largest. So just based on visibility, Based on this particular term, you have to bring visible surfaces content in your mind and then map Z buffer algorithm accordingly. While learning during preparation, you have to learn this way, and all these explanations, I think it will be available in unit outline video, computer graphics unit. So it will give you some more idea and some more understanding on these algorithms. So what are the right statements here? It is option 1. A and B only will be the right answer. And I have told you why C and D are wrong. When B is right, C cannot be right. And D is obviously not right. Next question is again from computer graphics. Match the list 1 with list 2. List 1 is having the quadric surfaces and list 2 is having the equation. What are these quadric surfaces? A frequently used class of objects are the quadric surfaces, which are described with second degree equations called as quadratics. We are using x power 2, y power 2 and all, no? That's what they say, quadratics. These objects include spheres, ellipsoids, tori, paraboloids and hyperboloids. The list 1 is restricting to paraboloids and hyperboloids. I'll just give you the image of all these quadric surfaces and the relevant equation, how to find them. So let's start with one sheeted hyperboloid that is present in list 1A. One sheeted hyperboloid will look like this. There will be two positive terms, one negative term involved that will be equivalent to a constant. In the options, just find two positive terms and one negative term. X square by A square is one positive term. Y square plus B square is another positive term. Minus Z square by C square is the negative term, and that is equivalent to a constant, is equal to 1. So A will be mapping to 2. The next one is two sheeted hyperboloid. This one will look like this. Here one positive term will be there and two negative terms will be there, that equals a constant. So here we have one positive term, Z square by C square, minus X square by A square is one negative term, minus Y square by B square is another negative term. If you take these equations in the web and see, in some places X will be given in positive part and Y and Z will be negated. Sometimes Y will be given in the positive part and X and Z will be negated. I have just taken this diagram for just giving you as a reference how they will look. This equation is what I am trying to tell you with two sheeted hyperboloid. What is the quadratic surface and how the equation will be there is alone given here. If you take option 2 also in list 2, sometimes Y will be negated, sometimes X will be negated. That is dependent on how the hyperboloid is placed in the surface. So don't get confused between the diagram. This is mere reference. This is not equal to the equation that is provided in the list 2 part. Okay, I am just making it clear. So just remember, 2 positive, 1 negative is 1 sheeted and 1 positive with 2 negative is 2 sheeted in case of hyperboloids. So here we will have B4. A to B4 is available only in one option. So let's mark it as it is. Now let's go for elliptic paraboloid. This is elliptic paraboloid. Here both squared terms are positive and that is linear in Z. So when they say linear in Z, it means Z will be placed in the right hand side. So here we have something called CZ and they say both the terms are positive. So it is X square by A square and Y square by B square. Both are positive terms. And since they say it is linear in Z, we are having C into Z. So here equals constant is equal to 1 in both the places. But here it is CZ since it is linear in Z. So this way you can remember C will be mapping to 1. And what about the final one, hyperbolic paraboloid? It looks like this. There will be one squared term positive and one negative. And this is also linear in Z. So CZ will be as it is, one positive that is X square by A square and one negative will be minus Y square by B square. So this will be hyperbolic paraboloid. D is mapping to 3. C1 D3 is available here. Option number 3 will be the right answer. I don't know whether such question will be repeated, or for the next match, instead of giving x square and y square in positive for this particular option, they can give y square and z square in positive and x square in negative. But if you understand 2 positive and 1 negative with a constant is one sheeted, nobody can confuse you, no words can confuse you, or no equation can confuse you. That's why I have given you how to find out the equation based on the terms. Next question, match the list 1 with list 2. We have the file mode parameters in list 1 and the meaning in list 2. So we will see the list of file mode parameters. These are actually C++ iOS flags. So iOS in is for open file for reading input. So this is B option. In list 1, iOS out is for open file for writing output. iOS app is for append mode, all output written at end of file, the usual append mode. Open file and move, write pointer to end, but allow writing anywhere is iOS ATE. So this is A. What about iOS trunc? If file exists, truncate its contents. It means delete its contents. What is iOS binary? Open file in binary mode. There will be no text translation. What about iOS no create? This is C. Fail if file does not already exist. This is non-standard and it's of older usage. We don't use it now, but they have given in the maths. That's why I am giving you the meaning. What about iOS no replace? This is D. Fail if the file already exists. Now we'll go for the meaning. Go to end of file on opening. So moving the pointer to end is what is mentioned here. So this will be 1. A is mapping to 1. Now we'll go for B. Open file for reading input. Open file for reading only is given. So B will be mapping to 3. A1, B3 is available in 2 options. Now let's go for C. No create means the file should already not exist. Open fails if the file does not exist. So C will be mapping to 4. What about no replace? This will fail if file is already there. Open fails if the file already exists. So D will be 2. These two are non-standard and it's of older usage, but since it's a part of the match, I just gave you the meaning. Other than that, have idea about the other 6 so that it can be useful for you in some other question paper. So let's mark C4 and D2 here. So this one is wrong. We can go with option number 4 as the right answer. With this, we are completing Unit 3 solutions. Let's solve Unit 4 questions. Specialization process does not allow. Here we have to understand what is specialization process. This is with respect to the concept generalization and specialization. Specialization is the process of breaking down a general entity into more specific sub-entities. When you take generalization and specialization terms, they might resemble the software engineering concepts, the UML diagrams, but here this is with respect to entity relationship diagram. Even the final question of the unit, which is in the form of matching list, also has diagram and its description, but those diagrams we would have come across in software engineering. But in fact, these diagrams are a part of entity relationship topic in database management system. So here we have certain terms, entity types, specific attributes, relationship. Using these terms only we are concluding this particular question is a part of DBMS. When there is a general entity and we are able to break down into more specific sub-entities, that process is specialization. The approach here is top-down approach. It means the general is here, from here you are moving specific. So this is specialization. When you take in the context of entities, there are two terms, superclass and subclass. Superclass is the general entity and subclass will be the specialized entities. There can be one or more specialized entities. Let's take an example. If you have an entity called employee, a manager is also an employee and engineer is also an employee. Even though manager and engineer are different entities, they are specialized entities that came from this particular employee entity. Employee is a general entity and the specialized entities will be manager and engineer. To represent distinct characteristics of subgroups while maintaining shared attributes in the superclass. So the superclass will contain the general characteristics similar to inheritance based class. But the derived class in OOP, how they represent a particular class specifically but derive some attributes from their base class. The similar way, the distinct characteristics of subgroups like manager and engineer will have some attributes that are specific to their own entities. But in general, they will share the common attributes from the superclass, which is the employee. Now let's check which statements are about specialization and which statement is against specialization. The first one, define a set of subclasses of an entity type. This is talking about specialized entities from the general entity type. Specialization is exactly about creating subclasses from a superclass. So this statement is actually correct. So we'll move to the next one. Establish additional specific attributes with each subclass. Here they say this will represent distinct characteristics of subgroups. This is what is mentioned as specific attributes here. Every subclass may share some attributes from the superclass, but at the same time there will be certain attributes that are specific to the subclass. So it will establish additional specific attributes that are constrained to that particular subclass. So this statement is also true. Subclasses have their own unique attributes beyond those inherited from the superclass. Statement 2 is also fine with regard to specialization. What about the third one? Define a generalized entity type from the given entity types. This part is actually wrong. So this process is generalization and not specialization. Let's go to the fourth one. Establish additional specific relationship types between each subclass and other entity types or other subclasses. So the relationship between subclass and subclass can be taken as the relationship between one subclass manager and another subclass engineer. Subclasses can participate in relationships that are not applicable to the superclass. It means apart from the ones that are defined from the superclass, it can have additional relationship. So here it doesn't mean manager should be related only to employee. Manager can also be related to another entity type other than employee. So this is what they say, additional specific relationship types. So fourth one is also true. So the only false statement here is option 3. Specialization process does not allow to define a generalized entity type from the given entity types. Option number 3 will be the right answer. That is the one not related to specialization, but it is related to generalization. Next question. If a transaction TA holds a lock on some data item D in shared and intention exclusive mode, then which of the following is true for another transaction TB? Shared, intention, exclusive. This is SIX mode. This concept is based on multiple granularity locking, a technique in DBMS that allows transactions to lock data items at different levels of granularity. Granularity means size of something you can take. It can be the database, it can be a table, it can be the page, it can be the row. So this is about locking data items at different levels of granularity simultaneously. Now we have to know what are the lock modes that are used in multiple granularity locking. So we have 5 lock modes here: shared lock, exclusive lock, intention shared lock, intention exclusive lock, shared and intention exclusive lock. The final lock is what they have mentioned in this particular question. We will take idea about all the locks. What is shared lock? Allows a transaction to read a data item but not modify it. Multiple transactions can hold S locks simultaneously. What about exclusive lock? Allows a transaction to both read and write a data item. No other transaction can hold any lock on that item at the same time because they are going to write a data item. That's why it is not allowed. What about intention shared lock? Indicates the intention to acquire shared locks on finer granularity. It means like rows within a table, not for big items like table or database, just restricted to row. It's placed at higher levels like table to signal shared access will be requested below. Then we have intention exclusive lock. This indicates the intention to acquire exclusive locks on finer granularity like rows within a table. It is placed at higher levels to signal exclusive access will be requested below. What about the lock mentioned in the question? A combined lock that allows shared access to the data item itself and indicates intention to acquire exclusive locks on its descendants will be shared and intention exclusive lock. Now they are saying that 2 transactions are involved, TA and TB. So TA is locking data item D in SIX mode. So what kind of access does TB have? TB can lock D in shared mode, exclusive mode, intention exclusive mode, intention shared mode. So from these 4 statements you can understand it can be done only in one mode. So what mode it is? We have some compatibility rules and I have given you it in the simplified form so that it will be easy for you to learn. Now let's take shared lock. It is compatible with shared and intention shared but not with exclusive, intention exclusive, shared and intention exclusive. What about exclusive lock? It is not compatible with any other lock. What about intention shared? Since it is shared here, it is compatible with shared, intention shared and intention exclusive, but not with exclusive or shared and intention exclusive. What about intention exclusive lock? It is compatible with intention shared and intention exclusive itself, but not with shared exclusive or shared and intention exclusive. Now what about this lock? It is compatible with intention shared but not with shared exclusive, intention exclusive or another shared and intention exclusive lock. So it is compatible with intention shared means we can find intention shared IS mode only here. Since it is not compatible with shared, option 1 is out of the race. Since it is not compatible with X mode, that is exclusive mode, it is also out of the race. Intention exclusive is IX, so it is also out of the race. So the only mode with which TB, the transaction B, can lock the data item D will be intention shared mode because SIX mode, the shared and intention exclusive mode, is compatible only with this particular mode. Here they say IS is compatible with these 3 but not with SIX. Here in SIX it says it is compatible with IS means TA is holding SIX, TB can hold IS lock. This is the meaning. Option number 4 will be the right answer. SIX conflicts with shared lock, so it is not allowed. Similarly, X is conflicting with SIX, so it is not allowed, and IX conflicts with SIX, so it is also not allowed. And the fourth one is definitely allowed because SIX is compatible with IS. Next question. Given below are two statements. One is labeled as assertion and the other one is labeled as reason. What is the assertion? A. OLAP systems are optimized for complex queries and analysis. What about the reason? OLTP systems are designed for transactions processing with large read-only queries. Let's take the assertion about OLAP. This statement is perfectly true. OLAP, which is online analytical processing, is designed for multidimensional analysis, decision support and complex queries on large data sets. When OLAP is for large data sets, definitely OLTP cannot be for large data sets. This is false. OLTP, online transaction processing, is designed for fast, simple, frequent transaction processing which involves insert, update, delete as well as small read statements. It is not about large read-only queries but about small reads, because when you take a transaction processing, it will actually go in real time. During real time, you cannot go for batch processing, you have to take real time processing. At that stage, it is quite difficult to go for large read-only queries. Large read-only queries are characteristics of OLAP and not OLTP. Since we have come to OLAP and OLTP, we will just see a distinguishing table here. When you take the purpose, OLTP is used to handle day-to-day transactions and the data volume will be small amount per transaction, but there will be very frequent transactions. The operations carried out mostly will be create, read, update and delete, and the response time will be very fast, that too in milliseconds. And examples will be banking system, e-commerce checkout, airline reservation. When you book something, when you buy something, when you transact something in bank, everything has to happen in seconds. So those systems are OLTP systems. What about OLAP? This supports complex queries and analysis, and the data will be large volumes of historical as well as aggregated data. When you take the operations, we have aggregation, summarization and multidimensional analysis, because when huge amount of data set is going to be involved, usually these will be the operations. When there are less amount of data involved, only then you can go for read, update and delete. This create is nothing but insert, this read is nothing but select statement as per SQL commands. So I'll just give you the equivalent words if you are not able to understand what is create and read. Creating a row is inserting a row, reading a row is selecting the row. What about the response time? This will be slower, usually from seconds to minutes depending on query complexity. We told that it is going to support complex queries, then how come we expect everything in milliseconds or nanoseconds? So we should expect slow response because it has to handle large amount of data. What about the examples? Business intelligence dashboards, data warehouses, sales trend analysis. Usually when you take dashboards, it has to apply all kinds of analytics into it and then only it will show. So loading of dashboard is not so easy. You may think that everything is available at one view, but that is the toughest thing. If you take even news feed, that is the very toughest part, because it has to match your recommendation, it has to match your requirements, it has to match your history and all, it has to match your taste also. Everything has to be matched and brought to a single page. Similar to news feed in scrollings or in social media sites, we can take this business intelligent dashboards. There are lots of data that have been processed by them. In order to give you a one-page review, you can take. So in short, we can say OLTP is optimized for transaction speed and accuracy, and OLAP is optimized for complex queries, reporting and decision support. What is the answer here? A is correct, but R is not correct. Option number 3 will be the right answer. Next question, arrange the following steps of the MapReduce framework. They have given 4 steps: input splitting, reducing, mapping, shuffling and sorting. So what is this map reduce? It's a programming model for processing large data sets in parallel across distributed systems using the two main phases, map and reduce. When we hear the term map and reduce, we will remember Hadoop. When we remember Hadoop, we know big data topic is inside. What are these 4 steps? First one is input splitting. When you have a set of data given to the programming model, first it has to take the input. So something related to input will be the first step here. The input data set is divided into smaller chunks. Maybe they are split into blocks so that they can be processed in parallel by different nodes. Nodes means the data nodes we can take. Mapping is the next step. Each split is processed by a mapper function, which will transform the input data into key value pairs. Then the next step will be shuffling and sorting. This framework will group all values by their keys, redistribute data across nodes and sorts them to prepare for reduction. Before sending it to the next stage, it has to group every value based on the keys. Say for example, there are 1, 1, 1, 3, 1, 4, 2, 1, 2, 2, 2, 5. Group all these ones together, all these twos together because they are the key with respect to these key value pairs. So group everything. One group will be sent to one node, another group will be sent to another node. Sorting will happen between every group before sending it to reduction. And the final step here is reducing. Reducer function aggregates or summarizes values for each key, thus producing the final output. How does it know that all values belong to a particular key? That work is only being done here by shuffling and sorting. It will collect and give to reduce, and reduce will do the aggregation work or summarization work perfectly. So here the order will be A, C, D, B. A, C, D, B is available in option number 3. Option 3 will be the right answer. With respect to this particular question, we definitely know map reduce framework is where map come first and reduce will come next. So map is C here, reduce is B here. Make sure C is followed by B in all the options. It is followed here, it is followed here, it is followed here. But here the order is reduce and map. From here itself you can rule out option 2. Then with what are you going to map? I am going to map only with the input. So this input stage will be coming in front of map work. So I don't know what is going to come in between, what is going to come in the last. But I should know what is going to come in the front. So A will be the first step out of these 4. In this way you can rule out the other 2 options also. When you have A in the last stage, this is a signal that the answer is wrong. Because after doing all the work, what are you going to do with the input then? What about shuffling and sorting? It should either happen before mapping or after mapping. So when there are options like A, C, B, you might get confused whether D should be inserted here or here. But when you apply the logic correctly, map will be working with the input data set only. So when the input data is going to be split up, definitely A and C will come together. But the mapped input will not be directly given to the reduce part. So definitely D will sit in between C and B. If you have no idea about map reduce framework, just from the term map and reduce, you should be able to find out the answer with the previous year question papers knowledge as well as some common idea about the framework. Again, all these works have to be done only when you forget about the framework or only if you have no idea about the topic. These works should not be done when you prepare for the examination. Let's take an example for all these 4 stages. Count word frequencies in a large text file. What is input splitting? We are breaking the file into chunks. Mapping will actually output the word and the count for every word. Shuffling and sorting will group all identical words together. Reducing will sum up the counts for each word to get total frequencies. How much time a particular word has been repeated in this particular text file. Say for example, word 1 has occurred one time, word 2 has occurred one time, then word 1 has occurred second time, then word 2 has occurred the second time. So this will be the mapping stage. The shuffling and sorting will be, it will take word 1 alone separately and word 2 separately. Then reducing will sum up the counts for each word to get the total frequency and says word 1 is used for these many times, maybe x times, and word 2 is used for y times. So this will be the final answer. Map will break down and tag the data, which data, input data. Reduce will combine the results to get the final answer. Shuffling or sorting, whatever the operation is, it will be the connecting point between the map stage and the reduce stage. So before you move from map to reduce, you should either shuffle or sort is what they say here. The glue that connects map to reduce. Next question. In transactions, a write item command includes the following steps. Arrange the following steps in correct sequence. This ordering will ensure that transaction modifies the correct block in memory before committing the changes back to the disk. So what is the order? It will find the address of the disk block that contains item X. First, the system must locate where item X resides on the disk. So let's take this to be a disk and just find where is this particular item. It has to find the address of the disk. Then copy the disk block into a buffer in main memory. So this is with respect to the disk. From here it has to copy into the main memory. So let's take this to be the main memory. So this disk block will be brought here. The identified block is brought into memory for modification. The next step is copy item X from the program variable named X into its correct location in the buffer. So here we have the program segment. The updated value of X is written into the buffer. So this is going to be the buffer. Say for example, if here X is equal to 1 and here X is equal to 2. Just for example I am telling you. Now it will be updated as X is equal to 2. So this is the previous value. This will be the new value. The final step is store the updated block from the buffer back to the disk. Now the block with the updated value will be stored back here. Finally, the modified block is flushed back to disk to persist the change, means to save the change. So the order will be C, D, A, B. Option number 1 will be the right answer for this particular question. What mistake we will be doing here is immediately after seeing copy the item from the program variable and then put it into its correct location. Most people will choose only A as the first answer, but that is not right. You have to take that particular disk block, bring it to the main memory's buffer and then only you have to copy the value. Usually when you work with Excel sheet and all, the worksheet I am telling, when you copy or cut a particular cell, immediately you have to paste it. If you do any other work other than pasting, when you try to paste after that, it will not get pasted. The same thing only will happen here. First you bring that particular block into the memory's buffer and then go and copy the item, place it here and then write it back to the disk is what they say. Next question. Given below are two statements. One is assertion and the other one is reason. Assertion says HDFS, Hadoop Distributed File System, follows a master-slave architecture with name node and data nodes. Already we have discussed about Hadoop in previous year question papers. If you have gone through them, this question might not be new to you. The reason states that name node stores metadata while data nodes store actual data blocks. Let's start with A. Assertion is actually correct. In HDFS, the name node will be acting as the master and the data nodes will act as slaves or workers. So it is following the master-slave architecture. Say for example, if we take this particular name node here, then it will be managing some data nodes here. So here this will be the master and this will be the workers. Instead of slaves we can say workers professionally, but why they use slave is the complete controller is this particular master only. So assertion is definitely correct here. What about the reason? The name node maintains the file system namespace and metadata like file to block mapping, the permissions, and the data nodes will handle the actual storage of file blocks. So that is what they have equated to actual data blocks and actual storage of file blocks. Both are actually same. So reason is also definitely correct. It is not option 3 and option 4 definitely. We know both A and R are correct. Is R the correct explanation of A? Since name node is storing the namespace and the metadata, it will have the detail about all the data nodes for which it is the master. And what is the work of data node? It is actually going to do the work and report it to the name node. Since name node controls data node through this particular process, we can say that HDFS is following master-slave architecture. The division of responsibilities, metadata versus actual data. This is name node and this is data node, is precisely why HDFS is considered as a master-slave architecture. The name node, the master, controls and coordinates, while data nodes, the slaves, store and serve the data. So R is definitely the correct explanation of A, and so we can rule out even option 2 which says it is not correct. We will go with option number 1 as the right answer. Both A and R are correct and R is the correct explanation of A. Next question. This is actually from File Organization in Database Management System. There are questions then and there from this particular topic. In relation to index structures for files, which of the following are true? Just pull out two statements here, C and E. Does any option have these two statements together? That option can be ruled out immediately. Why? Because C says that it cannot be created dynamically and E is saying it can be created dynamically. Completely contradicting statements. Either C should be present or E should be present. If both are present, that option is absent. That's all. We will see statement by statement and then conclude what is the right answer. First statement, an index is an integral part of data file. Index is typically a separate data structure maintained alongside the data file. In case if you have come across certain previous year questions, you could have seen about B plus tree questions and all. So what is this B plus tree and all? It is a data structure. So index is actually represented in the form of that particular data structure. So it is indeed a separate data structure maintained alongside the data file. It actually references the data, no doubt, but it is not physically a part of that file. So definitely A is false here. So we can rule out options that involve A. The next statement, an index can be created in conjunction with virtually any primary record organization. Whether the file is sequential, heap or hashed, indexes can be built to improve access. So definitely this statement is true. Whatever record organization it has, this can serve as a secondary organization in order to improve access time. So B is a true statement. What about C? This is the game changer here. An index can be created or cannot be created. Think well. If all the index have to be created priorly, do you think it is quite possible for maintaining a big file system? No way. This is false. Indexes can be created dynamically. In most DBMS, you can issue a create index command at any time. At any point of time, by issuing this command, you will be able to create an index. So, cannot be created dynamically is not true at all. C is also removed. Once C gets removed, now we know what's the answer. What about D statement? An index can be used to enforce a key constraint on an attribute. Yes, like primary key, we have something called unique key. Unique indexes are often used to enforce uniqueness constraints similar to the primary keys. So, D is definitely true. What about the final statement? Once we know C is definitely false, we will know E is definitely true. An index can be created dynamically. So, this is the opposite of C, and modern systems allow dynamic index creation. And I have already mentioned how to create index at any point of time. So, E is also true. Option number 3, B, D, E only will be the right answer, and I have justified why A and C are wrong. So, whenever you start with such questions, always find such contradictory statements, rule out those options, narrow down your options and start working. You will arrive at the solution in a quicker time. Next question, which of the following statements are correct? Let's see the statements. Having clause is an optional clause which tells Oracle to group rows based on distinct values that exist for specified columns. Whenever you see having clause, it is actually used along with group by clause. Grouping is done by the group by clause. The having clause is used to filter groups after they are formed, not to group rows itself. So just cut these three words. It's an optional clause to group rows. Is it to group rows? Group by clause is there for grouping rows. But having clause is used to filter those groups after the groups are formed, not to group rows itself. So when you use SQL command of group by, after that you will be placing having clause based on this group by condition only. When select statement is going to have a clause called where to specify the condition, group by clause will have having clause to specify the condition. This is for all the rows, this is for the grouped rows. Next statement, unions can be used in subqueries. Earlier when we were students, union were not used in subqueries. Actually, there will be two queries and the results should be combined under union operation, but practically speaking, unions can be used in subqueries. In reality application, though there are possibilities, the purpose of union is to combine two queries in name of union operation. So, they will mark it as incorrect only. In older books or in exam materials, when you take, union is only valid at the top level of a query and not inside subqueries. This is the point. But in reality, modern SQL implementations, union, union all, intersect and minus can be used inside subqueries also. After coming to previous year question paper of DBMS only, many people are dealing with intersect, union, any, all these words and all. So definitely we will not be liking it. Whether we like it or not, in modern implementation, yes, it can be done. What are these exam materials? In some parts of videos I used to mention for exam materials. These exam materials are prepared by many people. Some people will prepare it and publish all 10 units in one particular book, or some faculty will produce material for certain units. So those are exam materials. Whichever material you use for your semester examination, they are exam materials. In those exam materials, you can find such statements. When there is a possibility of saying correct in modern implementation, there is a question like which one should we follow, whether older books, whether the exam materials or the modern versions, which one? There is a question coming in our mind. Already the scalp is getting dried. Actually in Tamil we will say, In this we are having lots of confusions here. So I wish such questions are not repeated. When there are possibilities for both correct and not correct answers, it's better that they avoid such statements. So B is not there, A is not there, and only 3 statements are there in the answer. From here itself you can understand option 1, 3 and 4 will be ruled out and only option 2 is left out. So let's go for C. The intersect clause outputs only rows produced by both the queries intersected. This statement is perfectly true because what does intersection do? It will take only the common elements and give you. So intersect returns the common rows between two queries. It is perfectly correct. C is right. What about D? The statement containing a subquery is called a parent statement. This is also correct. Say for example, we are having some select statement. Inside that we are having a subquery. So this is called as the parent statement because this query is containing the subquery here. So the outer query that contains a subquery is referred to as the parent statement. In fact, we will differentiate it as inner query and outer query, or subquery and outer query, but here they have given a name to the outer query as parent statement. It is perfectly right only. So D is also true. What about E? If a select statement is defined as a subquery, the innermost select statement gets executed first. This is perfectly correct. SQL evaluates subqueries starting from the innermost query outward. It means the innermost select statement will get executed, then the outermost select will get executed. Say for example, here I said we have a select query, here also we will have a select query. So this innermost, the subquery part, this will get executed first and then this select query will get executed next because this select query is depending on this subquery's result. Maybe we will have in operator with a subquery, where operator with a subquery, any operator with a subquery, all operator with a subquery. Based on the result of the subquery only, the outer query has to give results. In those cases, it is very clear that innermost select statements get executed first. So it is perfectly correct. There is no doubt. But what is the next line? SQL optimizers may reorder execution. Conceptually, subqueries are evaluated first, but it is not guaranteed in all cases. This is nowhere related to the question because the key is very clear. So here they are asking about execution only. So we are going with this particular statement, no doubt. While doing real-time execution, it may not happen so. So we are not concerned about this point, but this is just an additional information you can take. So what is the option here? Option number 2, C, D, E only will be the right answer. Next question, match list 1 with list 2. This was the question I was earlier talking about. Class diagram, package diagram, object diagram, component diagram. And this side we have subset, relationship, dependency, static structure. All these are UML terms, OOP content. Why did it come into this particular unit? It is because this question is a part of entity relationship topic. In database design, we have something called entity relationship modeling. Under that only we have got this match. You may ask me why I am so sure that these are DBMS topics. It's because this session question paper, since computer system architecture and software engineering had the comprehension type of questions, those 2 units were placed last. Rest of the units were placed in sequence. Even the question IDs are in order. Let's start with class diagram. A class diagram in ER reflects the static structure of the database showing entities and their attributes. Say for example, let's take employee. We will have ID, we will have name, we will have pay, we will have join date, we will have designation. So this is the entity and these are the attributes. So this is showing the static structure. It is not showing any conversation and all. So definitely A will be mapping to 4. What about the next one? Package diagram. Package diagram can be seen as the subset of the overall schema, grouping related entities or modules together. Sometimes when you want to take an office setup, employees, managers, everything can be grouped together and it can be placed under package. This is for payroll information. These things are for HR. These things are for projects. So under projects we will have project managers, teams, products, projects, everything. So every department will be treated as a separate package that can group related entities or the modules together. When you talk about modules, software engineering will come into place. When you talk about entities, it is a part of DBMS. We will be mapping to one package diagram subset. What about the next one? Object diagram. An object diagram corresponds to a relationship in entity relationship depicting how specific entity instances are linked at a given moment. So let's take the employee table alone for example. So one person is designated as the clerk, the another one is designated as manager. We definitely know clerk and manager have a relationship here regarding those two instances. So object diagram is going to correspond to a relationship and definitely we can say C is mapping to 2. What about component diagram? Component diagram highlights dependencies similar to how attributes or entities depend on one another through functional dependencies or foreign keys. This component diagram is going to highlight dependencies. We can take employee entity and manager entity. So somewhere we know manager entity is going to have the ID that belongs to employee table. If ID in employee table is going to be the primary key, then ID in manager table will become the foreign key. The table with the foreign key is dependent on the table with the primary key. So here dependencies are created and component diagram will highlight those dependencies. So D will be mapping to 3. A4, B1 is available in 2 options. We can rule out the other 2. We have C2 and D3. It is available only in one option. Option number 3 will be the right answer. We can even rule out option number 2. With this we are completing Unit 4 solutions. Let's solve Unit 5 questions. What does a superblock object represent in virtual file system of Linux operating system? In Linux virtual file system, the superblock object will be a key structure that represents metadata about a mounted file system. What about the first option, an open file? Open files are represented by the file object in virtual file system. The superblock does not track individual open files. Instead, it stores global information about the file system itself. So what details will be stored? Block size, inode count, mount options, all these details will be stored. So when they say global information about the file system, this is equivalent to the term metadata. So option 1 will not be the answer. What about option 2? It's an entire file system. This is right. The superblock object represents the entire mounted file system. It contains metadata such as file system type, size of blocks and inodes, root inode pointer, along with the details of mount state and flags. Every mounted file system has exactly one superblock in memory. So the superblock object is used to represent the file system. We are going with option number 2 as the right answer. What about third option, individual directory entry? Directory entries are represented by the D entry object in virtual file system. The superblock does not deal with individual directories, it's higher level. It will describe the file system as a whole, but it will not get into open file or individual directory or even an individual file. So it's only about the whole file system and not about individual parts like individual directories and individual files. The fourth option is also wrong. Individual files are represented by inode objects for metadata like permissions, size, timestamps, and file objects for open instances. The superblock does not represent a single file but it represents the file system that contains many files. So if you take directory entries, it is represented by dentry object, and if you take the files, they are represented by inode objects as well as file objects. So we can rule out option 3 and option 4 for this particular question, but definitely have a learning about all the 4 options. The superblock object is the top level structure in virtual file system that holds metadata about the file system, while other objects like the inode, dentry and file represent files, directories and open file instances. So inode is for files, dentry is for directories and file object is for open file instances. Next question. Consider the following set of processes assumed to have arrived at time 0 in order P1, P2, P3, P4 and P5 with the length of CPU burst given in milliseconds. The burst time is what they have told as length of the CPU burst. The process and the burst time are given and the priority is listed here. If priority column is given, then we must understand it is about priority scheduling. Here the arrival time of all the processes are taken to be at time 0 only. So the scheduling will go as per the priority and not by the arrival time. The question here is, what is the average waiting time in milliseconds using priority scheduling? So let's first arrange the processes as per priority. The first priority goes to P2, the second one goes to P5, the third one is P1, the fourth one is P3 and the fifth one is P4. The respective burst times are mentioned here. P2 with burst time 1, P5 with burst time 5, P1 with burst time 10, P3 with burst time 2 and P4 with burst time 1. Now we will get into priority scheduling algorithm. So this is the order of the process. Now we will start with 0 here. What is the burst time of P2? It is 1. So at 1 millisecond P2 will be completed. What about P5? It will start from 1 and the burst time will be 5. So what is 1 plus 5 here? It will end at 6. At 6 milliseconds P5 will get over. What about P1's burst time? It is 10. So 6 plus 10, it will be completed in 16 milliseconds. Next is P3. The burst time is 2. 16 plus 2 will be 18 milliseconds. And P4's burst time is 1, 18 plus 1, 19 milliseconds will be the completion time of P4. Now we have to calculate the average waiting time. For that we have to know the waiting time. Let me tell you in the format of the formula itself. Turnaround time means completion time minus arrival time. And waiting time means turnaround time minus burst time. Here we know the arrival time of all the process is taken to be 0. So completion time minus arrival time will give you the completion time only. So here turnaround time is equal to completion time. So instead of turnaround time, here we can substitute it by completion time and then keep minus burst time as it is. So how will you get the waiting time here? By finding the difference between completion time and burst time. I am trying to say why I am going to subtract these two columns now. So let's get into the column first. What is the completion time of P1? It is 16. So we have to take these values. What is the P2 completion time? It is 1. P3's completion time is 18. P4's completion time is 19. And P5's completion time is 6. Now for the waiting time, we have to take this particular column and this particular column into consideration. So the waiting time here is 16 minus 10, it is 6. Here we have 1 minus 1, there is 0 waiting time because it is the first process that is getting executed. What about P3? It is 18 minus 2, which is 16. What about P4? It is 19 minus 1, which is 18, because it is waiting for 18 milliseconds and getting executed in the last place. What about P5? It is 6 minus 5, which is equal to 1. So here it is waiting only for 1 millisecond. So take it in this way. It starts at 0, so P2 has 0 wait time. Though it arrives at 0, it starts at 1. So P5 has a waiting time of 1. P1 has a waiting time of 6. P3 has a waiting time of 16 and P4 has a waiting time of 18. Even from this particular Gantt chart, you will be able to find the waiting time. But if you want, you can either take it from this way or you can go with this way. It is completely up to your comfortability. Make sure whichever way you go, you should be able to fill the table soon and get the waiting time. Now what is the question about? We have to find average waiting time. So how many processes are there? There are 5 processes and we have to find the sum now. 6 plus 0 plus 16 plus 18 plus 1. I am listing it in the order of P1 to P5. But if you want to list, you can list it exactly in this order. P2's wait time is 0, P5's wait time is 1, P1's wait time is 6, P3's wait time is 16, P4's wait time is 18. You can even list it in this order. Actually, if you list it in this order, you will have no confusion. But since I have put it in tabular format, I am just using this order. In whichever way you add, you should get the same sum. 6 plus 16 is 22, 22 plus 18 is 40, 40 plus 1 is 41 divided by 5. 8 5s are 40 and you will have 10. So this will be 2. 5 2s are 10. So 8.2 milliseconds will be the right answer. It is found in option number 2. Option 2 will be the right answer. Next question. Given below are 2 statements. One is labeled as assertion and the other is labeled as reason. Assertion says thrashing occurs when a process spends more time on paging than executing. The reason says it happens when the degree of multiprogramming is too low and frames are insufficient. Let's first understand why thrashing is going to happen. When there are too many processes and too few frames, the process will be spending more time on paging itself. This excessive paging is what we call it as thrashing, that is spending more time on paging rather than executing. So thrashing is going to happen when the time is spent more on paging. From this we can say that assertion A is correct. Thrashing is exactly the situation where the CPU spends most of its time swapping pages in and out rather than executing instructions. So assertion is correct. What about reason? They say this thrashing happens when the degree of multiprogramming is too low and frames are insufficient. 2 causes are given here. This is not correct. Why? Thrashing actually happens when the degree of multiprogramming is too high and not too low. When too many processes are loaded into memory, each will get fewer frames. So this part is correct. If frames are insufficient, page faults will keep increasing. When page faults increase, automatically the CPU will spend more time on paging. This will lead to thrashing. This insufficient frames part is correct, but the degree of multiprogramming is too low is wrong. Actually, it should be too high. So this is where the statement goes wrong. So from this we can mark option number 3. A is correct but R is not correct as the right answer. So understand one thing, degree of multiprogramming will be high if more and more processes are loaded into the memory. Only when too many processes are loaded, the frames will become insufficient. Only due to the insufficiency, the page fault will be increasing. This will lead to thrashing. If you say the degree of multiprogramming is too low, all the processes will be using the frames as it is. Page fault will not be occurring frequently and thrashing will never happen there. Only when multiprogramming degree is high, thrashing can happen. So if the reason is given as degree is too low, then this particular process may not happen at all. You have to understand the context of the statement, apply it to the assertion and then find out why it is wrong. This may be a very simple question, but the depth of understanding why it happens, what are the causes, what happens if something doesn't happen, what happens if something happens in a high way, everything you have to compare and see Only then the concept will be retained in your memory for a longer time. Next question. Consider a disk queue with request for I/O to blocks on cylinders 98 183, 37 122, 14 124, 65 67 in that order. If the disk head is initially at cylinder 53, using SSTF scheduling, shortest seek time first scheduling, arrange the following movement of head position in order of traversal. They are asking the order of the request that is being served here. So what is SSTF? This will select the input-output request that requires the least movement of disk arm from its current position. So this will choose the request that is closest to the current head position. So let's take the arrangement. This is the current head position and I have arranged other blocks on the cylinders in ascending order along with head position 53. Now from 53 there are two possibilities. You can go to 65 and you can go to 37. 65 minus 53 will give 12 movements. 53 minus 37 will give 16 movements. Which request is close to the head position? It is 65. So the first request that gets executed will be 65. What is 65 from the option? It is C. So we have started with C. After 65 there are two options. From 65 you can go to 37. From 65 you can go to 67. Since the distance is very less here, from 65 we are moving to 67. The next request that is going to be served will be option A, which is 67. So this is also done. We are going with A in the next place. From 67 there are two directions again, 67 to 98 and 67 to 37. 67 minus 37 will give 30. 98 minus 67 will give you 31. Just a difference of 1 only, but even then this algorithm will choose the least distance. So we are going with 37 as the next request. 37 is available in B. So let's choose B now. After 37 we have two options, 37 to 14 and 37 to 98. From this itself we will know 14 will be the next request. 37 minus 14 is equal to 23. 98 minus 37 is 61. Obviously our choice will be 14, which is available in option E. So E will be the next request. From 14 with no other option we are moving to 98. And so D will be coming in the last. C, A, B, E, D will be the right order. Option number 3 will be the right answer. Next question, which of the following is correct about real-time operating system? A real-time operating system is designed to handle tasks within strict timing constraints. The key features include multitasking, priority-based scheduling, interrupt handling and sometimes fault tolerance. There are 5 statements about RTOS and we will see one by one. The first one, it permits creation of multiple processes within an application. Definitely this must be correct. We have multitasking as the keyword here. So RTOS supports multitasking. This allows multiple processes or threads to run concurrently. A is definitely correct here. What about B? It does not permit priorities to be assigned to processes. This is false, because here we have priority based scheduling as key feature. RTOS does allow priorities to be assigned. It is given as not, so this is false definitely. This is a fundamental for meeting deadlines. It does not permit is wrong. Now what about C statement? It permits a programmer to define interrupts and interrupt processing routines. This is also right. Key feature includes interrupt handling. Interrupt handling is a core feature of RTOS, enabling immediate response to events. So C is right here. What about D? It does not use priority driver or deadline oriented scheduling. When priority scheduling is there and that becomes a fundamental for meeting deadlines, They say it does not use priority driver or deadline oriented scheduling. This is contradicting. RTOS does use priority driven and deadline oriented scheduling to ensure tasks meet timing constraints. D is definitely wrong here. What about E? It provides fault tolerance and graceful degradation capabilities. This is actually partially correct, we can say. Some RTOS implementations provide fault tolerance and graceful degradation, especially in safety critical systems like aerospace or medical devices. However, this is not a universal property of all RTOS. Sometimes fault tolerance becomes a key feature. So this part is fine. But it doesn't mean all RTOS have this particular property. Since there is a possibility of having these properties in RTOS implementations, we are sticking to this particular statement. So we are taking this to be correct only. So E is also right. It's my work to tell you where this statement may fail. But it doesn't mean I am saying that statement is wrong. It is correct. But again, it is not a universal property. So we cannot say it's completely correct in all scope. From this we know B and D are out of the race. Once you know B is actually wrong based on the key features list, you can rule out 1, 2 and 4 completely and go with option number 3, A, C and E only as the right answer. B says it does not permit priorities and D says it does not use priority driver or deadline scheduling. If you actually focus and see this, both points are telling the same thing, that is against RTOS. So keep both the options aside and choose the answer. Next question, match the list 1 with list 2. List 1 is having the types of schedulers. What are the types of schedulers in operating system? We have process schedulers and IO scheduler. Process schedulers are categorized as short-term scheduler, medium-term scheduler and long-term scheduler. IO scheduler is specific for device IO scheduling. So now we have to understand what each scheduler is going to do. Let's start with short-term scheduler. This is a part of CPU scheduling. Decides which process gets the CPU next. This runs very frequently and this uses algorithms like round robin priority scheduling, etc. Now from list 2, try to pick the exact terms. Select which process should be executed next and allocate CPU time. A will be mapping to 2 here. A2 is available only in one option. Next scheduler is medium term scheduler. This temporarily suspends or resumes processes. This is used for swapping, moving processes between main memory and disk, that is swapping. This helps balance load and improve performance. In list 2, the third statement, manage the degree of multiprogramming by swapping processes between main memory and disk storage. This will be the key term that you have to see in list 2. So B will be mapping to 3. V3 is available here. This is also available only in one option. What about C? Long-term scheduler. This is called as the job scheduler. This controls admission of jobs into the system. This decides which jobs enter the ready queue. This runs less frequently, ensures a good mix of CPU bound and IO bound processes. So here the statement in list 2 will be, determine which processes are added to the system for execution level, place them in ready queue. This ready queue is the clue and we know C will be mapping to 1. C1 is also available here. But regarding C and D, they are available in multiple options. For A and B only there are unique options. What about the final scheduler? It is IO scheduler. This manages the order of IO requests to devices. This uses algorithms like FCFS, SSTF, SCAN, CSCAN. All these are disk scheduling algorithms. From this term you must be getting that This focuses on disk IO efficiency and not CPU. So the only left statement is statement 4 here. Order the input or output request from process waiting for IO operations. So D will be mapping to 4. D4 is here. Option number 3, A2, B3, C1, D4 will be the right answer. Next question, match the list 1 with list 2. The terms are in list 1 and the descriptions are in list 2. What about system call? It's a mechanism that allows a user program to request services from the operating system kernel. Example, file handling or process control. So which statement can be equated in list 2? It's a request that a program makes to the operating system. A will be mapping to 2 here. What about the next term? Preemption. The act of temporarily interrupting a running process so the CPU can switch to a higher priority task. The forced deallocation of the CPU from a process. B will be mapping to 3. What is this forced deallocation? Preemption means the operating system is forcibly taking the CPU away from a running process. Why it is taking the CPU? It's because to switch to a higher priority task. It means to allow another higher priority task to get the CPU, it is forcibly taking the CPU away from the running process. Connect it this way and learn. Only then you can understand the meaning and it will be retained in your memory for a long time. You can actually use 2 ways of keeping something in your mind. One way is to completely memorize. The other way is to understand and then put it in your mind. So memorization is for a short time. Understanding and retaining it in the memory is a long time process. For that you have to get the meaning, you have to connect things and then only learn. What about the next term in list 1? It is real-time application. Real-time application means it must respond to inputs or events within strict time constraints. Say for example, we saw real-time operating system. Instead of operating system, just substitute application here. Example, the airbag system in the car. When something goes wrong, it has to come up. Otherwise, there is no use of having airbag. Similarly, medical monitors. When something shoots up like BP or the pulse rate goes down, it should immediately give a beep sound and alert the nurse or the doctor. Else, there is no use of monitoring. So in that way, real-time application has to respond inputs or events within strict time constraints. So here we can take it as a program that responds to activities in an external within a maximum time determined by the external system. C will be mapping to 4. Just with the examples given here, you will be able to understand that particular statement here. Activities in an external environment you can take. Within a maximum time is the airbag has to blow up immediately. The alert by the monitor should be given immediately. This will be determined by the external system. The airbag system is the external system here. Medical monitor is the external system here. What about D? Remote procedure call. A protocol that enables a program to execute procedures on another computer across a network as if they were local. A process requests a function that is located in a different computer system. So D will be mapping to 1. So when you have idea about C and D, you can complete this match. Option number 2, A2, B3, C4, D1 will be the right answer. With this we are completing Unit 5 solutions. Let's solve Unit 6 questions. Arrange the following web app design layers from top to bottom. I think this is the first time they are asking about web application design in software engineering. So this diagram is taken from the reference book only. So here we have user in the top of the pyramid and technology in the bottom of the pyramid. They are asking us to arrange it from top to bottom. Interface design comes first, which is C. Then we have aesthetic design, that is B. Then we have content design, that is D. Then we have navigation design, that is A. Then we have something called performance design. So we know the order is CBDA. So CBDA is available in this particular option. So the CBD order is also retained here, but we don't know where performance is going to sit. For this, you are getting into the story now. Interface design describes the structure and organization of the user interface and includes a representation of the screen layout. A definition of the modes of interaction and description of navigation mechanisms are given there. What about aesthetic design? Aesthetic design is also called as graphic design. This will describe the look and feel of the web application, and this includes color schemes, geometric layout, text size, font and placement, the use of graphics and related aesthetic decisions. How it looks and what you see, how does it make you feel, everything is aesthetic design. So interface is what you see on the user interface. How does it look and how it makes you feel is aesthetic design. Next comes the content design. This defines the layout, structure and outline for all content that is presented as part of the web app, and it establishes the relationships between content objects. The next design is navigation design. This design represents the navigational flow between content objects and for all web app functions. Usually when you take an application, a menu will be there. From there you will be able to traverse to all other parts. So the navigational flow is between the content objects. From your home page you are moving to other page. In terms of web application I am talking, not in terms of mobile application. Next design is architecture design. This identifies the overall hypermedia structure for the web app and encompasses both content and web app architectures. There are two things actually, content architecture and web app architecture. Architectural styles for content will include linear, grid, hierarchical and network structure. So generally it can be linear. Grid structure means everything will be present in this format. So usually when you go for layout, we will follow this format only in web application. Only then it will be easy to design the same way in mobile. If there are 2 or 3 grids in desktop version, in mobile version it will be of single grid placed vertically. That will be the difference. What about web app architecture? This describes an infrastructure that enables a web-based system or application to achieve its business objectives. Sometimes the business will have a website separately and an application that is suited for mobile separately. I mean the smartphone. But for some business, whether you open it in a website or whether you open it in your smartphone, both will be giving the same kind of interactivity. That is the web app architecture they say. It can either enable web-based system or an application-based system. How you handle in your smartphone, the same way you will be handling in your system. Till Windows 7 it was completely desktop oriented. The desktop version will be completely different. The Windows mobile version will be completely different. Windows 8 is a smart move by the company where they integrated same kind of experience for both the users. So architectural design is about what kind of structure is done for web-based system or application system. The next one is component design. This develops the detailed processing logic required to implement functional components that implement a complete web app function. So why is it coming in the final places? It is going to implement it as a whole part, and that is close to the technology, while interface design is close to the user. What user sees is maximum this much or this much, and the content this much along with the navigation. These two parts actually decide how far the first 4 layers will work. If the grid structure is not proper, or if the web-based system doesn't give a proper infrastructure, whatever and however you have designed, nothing will be going to the user. So performance means architecture and component together. Performance design usually relates to architecture or component design layer at the base, since performance depends on system design and efficiency. Since we are getting into architectural level here and also the implementation of the complete web app function, we can take this to be performance design. So performance design will be in the bottom of the layer, so we can place E here. C, B, D, A, E will be the right order. Option number 1 will be the right answer. Next question. Given below are two statements. One is assertion and the other one is reason. What is assertion? Higher cyclomatic complexity indicates a more complex program. What about the reason R? It is calculated based on the number of independent execution paths in the program. R is perfectly right regarding cyclomatic complexity. But is assertion correct? Let's see. Assertion is correct. Cyclomatic complexity is a software metric that measures the complexity of a program based on its control flow. A higher value means more branching and decision points, which makes the program harder to test, maintain and understand. So in this way we can say it is indicating a more complex program because it is involving more branching and more decision points. So definitely assertion is correct. What about reason? This is also correct as we already saw. Cyclomatic complexity is defined as the number of linearly independent paths through a program's source code. That is exactly mentioned here as independent execution path. So R is also correct. So we can rule out 3 and 4 here. More independent paths means more branching and more complexity due to more branching. When you have higher cyclomatic complexity, it means there are more number of independent paths. When there are more number of independent paths, it means it has more branches, more decision points. When it has more decision points and more branching, what does it indicate? It indicates more complexity. So since the reason is directly explaining why higher cyclomatic complexity means higher program complexity, we can say R is the correct explanation of A. We can rule out even option 2 and say option number 1 will be the right answer. Next question. Which of the following statements are correct? The question stops here. This is a separate part regarding task elaboration in interface design. This part doesn't belong to the question at all. So we will go only with this. Regarding alpha, beta or acceptance testing, this will happen during testing or validation phase. This comes later, as well as this is system focused. Whether the product is working properly as per the user's requirement. This question is system focused while task elaboration is user focused. Let's start with the software testing methodologies. First one is alpha testing. The statement is alpha testing is done at the developer's site in a controlled environment. This is perfectly true. Alpha testing is typically internal at the developer's location before releasing to external users. So definitely A is correct. What about B? Beta testing is done at the end user site with developer presence. Till here it is fine. After that people are not fine with the statement. Beta testing is done in real user environment. This is right. End user site is real user environment. They say it is with developer presence. We will come to this discussion later. We will go for C. Acceptance testing may be very formal and last for weeks. This is correct. It is sometimes contract driven and can last for weeks depending on the scope. So this is also fine. What about D? Alpha testing always replaces beta testing. It's not so. We have to start with alpha testing and then go for beta testing. First it will start at the developer's location in a controlled environment. Then it will move to the end user location and there the environment might not be controlled. This is the exact difference. So D is incorrect. Alpha and beta testing are complementary, not replacements. Alpha comes first, then beta. So D is definitely wrong. In the options, we have either 3 statements or 4 statements. Definitely D is wrong. Based on D, we can rule out 2, 3 and 4. They have marked option 1 as the right answer in the official answer key. Now let me justify about this beta testing. Why did they give with developer presence and why did they make it correct? Beta testing is actually done at the end user location. The environment is completely theirs. What will actually developers do with beta testing? Do you think from beta testing directly the application will go live? No. From beta testing, after allowing the users in uncontrolled environment, developers will be observing and capturing feedback accurately. Based on that, supports will be provided if needed or changes will be done accordingly. The term with developer presence. This part states that developers need to be present to observe, support and capture feedback accurately. So in what context is this particular statement given? It is given in the context that beta testing doesn't mean it is completely live with the user. The user will work, but even then the developer will be collecting feedbacks, monitoring things, observing how end users react with the application or with the particular design or with the system, and wherever possible support will be given to the end users. It doesn't mean that they will be present and they will control the end users. So we are going with option number 1, ABC as the right answer. Now this question is over. We have an additional task here. What is task elaboration? Task elaboration is a user-centered design activity. It focuses on breaking down and analyzing the tasks that users need to perform with the system, so the interface can be designed to support them effectively. What are the methods used here? Task analysis, storyboards or use cases, prototyping based on task flows. So how the system will look, those prototypes. In task analysis, we have hierarchical task analysis, cognitive task analysis. There are types. I didn't get into the detail. Now take it in another way. After doing with interface design, if they are going to get into alpha testing and beta testing, in that case also they can mention task elaboration here. When official answer key comes, sometimes we have to mend our ways to have another kind of understanding. So there is a possibility of justifying this question too. Next question, match the list 1 with list 2. It's about the types of coupling and the description here. So what is coupling? It's a qualitative measure of the degree to which clauses are connected to one another. So what is content coupling? This exists between two modules if they share code. That is, a jump from one module into the code of another module can occur. What about control coupling? This exists between two modules if data from one module is used to direct the order of instruction in another. An example of control coupling is a flag set in one module and tested in another module. We have already discussed about this coupling types in previous year question paper, so that's why I didn't want to repeat the explanation. Next comes stamp coupling. Two modules are stamp coupled if they communicate using a composite data item such as a structure in C. What about data coupling? Two modules are data coupled if they communicate using an elementary data item that is passed as a parameter between the two. Data coupling is with data item and they say it is passed as a parameter. We can map this to fourth statement. Passes long list of data arguments. What about stamp coupling? They have mentioned composite data item. So this is individual data items or elementary data items, that is data coupling. But here it is mentioned as composite data items such as structure. So we have uses entire structure or class as argument. We can map stamp coupling to uses entire structure or class as argument. What about control coupling? We have a keyword here, flag set in one module and tested in another module. So here pass control flag to influence logic. It means it is set in one module, means it has one value in that particular module. When they are tested in another module, it can be updated or due to that update the logic can be changed too. Something when I set as false in one module can change to true in another module. But when it becomes true, the logic might be completely changed. So here we can take it as pass control flag to influence logic. So when you want to modify the logic or bring some change in the logic, using a control flag, that is control coupling. What about content coupling then? When you are going to share code in terms of coding we can say. Otherwise we can say it can modify internal data of another component. When you are able to touch the data of another module, that is content coupling. We can map content and data here, control and flag here, stamp and structure here, data and data arguments here. Content coupling will be modifies internal data of another component. A is mapping to 1, B is mapping to 2, C is mapping to 3 and D is mapping to 4. Option number 4 will be the right answer. Next question, match list 1 with list 2. Software process models are listed in list 1. List 2 has the characteristics of models mentioned in list 1. The V model follows the classic life cycle where each development phase has a corresponding testing phase. This ensures verification and validation are done at every step. A will be mapping to 2. What about incremental process model? Incremental model will deliver a core product first. Then gradually it will add features in increments, making the system usable early and it will get improved over time. So the core product will be given first, then additional features will be added little by little. At the end of the development, the system will be given as a whole. But what you need first, that part will be delivered first. That's what they say as core product. That is the key characteristic. B will be mapping to 4. A to B4 is available only in one option. Now we will get into spiral model. When we learnt about spiral model in the previous year question papers, we know the characteristic is risk driven. Spiral model is risk driven, focusing on identifying and reducing risks through repeated cycles of planning, prototyping and evaluation. So C will be mapping to 3. What about D? Concurrent model. This uses trigger transitions, meaning activities overlap and progress dynamically with states changing based on conditions rather than strict sequence. When you change states based on conditions, you are triggering transition. Transition means moving from one state to another state. Triggering transition means based on the condition you are making a change. Trigger transition is equivalent to state change based on conditions. You can take the meaning in this way. So concurrent model will be mapping to trigger transition. D will be mapping to 1. Option number 4 will be the right answer. Next question. From here for the next 5 questions, we will be using this particular paragraph. A project is planned for an enterprise accounting system with an estimated size 60 KLOC. KLOC means kilo lines of code. So it is 60,000 lines of code. The organization applies basic COCOMO, semi-detached mode with parameters. They have given some details here. Effort is equal to 3.0 into KLOC power 1.0. Development time is equal to 2.5. Effort power 1 by 2. So this 1 by 2 is square root of effort. Average cost per person month is equal to $10,000. A contingency margin of 10% effort is mandatory. The client demands a detailed schedule if staff is kept at 15 engineers. Answer the following 5 questions based on this paragraph. Let's start with the first question. What is the initial effort in person month before adding the contingency margin? Basic COCOMO effort estimation formula for semi-detached mode is given in the paragraph itself. For this question we are using this formula. 3.0 into KLOC power 1.0. So let's take 3.0 into KLOC value is 60. So this is KLOC and here also it is in KLOC. So we will have 60 power 1.0. 1.0 can be taken as 1 itself. So this is 3 into 60 which is equal to 180. They have asked in person months. So effort is mentioned in person months. 180 pm will be the right answer. Option number 3 will be the right answer. Next question. What is the estimated development time in months? So what is the development time formula here? 2.5 into effort to the power 1 by 2. Estimated development time required based on the square root of the effort. Effort power 1 by 2 is nothing but square root of effort. We have computed effort is equal to 180 person-months in the previous question. So this can be taken as 2.5 into square root of 180. So what is square root of 180 here? So we have to go with approximate value only. Let's take 12 square, which is equal to 144. 13 square is 169. 14 square is 196. So the value will be sitting between 13 square and 14 square. So let's take it as 2.5 into 13 here. This will be 32.5, and when you take 2.5 into 14, we have 35 here. We said 180 is lying between 13 and 14. So for 13 we have 32.5 and 14 we have 35. Which value is lying between these two? 34 months is actually lying between these two. So the answer will be option number 3, 34 months. When you are not able to compute square root of a number, you can go this way. So let me give you the value of square root of 180. The value is 13.416. When you multiply it by 2.5, you will get a value of 33.54 months, which is approximately equivalent to 34. Next question. What is the implied average staffing level? We have two values from the previous question. Effort is equal to 180 person-months and development time is equal to 34 months. So they are asking for this effort and for this development time, what is the implied average staffing level? The average number of engineers needed is given by dividing the total effort in person-month by the development time in months. So effort is equal to 180 person-months. What is the development time? It is 34 months. We can cancel months and months, only persons will be remaining. So here instead of persons they have mentioned as engineers. That is the only difference. What is 180 divided by 34? It is 5.29. So we have to drop this 0.29 because we are going to count the number of engineers. So we can go with option number 2, 5 engineers. This is approximately equivalent to 5. So we will go with 5 engineers as the right answer. This particular formula actually we should know because it is not given here. Average staffing level will be effort divided by development time. Next question. If the staff is capped at 15 engineers, what is the revised calendar duration? For earlier effort of 180 person-months and development time 34 months. This is the duration. The staff level was 5 engineers. In case if the number of engineers is going to be increased, they are asking for the revised duration. It means the revised development time. With a fixed team size, the total effort is divided by the number of engineers to get the new duration. Earlier we calculated staff is equal to effort by development time. Now they are asking the development time. So this development will have the formula effort divided by staff. So what effort is this? We have to use adjusted effort, only then we will get the revised duration. What is this adjusted effort or total effort? For 5 engineers to work for 34 months, it's 180. But now the staff level is changed to 15. We have to change the effort accordingly and then find the duration. The question asks for the revised duration. That includes the 10% contingency margin. So here we are going to use this particular hint. when they are asking for extra engineers, you have to include the 10% effort. Adjusted effort is equal to effort with margin. What is effort with margin? Effort plus 10% of effort. What is the effort? It is 180. What is 10%? 10 divided by 100 into 180. 0 and 0 will go, 0 and 0 will go. So this will be 180 plus 18, which is equal to 198 person months. Now we will be using this particular formula. Adjusted effort will be 198 person months divided by the staff is given as 15 engineers, which is 15 persons. The person units will go 198 divided by 15. This will be 13.2 and the remaining unit will be months. 13.2 is available in option number 3. Option 3 will be the right answer. So here they have given the client demands a detailed schedule if staff is capped at 15 engineers. So this part is actually mentioned in the question asking for the revised duration. The 10% contingency margin is mandatory, meaning the client expects the project to absorb that extra effort for risks, rework or unforeseen tasks. And since they have mentioned it as mandatory, must be applied, we are adding that 10% to the existing effort and making it to 198. Say there are 180 person months divided by 15%. The value is 12 here. This is 12 months. When we have 198 person months divided by 15%, we have 13.2 months. So without applying the margin, it is giving 12 months. After applying the margin, we get 13.2 months. That is what is mentioned here. So the margin directly stretches the timeline unless you increase staffing, which is capped. Capped means maximum 15 engineers are allowed here. So I am just giving you the difference between the two values. If you don't increase the effort using the margin, you will not end up with the right answer is what I am trying to tell you. Now the final question for this particular paragraph as well as for the unit is, including 10% contingency margin, what is the project cost? So here average cost per person month is $10,000. This is for one person month. Here how much person month is mentioned? 198. To get the project cost, multiply the adjusted effort with 10% margin. This is already calculated in the previous question by the cost per person month, which is mentioned in the question. Project cost is equal to effort with margin, that is the adjusted effort, which is equal to 198 person month into cost per person month. What is cost here? $10,000. Since it is given as per person month, we will put it here. So this unit and this unit will go. Now we will keep the dollar symbol as it is. 198 with 4 number of zeros. When you express Indian values, that is for rupees, take 1 lakh. We will first split it with 3 zeros, then we will split it with 2 zeros. This is for our system or Indian system. When you go for dollar, you have to go with 3. That is, we will take 3 units for 1 comma. So in that way, if we take this is 1 comma and this is 1 comma. This is 1 million. 10 lakhs in Indian system is actually 1 million. So this can be represented as 1.98 million. I am just telling you how we got 1.98. Based on the options given, you can easily rule out 1, 3 and 4 because 198 occurs only here with decimal point. 1.98 million. Million means here it is 10 to the power 6. So apply 1.98 into 10 to the power 6. 198, 1, 2, 3, 4, 5, 6 and in point we are taking 2 zeros. Did we get the same value as here? Yes. So $1.98 million will be the right answer. Option number 2 will be the right answer. Hope you understood how we calculated project cost. This set of questions are taking values from the previous questions. So if the questions come in order, it will take minimum time only to solve it. But if the questions are not in order, then you have to calculate accordingly and then use it in the other questions. It's better you use the question ID to find which has to be solved first. It will take additionally 1 or 2 minutes. I do understand that. I don't deny. This 180 became 198. From 198 only we are calculating this. If you don't have this particular flow, then for every question you have to calculate it again and again. That's why I am telling you this particular point. With this we are completing Unit 6 solutions. Let's solve Unit 7 questions. The in-order and pre-order traversal of binary tree are DBEAFCG and ABDECFG respectively. So the first traversal is in-order here and the second traversal given here is pre-order. We have to take it in the respective order. The post-order traversal of the binary tree is, using the in-order and pre-order we have to construct the binary tree. And from the constructed binary tree, we have to find the post-order traversal. This is what we have to do in this particular question. So let's have a recap of the binary tree traversals. So what will be the order of pre-order? It is root left right. Usually we will say data left and right. So here I am mentioning it as root left and right. The order of in-order will be left, root and right. What about post-order? It is left, right and root. So they have given us pre-order as well as in-order traversal and we have to find this post-order traversal after binary tree is constructed. So let's look at the steps and we will go one by one. First we have to identify the root of the tree. For that we are going with pre-order traversal first. The first element in pre-order is always the root. So what is the first element in pre-order? It is A. A will be the root here. So let's take A here. This is going to be the root of the tree. This step is done. Now we have to split in order. Find the root in the in order sequence. Where is the root? It is present here. Elements to the left of the root will be the left subtree. So let's take the root A. What are the elements in the left side? It is D, B, E. The elements to the right of the root will be the right subtree. We have F, C, G here. So all these three will go to the right subtree. This is from the in-order traversal. This step is done. Now we have to go for pre-order. We have to divide the pre-order. After the root, after A, the next elements in pre-order correspond to the left subtree. So how many elements you have to consider here? It has to be in the same length as left part of in order. How many elements are there in the left part of in order? There are 3 elements. So you have to take the next 3 elements after A. What are the next 3 elements after A? They are B, D and E. They will form the left subtree. So from pre-order, we are taking the left subtree as B, D, E. Remaining elements correspond to the right subtree. So we have C, F, G here. The right subtree will have C, F, G as the elements. So we have divided the pre-order into left and right now. We have to recursively build subtrees. We have to apply the same logic to the left and right subtrees. So let's start with B, D, E. We will take the left subtree first. Whatever we arrange here will be occurring in the left side and whatever we arrange here will be occurring in the right side. So let's take B, D, E. What we have to do? The first element in pre-order is always the root. So what is the root here? It is B. So let's take B here. We have to split in order. In order, just choose B. Element to the left of the root will be left subtree. Element to the right of the root will be right subtree. If you don't have clarity in this particular order, you can look at this diagram. This is going to be the in order part. B is going to be the root. The element that is left of B will be left subtree. The element that is right of B will be right subtree. So here for B we will have D as the left subtree and E as the right subtree. I am just telling you in the context of subtree, even though there is only one element, so that we will exactly follow these steps. From where is this subtree constructed? From the root. So from the root we will put B here, and from B we will go for D and then for E. Now left subtree construction is over. You can take little by little, and then wherever you have to join it, you can put it in the main tree. So maintain two trees, one for complete construction and another for splitting and working. Now we will take the right side because they have asked us to use the same logic for both left and right subtrees. The right subtree has C, F, G. So let's start again. The first element in pre-order is always the root. What is the first element? It is C. So C will be the root of the tree. And we have to identify C in the in-order traversal. It is here. The element that is left of root will be left subtree and the elements to the right of root will be right subtree. So F will be left and G will be right. So let's take F and G here. Now we have to place this right subtree in the main tree. So let's take C. Here we will have F and here we will have G. Now let's check whether in-order and pre-order traversals are right because the tree construction is over. Let's take pre-order. We have to go with root left and right. So what is root? It is A. What is left? It is B. From B again we have to go for D because this is root left right. Similarly, this is root left right. So this will be B, D, E. Then coming to the right side, here also we will follow the same pattern. It is C, F, G. Did we get the same pre-order here? A, B, D, E, C, F, G. Yes, pre-order is correct. Now let's check for in-order. In-order will be left, root and right. Which is the leftmost branch here? It is D. In-order will start from D. D, B, E. After completing the left side, now we have to specify the root, which is A. Then for the right side, again you have to go for left, root and right. This will be F, C, G. Did we get the same order? D, B, E, A, F, C, G. So in order and pre-order are correct. So from this, we have to find the post-order traversal. So for post-order, we have to go to the left, right and the root. So what is the left here? The extreme left you have to come. It is D. Then we have right, that is E. Then we have the root, which is B. This is for the left subtree. Now this part is done completely. After the left side, we have to process the right side. So we are coming to this particular tree. Again we have to go with left, right and root. So here left it will be F, right it will be G and root it will be C. Now left is also done, right is also done. What is remaining? Root. So it will come to the last place. In pre-order, the first element will be the root. In post-order, the last element will be the root. So this will be the order. D, E, B is present here, F, G, C is here and A is here. Option number 1 will be the right answer. Option 1 is the post-order traversal of the constructed binary tree. When they say recursively build subtree, you have to use this particular logic, these 3 steps, 1, 2 and 3 for the left subtree and the right subtree. Since we have ended up with only one element in left and right, we have stopped with this particular step. If there was more than one element in the left side or right side, then we would have gone for divide pre-order. Next question. Which of the following is correct solution of the given recurrence relation? T of n is equal to 3 into t n by 4 plus n log n. Usually I will give 2 Master's theorem for such kind of questions and we will try to solve the question using both the Master's theorem. But for this particular question, we are going to work with this particular master theorem. So this time I thought we can do it in a detailed way so that additional understanding can be given. The recurrence is of the form T of n is equal to A into T n by B plus f of n. A will be the number of subproblems, B will be the factor by which the problem size gets reduced, and f of n will be the additional work or the extra work that is done outside recursion. So whatever is given in A into T n by B will be of recursion, and whatever is given in f of n will be the work that is done outside recursion. From the given question, what you can infer is the value of A is equal to 3 because it is given as A into T, and the value of B is equal to 4 because it is given as n by B. For such problems where we have f of n is equal to n log n, we have to start with finding threshold. Threshold is nothing but we have to find the value of n power log A to the base B. After finding the threshold value, we have to check whether value of log A to the base B is less than 1, equal to 1 or greater than 1. Based on that only we will be picking the case that is given in the asymptotic bound of Master's theorem. So let's first start with finding the threshold. So what is the threshold? N power log A to the base B. Now let's not consider n, but we will stick to log A to the base B. What is A value? It is 3. What is B value? It is 4. What is log 3 to the base 4? So when it is log some value to the base 2, we will make it as 2 power something. That is equal to this value. From this we will be finding x. When it is log base 4, we will have 4 power x, which is equal to 3. So this question mark and this x is the same. How will we find x? The correct value of log 3 to the base 4 will be 0.79. So how can we calculate without getting into the logarithmic table? If x is equal to 0, 4 power 0 is equal to 1. When x is equal to 1, 4 power 1 is equal to 4. 1 is less than 3 but 4 is greater than 3. It means the value of x cannot exceed 1. What is the other possibility of x is we can take the value 1 by 2. What is 4 power 1 by 2? It is square root of 4. This is equal to 2. Now the value 3 is lying between 2 and 4. So let's take a scale. This is 1, this is 2, this is 4. Let's have the x value 0, x value 1 and x value 1 by 2. Now 3 is going to lie here. So the value of x will range from 0.5 to 1. Since it is exactly in between, we can take this to be 0.75, which is nearer to 0.79. So from this we can take the value as 0.75 or 0.79, which is the exact value. Now we will have n to the power of log 3 to the base 4 will be n to the power of 0.75 or 79. In asymptotic bound, we have value called n power 1, which is equal to n. So here we can say n power 1 grows faster than n power 0.75 or 7. In order to make this power to a whole number to 1, what you have to do is along with 0.75 you have to add epsilon to make this to 1. So this format is available in case 3. Let's take the case 3. If f of n is equal to omega of n power log a to the base b plus epsilon for some constant epsilon greater than 0, and if a into f of n by b is less than or equal to c into f of n for some constant c that is less than 1 and all sufficiently large n, then the solution T of n is equal to theta of f of n. Now what is the relation between f of n and n to the power log a to the base b? The theorem has 3 cases depending on how f of n compares to n to the power log a to the base b. They say f of n is smaller than the threshold, f of n is less than or equal to n to the power log a to the base b. This is what we have to compare here. F of n is n log n less than or equal to n power 0.7. Is this right? N power 1 is less than 0.7? No. N power 1 is equal to n power 0.7? No. N power 1 is greater than n power 0.7. This particular part is correct. So, we are sticking to case 3. This case 3 is nothing but this part. So, based on the given f of n from the question and based on the threshold value, we are just making comparisons here, and out of the comparison, we are getting case 3. So, we are going with case 3 here. Understand one thing, when f of n is smaller than threshold, recursion is getting dominated. When they are equal, they are balanced. When f of n is larger than the threshold, extra work is dominated here. It means more than the recursion, this extra work is of more work. It means the t of n will rely on this particular f of n only. Without further computations, you can conclude t of n is equal to theta of f of n. What is f of n here? It is n log n. This will be the solution for the given recurrence relation. I am not checking any of the conditions here. Whether this particular condition is true or not, whether this is true or not, I am not checking anything. Just based on the cases, I am concluding it is of case 3, and based on case 3, we are concluding that this is the solution of the given recurrence relation. So, this solution is perfectly matching in option 1. Option 1 will be the right answer. But I will give you the detailed working so that it can be useful for you in some other question paper. So, let's take n log n. We have omega, then we have n power 0.7 plus this particular epsilon value. It is in this format. What does this particular statement say? It says that n log n grows faster than n power 0.792. So, that is what we mention as f of n is larger than the threshold, where extra work is getting dominated. Now, we will work it out in an elaborate way so that we will understand how t of n is equal to theta of f of n. Let's verify regularity condition. What is the regularity condition? They have given some condition here. A into f of n by b less than or equal to c into f of n. Now, the only value that we have in our hand is f of n is equal to n log n. Now, what we will do is we will bring this particular f of n to a into f of n by b. So, what you should do for this particular f of n? You have to divide it by b and then multiply it by a. If you do this, then it will be changed to this particular format. What is divide by b? It is dividing n by 4. What is into a? It is multiplying f of n by 3. So, instead of a we are going with 3. Instead of n by b we are going for n by 4. Now, we will have f of n by 4 is equal to, now we will apply it here, n divided by 4 into log of n by 4, log of x divided by y. This will be log of x minus log of y. So, we are going to apply this formula here. N by 4 will stay as it is and this will become log n minus log 4. The value of f of n by 4 will be this one. Now, we have to multiply f of n by 3. So, 3 into f of n by 4, which is equal to 3n by 4, and we are not going to touch the log part. So, let it be as it is. So, we have brought this to this particular format, and let's take this to be the LHS and this to be the RHS. Now, this is the LHS. What about RHS? Let's take c into f of n, which is equal to c into n log n from the question. This is going to be the RHS. Now, we will equate the right hand side of LHS as well as RHS. So, let's take 3n divided by 4. Then we will have log n minus log 4, which is equal to c into n log n. We have n in both the sides, so we will cancel n. This will be 3 by 4 log n minus log 4, and here we have to maintain the inequality, so we will have this as less than or equal to, and here also we will have less than or equal to, because we have to maintain this inequality. Now c into log n will alone be staying this side. Now let's compare log n and log 4. As n grows, what happens? Log n will be dominating log 4. Since log n is going to dominate, we can neglect log 4 part. So this particular inequality will be changing as 3 by 4 into log n less than or equal to c into log n. So from here we can cancel log n and log n. This will be 3 by 4 less than or equal to c. So what is 3 by 4? It is 0.75, that is less than or equal to c. Now we have to check whether c is less than 1, because they have given this particular inequality. If this inequality is true for some constant c less than 1. So let's have a value 0.8. Check in this equality. 0.75 is less than or equal to 0.8. Is it true? Yes. Then we'll go for c is equal to 0.9. 0.75 is less than or equal to 0.9. I can take any value. I am just telling how to compare. Both are correct. So definitely c is less than 1 only. So here, since we have a value less than 1 in the left hand side of the inequality, we can be very sure that c is also less than 1. Because we have numbers that are greater than 0.75, which is less than 1. So between 0.75 and 0.99 we have lots of numbers. Those values can be taken for c. Definitely c is less than 1. So we can say this satisfies the regularity condition. Since it has satisfied the condition, we can conclude that t of n is equal to theta of f of n. So without checking, here we concluded, because based on case 3 statement here, we found that extra work is getting dominated. That's why we are going with this particular complexity. But here, after solving this, we are concluding the solution of the recurrence relation will be theta of, what is f of n? It is n log n. So this will be the solution to the recurrence relation. So the answer will be option number 1. Next question. Consider B plus tree in which the maximum number of keys in a node is 5. What is the minimum number of keys in any non-root node? Any non-root node means you can take it for internal nodes. A B plus tree is a balanced search tree widely used in databases and file systems, where all data records are stored at the leaf level and internal nodes only guide the search. This will be key 1, this will be key 2, and these all will be connected to some root node here. These are the leaf nodes where the data records are stored. So data records are stored at the leaf level only, and such internal nodes are helpful for guiding the search. So this will be the root node. Any node other than root and leaf will belong to non-root node. Suppose the maximum number of keys per node is equal to k. So they have given maximum number of keys. So k value is equal to 5. For non-root internal nodes, the minimum number of keys is equal to minimum number of children minus 1. What is minimum number of children? It is k plus 1 divided by 2 ceil function. Whatever you calculate for minimum children, minus 1 will be minimum keys. So the question is asking for minimum number of keys. So let's see what are the other details given. The maximum number of children per internal node will be k plus 1. 1 more than the maximum number of keys. For leaf nodes, the minimum number of keys will be k divided by 2 in ceil function. It means when you have 2.1 or 2.5, it will be raised to 3. When you have floor function, 2 point any value will give you 2. But in ceil function, 2 point some value will be raised to 3. This can be 2.74, but floor value will be 2 only. Here seal can have 2.37, but still it is raised to 3. So here seal of k by 2 in case of leaf nodes, but for non-root internal nodes the case is minimum children minus 1. So let's go for minimum number of keys is equal to minimum children minus 1. Why am I going with minimum children minus 1 is through this you can even learn minimum children count. So what is minimum children? Seal of k plus 1 divided by 2 minus 1. So let's have the seal notation here. K plus 1 is 5 plus 1 divided by 2 minus 1. So this will be 6 divided by 2 in seal minus 1. 6 divided by 2 will be 3 in seal minus 1. So this is 3 minus 1 which is equal to 2. There are minimum 2 keys in any non-root node. Option number 2. 2 will be the right answer. You can have some more idea on B plus trees for your learning. Next question. How many number of comparisons are required in worst case to find out second smallest element of n elements list? To find the smallest element among n elements, we will need n minus 1 comparisons. Compare each new element with the current minimum, we can say. The second smallest must be one of the elements that lost directly to the smallest. Any element that lost to another element but not the smallest is guaranteed to be larger than the winner and thus cannot be the second smallest. The smallest element will win against seal of log n opponents. The minimum number of comparisons needed to reduce n elements to one winner is logarithmic in n. So the number of candidates for second smallest will be seal of log n. They say for n number of elements we will need n minus 1 comparison. This is in case of finding the smallest number. But for finding the second smallest, the population will not be all the n elements. The population will be seal of log n only, they say. When you take the smallest number, all the elements will be in the competition. But for the second smallest number, whichever element has lost to the smallest, those elements alone will be taken. I will give you an example, you will understand it better. So the number of candidates for second smallest will be seal of log n. To find the minimum among seal of log n candidates, we will need seal of log n minus 1 comparison. So for n elements, you will need n minus 1 comparison. For seal of log n elements, you will need seal of log n minus 1 comparisons. They are asking for the number of comparisons in worst case. It means you have to add up these two. N minus 1 comparisons plus seal of log n minus 1 comparisons. N plus seal of log n will be here. Minus 1 and minus 1 will be minus 2. This will be the number of comparisons in worst case to find out the second smallest number. This is available in option number 4. Option 4 will be the right answer. Now let's take an example. We will have 4, 8, 9, 1, 3, 5. Instead of comparing it in bubble sort way, we will do it in a way for which we will understand this particular paragraph. Okay, first let's take comparisons between the main elements. We will compare 4 and 8, which is smaller, 4 is smaller. We will compare 9 and 1, 1 is smaller. We will compare 3 and 5, 3 is smaller. Then in the second thing, we will compare 4 and 1, 1 is smaller. Then between 1 and 3, we will have 1 as smaller. So all together, 1 is the smallest element. How many comparisons have occurred? 1, 2, 3, 4, 5. So the number of elements is equal to 6 and comparisons to find the smallest will be n minus 1, which is equal to 5. So here there are 5 comparisons. 1, 2, 3, 4, 5. This part is true. Now for the second smallest, who lost to 1? Which elements were compared with 1? this one and this one. Now pick these three elements alone, 9, 4, 3. All these three elements have lost to the smallest element. Any element that lost to another element other than 1 is guaranteed to be larger than that winner and thus cannot be the second smallest. So we are not considering 8, 5 and all. The second smallest element must be one of the elements that lost directly to the smallest. That is what we did now. The smallest element wins against these opponents only. So what is seal of log n? What is log 6 value? We have to take log to the base 2, right? So what is 2 power x is equal to 6. So let's have 2 power 1 is equal to 2, 2 power 2 is equal to 4, 2 power 3 is equal to 8. So 6 is lying between 4 and 8. The value will be between 2 and 3 for x. So 2 point something. When you have seal of 2 point some value, what is it? It will be 3. Log n in seal will be equal to 3. So how many candidates are there for second smallest? It is 3. Just count 1, 2 and 3. This is what they say. The minimum number of comparisons needed to reduce n elements to one winner will be logarithmic in n, which is log n. So the number of candidates for second smallest is equal to seal of log n, which we have brought to 9, 4 and 3. Now we will do comparison. 9 and 4, which is small here? 4. Then 4 and 3, which is small here? 3. How many comparisons are done? 2 comparisons are done here. So what is the comparison that is done for second smallest? It is log n minus 1. So log 6 minus 1, which is equal to 3 minus 1, 2. So 2 comparisons are done. So what is the second smallest element in this particular list? It is 3. So 1 is the smallest and 3 will be the second smallest. Now add all the comparisons together. We have 6 elements. Then the value of log n is 3 minus 2. 6 plus 3 is 9. 9 minus 2 is 7. Just check whether we needed 7 comparisons for finding 3. So let's take 1, 2, 3, 4, 5. Here it is 6 and 7. So in 7 comparisons, in the worst case we are saying 7 comparisons are needed to find the second smallest of n elements. So along with the example, if you see the statements, you will understand it better. Next question, which of the following is correct order of increasing time complexity of algorithms? We have Tower of Hanoi with n disk, binary search given n sorted numbers, heap sort given n numbers at the worst case, addition of 2 n cross n matrices. We will start with the smallest one. Binary search with n sorted numbers. Each step halves the search space until the element is found. So the complexity will be big O of log n. They have asked for increasing time. It means in ascending order. So B will be the first one. There is only one option starting with B. The next one will be heap sort. Here n numbers are given and they are asking for the worst case. Building the heap will take big O of n and each of the n extractions will require big O of log n. So the time complexity will be big O of n log n. C will be coming next. Then we will go with addition of 2 n cross n matrices. N cross n matrices means we definitely know there will be n square entries. So the time complexity is big O of n square. Make sure D is not coming before B in any of the option. Here D is coming before B and D is coming before B. Just between binary search and addition where we will have minimal idea, for that itself you can rule out 2 options. Each of the n square entries requires a single addition. That's why we are going with big O of n square here. Now Tower of Hanoi with n disk. Recursive solution requires moving 2 power n minus 1 disks. So the time complexity will be very huge, big O of 2 power n. So this will be in the final place because it is of increasing order. We will rule out even this. A cannot be in the first place because it is going to have the highest complexity. So this part is definitely wrong. Option number 1, BCDA will be the right answer. What is Tower of Hanoi here? The Tower of Hanoi problem is about moving n disks from one peg to another using a third peg as auxiliary following the rules. Move only one disk at a time and never place a large disk on top of the smaller one. You can take this as stack. Take 2 stacks and there will be different disks here. You have to arrange it in such a way that you have to move only one disk at a time and the larger one should not be placed on top of a smaller one. So the order will be in this way only, and you can use a third stack as auxiliary. You can use another one as auxiliary. Maybe when you get a big one you can put it here, and then when you get a small one you can place it in auxiliary, and when the right time comes you can place it in the main stack. So Tower of Hanoi problem will take the largest time complexity because it involves recursive solution moving 2 power n minus 1 disks. Next question. Arrange the following algorithms from the most efficient to least efficient based on their time complexity. Most efficient means the complexity should be less. Least efficient means it should have more time complexity. So let's start with the least one. We have Kruskal, BFS, Bellman-Ford, Dijkstra's and Edmonds-Karp algorithm. Which one comes first? It is BFS. This traverses a graph level by level using a queue. So the time complexity will be linear in vertices and edges with big O of V plus V. It will be starting with B. So we can rule out option 2. Vertices plus edges together. This will be coming first. Then comes Dijkstra's algorithm, the shortest path algorithm. This finds shortest path from a source to all vertices in a weighted graph, that too non-negative weights. There are 2 complexities, one for the binary heap that is implemented using priority queue, and another heap will be Fibonacci heap. In binary heap we will have E log V, and in Fibonacci heap we will have E plus V log V. This requires more operations than a simple BFS due to priority queue management. So compared to BFS, this is taking extra time. But here for Dijkstra's itself, there is possibility of having 2 complexities based on the heap it is going to implement. So let's go for the next one. It is Kruskal's algorithm. This finds a minimum spanning tree by sorting edges and adding them greedily if no cycle forms. So here we have sorting edges and adding them greedily, and we have to check whether cycle formation is there or not. The time complexity is big O of E log V. Its efficiency is primarily dominated by the time required to sort all edges by weight. So here also we have E log V, here also we have E log V. How can we be sure that the order will be only DA and not AD? Check whether we have DA combo anywhere. So we have DA, and here we have AD, but that option is ruled out, so we can leave it off. So after breadth first search, comparing to BFS, they are saying this will take more operations, so definitely B will be followed by D only, and since we have Fibonacci heap option here, we can definitely say Dijkstra's will come before Kruskal algorithm. So the order will be BDA. Then comes Bellman-Ford algorithm. This will compute shortest path from a source even with negative weights by relaxing edges repeatedly. The time complexity will be vertices into edges, big O of V into E. So this will come next. Comparing Dijkstra's and Bellman-Ford, Dijkstra's is with respect to non-negative weights and Bellman is with respect to negative weights. In any way you see, Dijkstra's should have less complexity compared to Bellman-Ford. So D should come before C. Here the order is changed. That's why we can rule out option 4 also. So we have BDA in 2 of the option, and now C joins the list. So only one option is having this particular order. So the final algorithm will be Edmonds-Karp algorithm. This solves maximum flow using repeated BFS to find augmenting path. We have learnt about maximum flow in unit outline videos of unit 7. So this algorithm will definitely have more time complexity compared to other algorithms. Just look at the syllabus. In syllabus they will be starting with DFS and BFS. Then they will go for shortest path algorithm. Then they will go for minimum spanning trees. If you take that order itself, you can understand they will start from simple to hard concepts. In that case, if you take all this minimum spanning trees and every algorithm will be discussed, and later only they will use maximum flow algorithm. This is for exam point of view. If you are confused in the examination hall, bring syllabus into your mind and work it out is what I am trying to tell you. Don't apply it during learning stage. So the time complexity will be V into E square, vertices into square of edges. So Edmonds-Karp will be coming in the final place. Since Edmonds-Karp is placed before C, we are ruling out even option 1. We will go with option number 3, BDAC as the right answer. So anything with least time complexity will be most efficient, and anything with more time complexity will be least efficient. Next question. Given below are two statements. One is assertion and the other is reason. Assertion states that Kruskal's algorithm and Prim's algorithm always produce minimum spanning tree. For that purpose only these algorithms are existing. This is correct. Both these algorithms are used for finding minimum spanning tree in a connected weighted graph. They are based on the cut property. The smallest edge crossing any cut must be in the minimum spanning tree. Because of this property, both algorithms are guaranteed to produce a valid minimum spanning tree. So A is definitely correct. What about the reason? Every connected graph has a unique minimum spanning tree. Not so. A connected graph does not always have a unique minimum spanning tree. If edge weights are distinct, then the minimum spanning tree will be unique. But if there are ties, example, when you have multiple edges with the same weight, there can be multiple different minimum spanning trees with the same total cost. All these three are going to be minimum spanning trees and all the total cost will be only 10. There is no uniqueness here. All are valid and all are different. In case if this particular part is going to have 10 and this one will have 15 and this one will have 12, then we can say it is a unique MST. When there are possibilities for having ties where multiple edges have same weight, there can be multiple different MSTs. Every connected graph need not have unique MST always. A connected graph may have multiple minimum spanning trees if there are edges with equal weights. We know that A is correct but R is not correct. We will go with option number 3 as the right answer. Next question. Given below are two statements. One is assertion and the other one is reason. What about assertion? Depth first search can be used to perform a topological sort of a direct acyclic graph. And the reason here is a topological sort of a direct acyclic graph G is a linear ordering of its vertices such that if G contains an edge u comma v, then u appears before v in the ordering. Already I have given details regarding these two in one of the previous year question paper. So let's get into the learning part now. Assertion is correct actually. Depth first search is one of the standard method for topological sorting. Perform DFS and then list vertices in reverse finishing time order, we will say. So this is definitely used to perform topological sort. So A is definitely correct. What about the reason? A topological sort is a linear ordering of its vertices such that if G contains an edge u comma v, then u will appear before v in the ordering. This is exactly the definition of topological sort. So we know it is not option 3 or option 4. We have to check whether R is the correct explanation of A. R correctly defines what a topological sort is. A states that DFS can be used to achieve it. Since DFS finishing times naturally respect this ordering, R is the correct explanation of A. Taking the definition of topological sort, they say DFS can be used to perform this particular sort. So we can rule out even option 2. Option number 1, both A and R are correct and R is the correct explanation of A will be the right answer. Even in unit outline videos, we have talked about topological sorting. So take a learning about these two techniques, both DFS as well as about topological sorting. Next question, which of the following statements about DFS are correct? It can detect cycles in a graph. It can be used to find connected components. It works for both directed and undirected graph. It guarantees shortest path in unweighted graphs. So which are correct? Let's take the first statement about detecting cycle. DFS can detect cycles by checking for back edges during traversal, especially in directed graph. So definitely A is correct. What about B? By running DFS from each unvisited node, you can identify all the connected components in an undirected graph. So B is also correct. Any option that does not involve A and B can be ruled out. Now we have to find whether C alone is correct or both C and D are correct. It works for both directed and undirected graph. The first point is given for directed graph and the second point is given for undirected graph. What does it mean? DFS is a general traversal technique and it applies to both directed and undirected graph. C is also correct. Does it guarantee shortest path in unweighted graph? This is alone wrong. DFS does not guarantee the shortest path because it explores depth first, not level by level. Actually, this statement is suitable for BFS. This is breadth first search and not depth first search. Here, the exploration is based on depth and it is not level by level. So BFS is done level by level, so it can guarantee shortest path in unweighted graph. So D is definitely wrong. 2 can be ruled out. Option number 1, A, B, C only will be the right answer. So once you complete this question, you shouldn't stop with these 4 points alone. Try to gather DFS related statements and BFS related statements from the previous year question papers. Learn it together so that it will give you a complete learning experience. Next question, which of the following are limitations of greedy algorithms? What are actually limitations? It means we can say the drawbacks of something. But when it is applied to the context of algorithms, limitations can be when the algorithm fails to guarantee optimal results, we can say it's a limitation. When it cannot handle certain inputs, we can say it's a limitation. When it has some constraints in performance or applicability, then we can say it's a limitation. So we have to find these 3 points in those 4 statements. What are those 4 statements? They always fail for NP-hard problem. They may not give the optimal solution for all problem. They are faster than dynamic programming in most cases. They make local choices without looking ahead. Let's start from A. They will always fail for NP-hard problem. This is actually not correct. They are not limitations. Greedy algorithm don't always fail. Sometimes they give good approximation for NP-hard problems like knapsack and traveling salesman. The limitation is they don't guarantee optimality. It will sometimes give approximation. You cannot say it will always fail. So that cannot be taken as a limitation. Now we are getting into the main point. They may not give the optimal solution for all problem is perfectly correct. So they say when the algorithm fails to guarantee optimal results, then that becomes a limitation. This is the key limitation. Greedy algorithm works only when the problem has the greedy choice property and optimal substructure. Otherwise, it may produce suboptimal results. It means a result that is not optimal. So B is definitely a limitation. What about C? They are faster than dynamic program. Actually, it is a good quality, a good characteristic. Then why should it be called as limitation? This is not a limitation. This is more of a performance characteristic. Greedy is often faster and it's definitely an advantage. So this is definitely not a limitation. What about D? They make local choices without looking ahead. That is correct only. Greedy decisions are made based only on immediate benefit without considering future consequences. This can be taken as constraints in performance or applicability. So here this is also a limitation. B and D only is available in option 4. Option 4 will be the right answer. A is not always true and C is definitely an advantage. It is not a limitation. Next question. Match the list 1 with list 2. In list 1 we have design techniques of algorithm and in list 2 we have the related application. So let's start matching. Actually we have learnt about Floyd-Warshall algorithm as well as about Huffman coding in certain previous year question paper. In Huffman coding, one thing that we learnt repeatedly is it is a greedy strategy. We definitely know B will be mapping to 2. B2 is available only in one option. Floyd-Warshall uses dynamic programming to compute shortest path between all pairs of vertices by building solutions step by step. So regarding all pairs, you just take the pair AB, BC, CD, then AC, AD. Then we can have BD also. So in order to reach A to D, it may take 10 value. To reach A to D via B, you may need only 8. So here this will be the shortest path compared to A to D direct edge. So if you have already computed for A, B and B, D. Say for example this is going to be 4 and this is going to be 4. This will be stored solution in the dynamic programming table. So referring the table, when Floyd-Warshall is going to compute all pair shortest path, for AD pair it will have direct edge 10 cost and AB, BD 2 edges cost as 8. So it will automatically go for shortest path as ABD path. So for this purpose only we are using dynamic programming technique in Floyd-Warshall shortest path. So A is directly mapping to 1. What about the next one? Huffman coding applies a greedy strategy. This will repeatedly choose the least frequency nodes to build an optimal prefix code. We have actually learnt about constructing a Huffman code tree in the previous year question paper solution video. If you want, you can refer those videos to get a good understanding about how greedy strategy is applied there. So B will be mapping to 2. What about backtracking? The Hamiltonian cycle problem is solved using backtracking by exploring possible paths and abandoning those that cannot lead to a valid cycle. So it has to go to one stage, backtrack and take another path. So here definitely backtracking will have its application in Hamiltonian cycle problem. What about branch and bound? Whenever you take traveling salesman problem, it will have branch and bound working strategy. And here you have an additional term called using lower bound. This term is also a clue to branch and bound technique. The TSP problem can be tackled with branch and bound, pruning search paths using lower bound estimates to reduce computation. So once you go node by node, when you decide that this path is not going to work, you can prune it. Prune it means you can remove this path from your traversal, you can stick to this path, thereby reducing computation. So branch and bound is mapping to traveling salesman problem. A1, B2, C3, D4 is available in option 3. Option number 3 will be the right answer. After completing this question, have a good understanding about the techniques in list 1 as well as an understanding about all the algorithms that are mentioned in list 2. Have an idea about the complexity, have an idea about how it works, what strategy it uses. It will be useful for you in some other question paper. Next question. We have algorithms in list 1 and the applications in list 2. If you have gone through previous year question paper, we know Huffman coding is done for data compression. So B is having answer in 2 directly. And regarding KMP string matching, this word is a clue that it is based on text. So this can say KMP string matching is done in text editor. If you have gone through unit outline videos of unit 7, you could have come across Ford-Fulkerson algorithm in maximum flow, where we would have worked about maximum flow in a network. So this network bandwidth optimization can be taken for network's maximum flow, which we studied in Ford-Fulkerson algorithm. So B2, C3, D4 can be found out if you would have gone through all the previous year question papers. And regarding C and D, I have also explained these algorithms in detail in unit outline videos. Dijkstra's algorithm is about finding shortest path, and the application given here is GPS route finding. If you apply your logic, you can find that A will be mapping to 1 only, because when you are finding some routes, you have to go for the shortest path. So obviously we can apply Dijkstra's algorithm, the shortest path algorithm, to this particular application. So let's start. Dijkstra's algorithm is used in GPS systems to compute the shortest path between locations on a road network. Huffman coding applies a greedy approach to compress data efficiently by assigning shorter codes to frequent symbols. KMP algorithm enables fast substring searches in text editors by avoiding redundant comparison. We have worked an example about the string matching algorithm in the unit outline video. And the final one, Ford-Fulkerson computes maximum flow in a network, helping optimize bandwidth usage across communication channels. A1, B2, C3, D4 is available in option 2. Option number 2 will be the right answer. Previous year question paper practice doesn't mean reading the question and reading the answer. It means preparing, analyzing every option, learning about every question, understanding the context, understanding the content. Everything is there in preparation. If you don't have understanding about a concept, you cannot apply the learning from one question format and apply it in another question format. If you learn something in true or false, you should be able to apply it in a match. When you learn from assertion statement, you have to apply it in true or false. When you learn how to solve some question, you have to know how to arrange all those answers. Once you understand the question, you can apply one question format's learning in another question format. Take previous year question paper preparation in a serious note and do your preparation. With this, we are completing Unit 7 solutions. Let's solve Unit 8 questions. Let P and Q be two regular expressions over the input alphabet. If P does not contain epsilon, then the following equation in R, namely R is equal to Q plus RP, has a unique solution given by. This type of question is new to this particular exam, because in the last 5 or 6 years question paper we have not come across such a question. This question belongs to the topic fixed point equation over regular languages. They have given two regular expressions, P and Q. They say P does not contain epsilon. It means empty language or empty string is not allowed in P. Then the following equation R is equal to Q plus RP has a unique solution, means which expression equates R. You can take it in this way. This is a classic form of a regular expression equation, and solving it involves understanding how regular expressions behave under concatenation and union. Union is plus, RP is concatenation, you can take. It is multiplication and addition, so we can take it as concatenation and union. What is this R is equal to Q plus RP? We find a recursion pattern here. This is a recursive equation in terms of regular expression. This resembles the algebraic form x is equal to a plus xb. X is r here, a is q here and p is b here. So for the expressions that are in algebraic form x is equal to a plus xb, there is a known solution in formal language theory. The solution is x is equal to ab star provided that b does not generate epsilon. They said p does not contain this particular epsilon. We have equated x to r, a to q and p to b. When they say b does not generate epsilon, here it is true for p also. This is r is equal to q plus rp. This format solution will be, instead of x we will have r, instead of a we will have q and instead of b we will have p. Star r is equal to qp star will be the unique solution. It is available in option number 2. Option 2 will be the right answer with the detail that we have here. R is equal to qp star is the unique solution under the condition that p does not contain epsilon. We have got the solution directly, but somehow we have to prove that option number 2 and the equation given in the question are equal. How can we prove that it is equal? For that we will do some work. Let's take p star first. P clean closure. By definition, P clean closure means 0 or more occurrences of P. In other words, we can say 0 or more repetitions of P. So instead of 0, we can have empty string here, that is epsilon. Then we will have 1 occurrence, then 2 occurrences, then 3 occurrences. So along with P star, we will have this particular Q now. So from this particular equation, we are starting. QP star is equal to, along with every element here, we are prepending Q. So Q epsilon plus QP plus QPP, it goes on. When you simplify, epsilon means it is nothing, no value. So we can take this particular term as Q itself. So this will be Q plus QP plus QPP plus Q triple P. Now let's take the unique solution R is equal to QP star. Instead of QP star, we will substitute the complete expression here. So R is equal to Q plus QP plus QPP plus it goes on. We have found R is equal to this form. Now what we have to do? We have to bring the question format also to this particular form. So we have to check whether this expression or this particular terms are generated even by the question. So let's check that. Now let's compute Q plus RP. We will take only this particular part because we have to check whether Q plus RP will generate the same strings as that of QP star, because they have given this particular algebraic form will have this particular solution. We have to prove this expression is equal to this expression. So we have found out QP star where it is equal to Q plus QP plus QPP and then it goes on. Now we have to compute this Q plus RP. So Q plus RP can be written as Q plus, instead of R we will place QP star. So we will just bring QP star here. Then we will retain the P. So let me tell you here, Q plus RP. Q will be there as it is, no doubt, and P will be there as it is, no doubt. So instead of R we will have QP star. QP star into P can be written as, this is associative. So we will move this term outside the bracket. Q will be outside and P star into P will be inside. What is clean closure with occurrence? P star is clean closure. This is 0 or more occurrence. What is P positive closure? It means 1 or more occurrence. When we have P star with P, even though this produces 0 occurrence, this will produce at least 1 occurrence. So the meaning of this particular expression will be 1 or more occurrence. 1 or more occurrence can be specified as P positive closure. So that's why we are bringing P star into P together and then making this as P positive closure. So now the right side term can be Q plus, instead of this particular expression we are making it as QP positive closure. What is QP positive closure? Positive closure means P, PP, triple P and it goes on. So here the Q will be as it is. Instead of QP positive closure we will have QP plus QPP plus Q triple P. Now what is this particular expression? This is exactly QP star. So we have proved Q plus RP is equal to QP star. Hence the solution is consistent, means either way you compute it or substitute it, you are getting the same expression, which is Q plus QP plus QPP and it goes on. This part is for making you understand how we compute things. So why are we working out in this particular way? Since we have R getting repeated in the right hand side, this is actually a recursive equation. Shall we unfold the recursive equation? Let's take R is equal to Q plus RP. Now instead of this R, we will again substitute Q plus RP. Here we will have Q, here we will have P, here we will have Q plus RP. We will substitute even in this particular way. This will give Q plus this one, QP plus we will have RPP. Already RP is there, now another P from the outside. So RPP will be there. So this is instead of R and we have the P here. So here we have QP then RPP. Now we expand again with this particular R. So this will be Q plus QP plus, instead of R we will have Q plus RP. Again we will have PP. We will have Q plus QP, then Q double P, then we will have R triple P. This will go this way. So what is this particular format? Q plus QP plus Q double P plus Q triple P. Now R will have 4 number of P's. This will keep on expanding. This is unfolding the recursion. If you unfold in this particular way, then also you will end up with the same equation or same expression is what they say. That infinite expansion is exactly what QP star is also representing. From this particular part and this particular part, we can say that this R is equal to Q plus RP. This one is definitely equal to Q into P star because both are generating the same infinite expansion. You can just try with the first equation. Q is having Q clean closure. It means epsilon comes, but in this particular term we will not have epsilon. Definitely we will have Q here. So this particular expression will not work. What about PQ star? The order is reversed here. Q star is given so that P terms will stay as it is. So this is also wrong because the format should be in QP form and not in PQ form. Which stands in the left side, which stands in the right side is important. So this is also not there. What about these two? This particular equation is carrying clean closure with Q and P. R is placed in the right side. We have Q plus RP, which makes it to Q plus RP into P. Here the generation will be QP then RPP. But when it is in the right hand side, this will become Q plus P into Q plus PR. Q plus QP is the right way and Q plus PQ is the wrong way. That's why we are even ruling out option 4. So when you learn for such questions, make sure why other options are wrong as per the understanding that is given here. So this is all for your understanding I have given. Though this might have complicated the question, there is nothing wrong to learn something new. Next question. a phase of a compiler which produce the symbol table is. Whenever we came across symbol table in the previous year question paper, what we learnt was symbol table is used in all the phases of the compiler. But here the question is, which phase is producing it? When you take compilation, there are two stages. One is analysis phase, then we will have intermediate code, then comes the synthesis phase. During the analysis phase, there are three stages: lexical analysis, syntax analysis, semantic analysis. These three phases together make up the symbol table completely, we can say. It means the symbol table creation might start in lexical analysis phase, but not in all implementation. So from lexical analysis it will start, then during syntax analysis the symbol table will be getting populated, and the semantics analysis phase will finally produce the entire symbol table. So complete symbol table is produced in semantic phase, no doubt. It might start during lexical phase, that is also no doubt. But here the question is, which is producing the symbol table? So a big confusion among many aspirants whether to choose lexical, challenge this question, or go with the official answer key, which is syntax analysis. And for some the doubt was on option 2, semantic analysis, because it is going to give the final symbol table that is needed for the synthesis phase. So after analysis the symbol table will be ready. This symbol table will be used by the synthesis phase in compiler. Symbol tables are data structures that are used by compilers to hold information about source program constructs. The information is collected incrementally by the analysis phases and used by the synthesis phases to generate the target code. Entries in the symbol table can contain information about identifier such as its character string, otherwise called as lexeme, the type, the position in storage, or any other relevant information. It can be function name, it can be variable name, every other detail will be stored from the source program only. Symbol table entries are created and used during the analysis phase by three of the phases here: lexical analyzer, the parser, which is the syntax analysis phase, and the semantic analyzer phase. In some cases, lexical analyzer can create a symbol entry as soon as it sees the character that makes up a lexeme. Lexeme is a token you can take. More often, the lexical analyzer can only return to the parser. Parser in the sense the syntax analysis phase, a token, say ID, along with a pointer to the lexeme. So if it is going to return to the parser, it means the parser is going to fill up the entry in the symbol table. Say for example in lexical analysis phase, we have something called ID is equal to ID plus 3. So what will happen is, it will just split up into tokens. This will be lexical analysis phase. But in syntax analysis, what happens is, ID is a variable, plus will be operator, or 3 is a constant. This detail is actually stored only when you parse the particular program code. Only the parser, the syntax analysis phase, can decide whether to use a previously created symbol table entry or create a new one for the identifier. So ID can be passed to the next phase, which is syntax analysis. Syntax analysis has to decide whether we can keep that entry or we will create a new entry for the identifier stating it is a variable. So the ultimate decision is in the hands of the syntax analysis phase. And after that, the scope of the variable and whatever additional details are needed, everything will be added by the semantics analysis phase. So syntax analysis will be filling up the symbol table entries, while this will build the final symbol table. So we can reframe the question like, which phase will give you the final symbol table? That will be semantic analysis. So definitely option 2 is not there. It is not going to start from there. Semantic analysis phase will not start creating entries. the entries will be started before semantic analysis phase, so we are not going with option 2. Target code generation and code optimization belong to synthesis part. They are going to make use of the symbol tables but not produce it. So 3 and 4 will also be ruled out. Regarding syntax analysis, there is no doubt that it is the answer, because that phase will be filling up the entries in the symbol table appropriately. Option number 1, syntax analysis, will be the right answer. There is no doubt that lexical analysis will start contributing for the symbol table. There is no doubt. But when we say this phase is going to produce the symbol table, means multiple entries are going to be created only by the syntax analysis phase. What is syntax analysis phase? That is only going to check with the grammar and then find whether that particular expression is correct or not. So having only the tokens in lexical analysis phase, the entries can be incomplete. After passing through syntax analysis phase only, the entries can be complete. Then you can ask me, what is the use in semantics analysis phase? We can say the scope of the variable, the scope of the function, everything can be added to the existing table. Semantic analysis will not start from scratch, but there is a possibility that syntax analysis can start from scratch, because it can either use the previously created entry by the lexical analysis phase or create a new one for the identifier after coming to the syntax analysis phase. Based on the 4 options that is given for this question, just narrow the context for these 4 phases and then understand the question, which is going to give you the symbol table. So entries will be filled up by the syntax analysis phase, while the final symbol table will be produced by the semantics analysis phase. Next question. Given below are 2 statements. One is assertion, other is reason. Let's see the assertion. If L is regular, then its complement L dash is necessarily regular. Whether this is true or not, we will check with reason and then come back. Reason is, complement of a language can be obtained by swapping final and non-final states in a DFA. This is actually true. Let's take a language in which we have entries of 1, 2, 3. Just for example, what is complement of this particular language? Any entries except 1, 2, 3 will be complement of the language. If we have Q4 as the final state in this particular DFA, then the complement will have any state other than Q4 as the final state. Only then the inputs 1, 2, 3 will not be accepted. So this statement is correct. When we are able to swap the final and non-final states, the DFA will still be a DFA. The language will be changing to complement of a language. Does the regularity change here? No. So from this we can say the assertion is also correct only. If language is going to be regular, then the complement language is also regular only. So let's see the justification. Regular languages are closed under complementation. If you know this property, then you could have answered this particular question. If L is regular, then there exists a DFA that accepts it. By swapping the accepting and non-accepting states, we will get a DFA for L complement. So L complement is also regular. By this way we proved assertion is true. What about reason? Let's take a DFA for the given language. What is the complement DFA having? The set of states, the input, the transitions are all fine. Even the initial state is fine. What is Q backslash F? Q backslash F means other than the final state, every other state will be included in the final state. F is the final state here, the accepting state. But for the complement, any state other than the final state, as we saw here in the example, other than Q4 will become the final state. This construction works because DFAs are deterministic and cover all possible strings. So reason is also correct here. There is no doubt. Definitely 3 and 4 can be ruled out here. Do you think R is the correct explanation of A? Yes. Based on R only, we concluded A is correct. That's why I went from reason to assertion. R is the correct explanation of A because closure under complementation directly follows from the DFA construction described in R. Just based on this example only, we marked R to be true, and based on that, we marked assertion to be true. So R is definitely the correct explanation of A. We will even rule out option 2. Option number 1 will be the right answer. With final state, the accepting state, it is a DFA, while other states are becoming final, that is the non-final states are becoming as final means, then also it will be a DFA only. We are not going to change the state, you are not going to change the transition, only the strings in the language will not be accepted in the complement part. So for that you have to have idea on what is a language, what will come in the complement of a language. If you are able to understand that particular part, even if you forget about regular languages are closed under complementation, you can still answer this question. Next question, given below are two statements. This is also assertion reason question. Assertion states that language is equal to A parent, B parent, C parent where n is greater than or equal to 0. When we say it is equal to 0, what does it mean? Empty strings are acceptable. This language is accepted by a linear bounded automata. What is linear bounded automata? The implementation of context sensitive languages will be linear bounded automata. Before answering for the assertion, let's see the reason. Linear bounded automatas recognize exactly the class of context sensitive languages. This is perfectly true. LBA is for CSL. So let's take regular language. It will be recognized by finite automata, that is DFA and NFA. What about context free language? It will be recognized by push down automata. So we have DPDA and NPDA. What about context sensitive languages? It will be recognized by linear bounded automata. What about recursive languages or recursively enumerable languages? We will need Turing machine to recognize them. If you have this particular idea in mind, then you can mark reason to be true. Now based on the reason, they are asking whether this particular language is accepted by a linear bounded automata. So what you should test here, you have to check whether this particular language is CSL or not. In CFL, we will use PDA where a stack will be there. An example of this particular language will be A parent, B parent where n is greater than or equal to 1. Whenever A comes, we will be pushing. Whenever B comes, we will be popping A. So with the same element only, we will be pushing A and popping A. This is on seeing A and this is on seeing B. This is how we will check whether the number of A's are equal to number of B's. This is CFL. Now just check the language that is given in the assertion. A parent, B parent, C parent. Do you think only one stack is necessary for checking this? No. For this particular equivalence, you need one stack, and for this particular equivalence, you need another stack. When there is more than one stack involved, this automatically becomes context sensitive language and not context free language. So context sensitive language is true. What is the implementation of context sensitive language? It is linear bounded automata. So assertion is also true. L is a classic example of context sensitive language. It is not context free. I told you why. It can be recognized by an LBA since linear bounded automata has tape bounded by the input length and can enforce the equal counting of A, B and C. Let's go for reason. By definition, the class of languages recognized by LBAs is exactly the class of context sensitive languages. From this we know 3 and 4 are wrong. Now we went in the order from reason to assertion. So what does it mean? It means R is the correct explanation of A because L is context sensitive. LBAs recognize exactly context sensitive languages. Since LBAs recognize CSL, the given example is also CSL, it is accepted by LBA. So R is definitely the correct explanation of A. We can go with option number 1 as the right answer. When you learn, if you learn in this particular order, you can use it for match. You can use it for true or false statement. You can use it for finding whether a particular language is CSL or CFL or regular. All these learning you can do when you go in this particular order. While you are revising, you can revise it as assertion is true, reason is true, and this is going to be the right explanation. That is fine. That is fine for revision. But when you learn, when you want to learn a concept from assertion reason statements, you have to start with the reason, then go to assertion. Only then you will be able to find the connect or disconnect. This is bottom up approach we can say, but this will give you in-depth learning for this particular topic. Next question. Arrange the following in the order of execution while proving a language is non-regular using pumping lemma. Usually we will be working with pumping lemma. This time we are going to work with the steps in pumping lemma. Whenever you start the pumping lemma statement, we have to assume the language is going to be regular. In the end we will say, since it has not met the condition, we conclude L is not regular. So any pumping lemma will start by assumption. That will be the first stage, and finally we will be giving the result whether it is regular or not, CFL or not, for context free languages I am saying. So it will start with assumption. Which statement is starting with assumption here? It is B. So we have to start from B. Assume the language is regular. This is what the pumping lemma must hold. Then we have to choose a string of length greater than the pumping length. This will be the next step, which is C. Choose a string from the language that is at least as long as the pumping length. At least long means greater than or equal to pumping length. After choosing, our work is to split the string as X, Y, Z. This is available in statement A. Split the string into X, Y, Z such that it satisfies the conditions. The count of X, Y together will be less than or equal to the pumping length. The count of Y will be greater than 0. It means Y should not be empty. Then for all I greater than or equal to 0, X, Y power I, Z should belong to L. These are the three conditions. So here the statement says split into X, Y, Z satisfying pumping lemma condition. So definitely A is the next step. Final step will be show contradiction when pumping Y. We have to pump Y and show that the resulting string is not in the language, which leads to a contradiction. What is the contradiction here? You have assumed something is regular and here we say it is not regular. This is the contradiction. In case if you are able to pump it properly, then regularity holds. There is no issue. But pumping lemma is not to say that a language is regular. Pumping lemma is used to say that a language is not regular. To say something is not regular, to say something is not CFL only, we have pumping lemma. So what is this pump Y? When you take X, Y power I, Z, when you have the Y term as X, Y power 0, Z, this XZ should also be present in the L. Then XYZ should also be a part of the language. XYY should also be a part of the language. If you are able to generate strings in such a way that they all belong to the language, then it is regular. If any of these condition fails, then it is not regular. So that's what they say, based on pumping Y, this Y power I will decide everything. We can say the resulting string is not in the language, Because we assume it as regular, we say that leads to a contradiction. What is the order? B, C, A, D. Option number 3 will be the right answer. Here in the option, 2 of the options are starting with assumption. At that time itself you can rule out 2 and 4. Regarding B and C, it is perfectly fine. Without splitting the string into X, Y, Z, how can you pump Y, or how will you know what is Y? So when you have D followed by A, that itself is a contradiction, we can say. In the sense that is not logically correct. You have something called X, Y, Z. From there you are talking about Y. This is logically correct. You are talking something about Y and then stating that it has to be divided into or split into X, Y, Z. This is not logically correct. Even if you forgot pumping lemma in the examination hall, think in this way and try to find the order of execution. So because of this particular order, we are ruling out even option 1. This contradiction implies that the original assumption that the language is regular is false. Next question. Arrange the following tasks of lexical analyzer in correct sequence. So we have token generation, removal of comments or white space, buffering and reading source characters, return token stream to parser. In compiler phases, from lexical analyzer, we will be moving to syntax analyzer. So here we will have the character stream that will become input to lexical analysis phase. Here everything will be split up into tokens and that token will be passed to the syntax analysis phase as input. Now you have to load the character stream, only then you can start with the lexical analysis phase. So out of these 4 statements, the first task will be buffering and reading source character. Only when you read the characters, you can know what to do with it. So the first step will be buffering and reading source characters. The lexical analyzer first reads raw characters from the source code. Buffering is used to efficiently handle input streams. The next step, it has to remove comments or white spaces, we can say. Non-essential elements like comments and extra spaces are discarded since they don't affect syntax or semantics. Additional spaces can be removed. Sometimes we have comments generated here, so those lines will be removed. Only the needed characters will be taken into consideration. So we are starting with C, then going to B. The only option that is starting with C is 3 only. From this itself you can rule out the other options. After that there are 2 stages here. Token generation and return token stream to parser. Only after you generate a token, you can return it to the parser. So this token stream is going to be an input to the syntax analysis phase. Syntax analysis phase is what they call as parser. Then token generation has to happen first. So the order after B will be A. The analyzer groups meaningful sequences of characters like keywords, identifiers, literals, operators into tokens. After generating tokens, finally, the sequence of tokens is passed to the parser, which uses them for syntax analysis. C, B, A, D is the right order. Option number 3 will be the right answer. Every statement given here is a task of lexical analyzer. After learning this particular question, try to learn the steps or the tasks in syntax analysis, semantic analysis also, so that it will help you in some other question paper. Next question, if R1 and R2 are regular expressions, then which of the following are correct? We will see every statement and then check whether it is right or not. Let's start with A. In regular expression, the plus or union operator denotes alternation. So the language of R1 plus R2 is exactly the union of the languages R1 and R2. So whatever we mention in plus is equated to union only. Say for example, R1 is going to be set of strings with A and R2 is going to be set of string with B. A plus B will be equal to A union B is what they say. The language of A and the language of B, here the language of A plus B. So whatever is in language A and whatever is in language B together becomes the union. So A is definitely true. What about B? The concatenation of two regular expression means concatenation of their languages. So formally R1 into R2 will be X into Y, where X belongs to language of R1 and Y belongs to language of R2. Have this formal representation to understand how they are interpreting the meaning of L of R1 into L of R2. So instead of directly writing it as L of R1 and L of R2, they have specified with X into Y, where X belongs to L of R1 and Y belongs to L of R2. Now let's go for C. When you have single brackets or double brackets, the meaning is same. Extra parentheses do not change the meaning of a regular expression, so the language remains the same. C is also true. What about D? Here we have clean star in R1 directly, and the clean star is applied to the language of R1 here. The clean star applied to a regular expression means 0 or more concatenations of strings. So by definition, language of R1 star is equal to language of R1 the whole star. Both actually mean the same is what they say. By definition, this particular expression is true. So D is also true. Option number 4 will be the right answer. A, B, C and D. All the 4 are correct. Next question. Which of the following languages cannot be accepted by push-down automata? What does it mean when they say cannot be accepted by push-down automata? It means it is not a CFL. Let's take the first one. Just in the assertion reason statement, we saw that A parent, B parent, C parent is a context sensitive language. Then how come it be accepted by push-down automata? So A is definitely not accepted. A will be the part of the answer because here they are asking cannot be accepted. So A cannot be accepted. Whichever options do not include A have to be ruled out. So now we can check B and C. Based on that we can conclude which option is correct. So let's start with A first. This is not a context-free language. This requires counting 3 symbols with equal counts, which a PDA cannot do with a single stack. So it is not accepted by push-down automata. What about P? A power P, where P is prime. So we have to check whether P is prime or not. How will we check that P is prime or not? Stack can count the equality, but can it check whether a number is prime or not? This is also not context free. Prime number checking is a non-trivial arithmetic property not expressible by a push-down automata. So definitely it cannot be accepted by push-down automata. Since A and B are not context-free languages, we can go with option number 3 as the right answer. We can even rule out option 1. From this what you can understand is all these 3 can be accepted by a push-down automata and they are context-free languages. Now we will see how C, D, E are context-free. The C language is a palindrome with a center marker. This string and the reverse of the string with a center marker. A PDA can push the string onto the stack and match it against the reverse of the string. Say for example, we have a word called madam. M, A can be pushed. After you get this mark, A and M can be popped out. When you find the first A, it can be pushed. When you find the second A, it has to be popped. This mechanism can be done. So definitely it is accepted by the push-down automata. What about the fourth one? This is nothing but counting the number of A's and number of B's. Number of A's in the string is equal to number of B's. This is definitely context free. A PDA can increment for A and decrement for B. This is accepted by the PDA. So take it in this way. Whenever you see A, you push. Whenever you see B, you pop. So when the stack is empty, you can find that number of A will be equal to number of B. So the string doesn't mean it will be in this order. It can be like AB, AB, AB. It can be in any order. So when it is in this way, we know it is CFL. Even if it is in this way, it is still CFL. Instead of saying pushing and popping, they have meant it as increment for A and decrement for B. Whichever symbol is going to start in the string, based on that you have to keep increment and decrement. So D is also definitely CFL. What about E? A power n, B power m, C power n plus m. So whenever you have A and B, you have to push it into the stack. And whenever you have C, you have to pop out of the stack. When you read A, push C. When you read B, push C. When you read C, pop C. When you read C, pop C. So this is what we can do. Because C is having the count of A and B together, so definitely one stack is more than enough. This language is context free. PDA can count N and M separately and verify C. Accepted by PDA. Let's take A is equal to 2 and B is equal to 3. A, B, B, B. Then we will have C is equal to 5 because it is 2 plus 3. So we will have 5 number of C's. I am just telling you in a plain manner. I am not going with this particular implementation. Whenever you read A and B, just keep pushing to the stack. Whenever you read C, just pop from the stack. So you can know the count is going to be equal, N plus M. Here the question is not about NPDA or DPDA but only PDA. So we are generally telling that C, D, E are context free languages. So they are accepted by PDA. You can check which push down automata can accept C, D and E. Whether DPDA can accept C, D and E or do you need NPDA. I am just leaving it to your learning. Next question, match the list 1 with list 2. List 1 has the input and list 2 has the compiler phase. We have the well-known diagram from the reference book. So let's take the input. The first input will be character stream and character stream is the input to lexical analyzer phase. So lexical phase is 4 in list 2, character stream is B. So B is mapping to 4 here. B4 is available in 2 options. The next input will be token stream. It is D. Syntax analyzer is in list 2 second point. So D will be mapping to 2. Already we would have ruled out 1 and 3. So now D is available only in second option and not in fourth option. So we can even rule out option 4. So token stream is also done. Then we have syntax tree. It is A. Syntax tree becomes the input for semantic analyzer or intermediate code generator. Semantic analyzer is there. So we will go with 3. We have A3. And what about intermediate representation? It is available in 2 places. Since the compiler phase mentioned here is code generator, we can take the intermediate representation here. So this is C. C will be mapping to 1. Intermediate code generator and code generator are different phases. This talks about code generator that comes after intermediate code generation and optimization, while intermediate representation is the output of intermediate code generator and optimizer. So you have to know which phase it is talking about. Syntax tree becomes an input for semantic analyzer and intermediate representation becomes an input for code generator. So C will be mapping to 1 and A will be mapping to 3. So A3, B4, C1, D2. Option number 2 will be the correct answer. This is actually a repeated question from the previous year question paper. If you have already practiced this question, you could have answered this question in the examination. Next question, match the list 1 with list 2. List 1 is listing out the grammar and list 2 has listed out the productions. This is also a repeated question from the previous year question paper. So let's start. Regular grammars allow productions like A derives terminal non-terminal or just A derives terminal. Small a is a terminal while capital B is a non-terminal. Which of the 4 productions in list 2 is having this particular form? A derives XB, A derives X. A derives BX, A derives X. So these two representations are nothing but right linear and left linear grammars of regular grammar. So A will be mapping to 2. Capital A, capital B belong to non-terminal while X belongs to the terminal. Now we will go for unrestricted grammar. What is unrestricted grammar? There will be no rules. Any combination of terminals and non-terminals can come. So which production is actually equating it? X derives Y. X belongs to a combination of non-terminal and terminal. Y belongs to the union of terminal and non-terminal. So what I meant as combination is union only. The left hand side of the production is given with positive closure, which means at least there must be one variable there, and the right hand side production is given with clean closure, which means even empty string is allowed there. So this differentiation will tell you that B will be mapping to 3. Unrestricted grammars allow any production of the form X derives Y with no restrictions on X or Y. A2, B3 is available in 2 of the options. Now we have to go with Chomsky normal form and Greback normal form. These two are a part of context-free languages. So let's take Chomsky normal form. CNF restricts productions to either 2 non-terminals or a single terminal. So just check fourth one. A derives BC is 2 non-terminals or A derives small a is 1 terminal, the single terminal, where A, B, C are in non-terminal and small a is in terminal. This is perfectly matching for Chomsky normal form, which is saying that the productions will have 2 non-terminals or a single terminal in the right hand side. So C will be mapping to 4. C4 is available only in one option out of these 4. So earlier itself we can rule out 2 and 4. Now we can even rule out 1. Option number 3 will be the right answer. Now let's see about Greback normal form. GNF requires productions to start with the terminal followed by 0 or more non-terminals. Now you could have understood the meaning of V clean closure. It must start with the terminal. It is A, perfectly fine. It can be followed by 0 or more non-terminal. It means clean star closure will always refer to 0 or more. So when they say V clean closure, it means they are saying 0 or more non-terminal. This is exactly representing the statement here. So D will be mapping to 1. A2, B3, C4, D1 will be the right match and option 3 will be the right answer. With this we are completing Unit 8 solutions. Let's solve Unit 9 questions. Dialog control is a function of which layer? Network, transport, session, presentation. Since the term is completely new, you must have ruled out network layer and transport layer from the answer list. Now the real fight is between session layer or presentation layer because not much questions have come from these two layers. So let's see the OSI model now. Because in TCP IP we don't have session layer and presentation layer. So these layers belong to the OSI model. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and then we have application layer. So let's see the functions of the given layers in the options and then the other layers. The network layer is responsible for source to destination delivery of a packet, possibly across multiple networks, or we can say even links. What about transport layer? It is responsible for process to process delivery of the entire message. So these two layers are not a part of this question's answer. What about session layer? The session layer is called the network dialog controller. It is responsible for dialog control and synchronization. When you take recent versions of reference books, you won't find such statements at all. These statements belong to the old versions of the book. So from this we can mark dialog control is a function of session layer. Option number 3 will be the right answer. What is dialog control? The session layer allows two systems to enter into a dialogue. It allows the communication between two processes to take place in either half duplex or full duplex mode. What is half duplex? One way at a time. What is full duplex? Two ways at a time. Along with dialog control, there is also another task done by session layer, that is synchronization. The session layer allows a process to add checkpoints or synchronization points to a stream of data. What about presentation layer? This layer is concerned with the syntax and semantics of the information exchanged between two systems. Now we are left with 3 more layers, so let's see about them. The physical layer coordinates the functions required to carry a bit stream over a physical medium. The data link layer is responsible for moving frames from one hop to the next. And the final layer, application layer, enables the user, whether human or software, to access the network. So for the user, this will be the nearest layer. So if you have one user here, the other user will be here with the same application layer. All the layers will be in between. Whatever comes down from this particular user will travel through the physical medium and then go to this particular user. So just have an idea about all the layers. It might be useful for you in such questions or in some matching list. Next question. Assume a signal travels through a transmission medium and its power is reduced to 1/2 of means. It means P2 is equal to 1/2 of P1. What is the power loss in attenuation? This question is directly available in the reference book along with the answer. Attenuation means loss of energy. So already they said it's power loss. To show that a signal has lost or gained strength, engineers will use the unit of decibel. That's why the answer is given in decibel. The decibel is negative if a signal is attenuated and positive if a signal is amplified. When there is a loss, we mention in negative. So here it is about power loss, so all the answers are in negative sign. The decibel value is given by 10 log to the base 10. We have P2 divided by P1. Variables P1 and P2 are powers of a signal. So already they have mentioned P2's value is equal to half of P1. So let's solve this. We will take 10 into log to the base 10. P2 can be written as 1/2 of P1 divided by P1. You can write it in this way, or you can make it as P1 is equal to 2 into P2. So in either way only the value will be staying. So let me do it with P1 now. This will be giving 10 log 10 1/2. P1 and P1 will get cancelled. In case if you substitute for P2 by P1, P2 divided by 2 into P2, here also you will have 1/2 only. In either way you do, you will end up with 1/2. How can we write this 1/2? 10 into log 1 minus log 2. This is to the base 10, this is to the base 10. So this we can keep it as 0. So this will be 10 into minus. What is the value of log 2? It is 0.3010. This we have to know. So this value will be restricted to minus 0.3. So 10 into minus 0.3 will give minus 3.0, which is equal to minus 3 decibel. Option number 2, minus 3 decibel will be the right answer. A loss of 3 decibels is equivalent to losing 1/2 the power. So they are asking what is the power loss. So the power loss is 3 decibel. When they say the power is reduced to 1/2 means the power loss is -3 decibel. Next question, which of the following statement are true for link state routing? Where did we study link state routing? It is available in network layer routing algorithms. Since all the statements are about link state routing, we'll just see what is link state routing. It is a routing protocol where each router discovers the network topology by exchanging link state packets. Every router builds a complete map called the link state database of the network and then independently computes the shortest path to all destinations using Dijkstra's algorithm. So let's start with the first statement. Link state routing suffers from count to infinity problem. Is this true? False. We have already come across this count to infinity problem in the previous year question paper, which is actually a problem of distance vector routing. Count to infinity is a problem of distance vector routing and not link state routing. Link state avoids this by having a complete network view. That's what they said, it will build a complete map. What is this count to infinity? Sometimes the router doesn't know where to reach. Unreachable destinations will be marked as count to infinity. So link state routing will avoid this because it is going to have the complete map of the network. Every router will have it. So this problem will be avoided. We are marking A to be false. What about B? Link state routing uses flooding in the network to distribute link state packets. This is true. Routers flood their link state packets to all other routers so everyone has the same topology information. Here they said exchanging link state packets. So that is what they have given. So definitely B is true. They are asking for true statements. So B is true. Once you know A is false, at that time itself you can rule out 1, 3 and 4 and here is the answer. Now we'll go for C. Each router creates its own link state packet. This is true. Every router describes its own links, the neighbors and the cost in a link state packet. So this is only being distributed to all other routers to tell the state of a particular router. Say for example, if I am a router, I will be telling these are my neighbors and these are the cost to reach my neighbors, and I will be giving it to other routers stating that this will be my travel plan. Similarly, all other routers will be giving me the travel plan. So every router will be creating its own link state packet is perfectly true. C is also right. What about D? Every router has exactly the same link state database. This is true. When the database is going to be same only, everybody can coordinate and work. After flooding, all routers store identical link state databases. Though each computes paths independently, the database will be same and so D is also right. We know E is wrong as per the option, but let's see what is wrong with E. Each router finds its own shortest path to the other routers by using distance vector routing. Actually, they have told independently compute the shortest path to all destination using Dijkstra's algorithm. Why is another routing algorithm coming inside? This part is wrong. It's false. Routers use Dijkstra's shortest path algorithm and not distance vector algorithm. Along with distance vector routing only, we have link state routing in the network layer routing algorithm. When they are going to find shortest path, they will automatically use a shortest path algorithm and not routing algorithm. So E is definitely wrong. So even if you have no idea about link state routing, just by ruling out A and E, you can find that B, C, D are true. So we will go with option number 2, B, C and D only as the right answer. After this particular question, have a learning on distance vector routing as well as link state routing if possible, along with Dijkstra's shortest path algorithm. Whenever you have connected concepts, just expand your learning. Maybe after you complete all these previous year question papers and the associated learning, just check how far you have completed in the syllabus. Definitely the contribution will be more from previous year question paper. Next question. Which statements are true for digital to digital encoding schemes? This is also a repeated question. Digital encoding schemes convert binary data, which are in zeros and ones, to voltage levels. Let's start with the first statement. Unipolar encoding uses one level of value. In a unipolar scheme, all the signal levels are on one side of the time axis, either above or below. Whenever it is above, it is 1. Whenever it is below, it is 0. So they say it uses one level of value, means it can either be 1 or be 0. This is what they say. Though there are two values used, the signal levels can always be only on one side. So only one value is used. You have to take it in that aspect. So definitely A is true. A is available in 3 options. So let's rule out option 3. What about B? Unipolar encoded signal contains a direct current component, a component with 0 frequency. Since unipolar encoding always has a positive voltage for ones and 0 for zeros, the average signal level is not centered around 0. This introduces a DC component called the zero frequency part, which is undesirable for transmission. Whether it is desirable or not is not our problem for this particular question. The only problem is we have to know whether DC component is there or not. It is definitely there. We have just told how the DC component is introduced. By this we ensure that DC component is definitely there. So B is true. What about C? In NRZ-L, the level of the signal is dependent upon the state of the bit. In NRZ-L, the level of the voltage determines the value of the bit. Here we have told digital signals means voltage level. So the term used in the statement is level of the signal. This can be alternatively used for level of the voltage. Both the terms mean the same. And here this is going to be binary data or binary value. When we have 0 and 1, it does not only mean as value, but we can say the state of the bit. State means on state or off state. On state will be 1, off state will be 0. So that can be equated to the voltage. So state of the bit is equivalent to value of the bit. Since we use signal, we use state here. Since we use voltage, we are using value here. Though the terms are different, they mean the same. C is also correct. What about D? In NRZ-I, the signal is not inverted if a 1 is encountered. In NRZ-I, if there is no inversion, then the bit should be 0. If there is inversion, then the bit is 1. So we can say the signal is inverted if 1 is encountered, and it is not inverted if 0 is encountered. So D is definitely false. Whenever 1 is there, it means do something. When 0 is there, don't do something. So for inverting something, when you get a 1, it means you have to invert. When they say no inversion happens, it means 0 will be there. When they say inversion has to happen, then definitely 1 should be there. You can take the plain meaning of 0 and 1 on and off and then connect it with this particular statement. When we know D is wrong, automatically 2 and 4 will be out of the race. And we know what is the answer now. Let's see how E is correct. RZ encoding scheme removes both DC components and problem of synchronization. RZ has transitions in every bit interval, which helps synchronization. So this removes the problem of synchronization. One thing is true. Since the signal returns to 0, it reduces DC components compared to unipolar and NRZ. Here they said it is not centered around 0, that's why it has introduced a DC component. But here they say the signal returns to 0, so definitely there will be no DC component obviously. But here the statement can be taken as reduces DC component only, but it supports removing DC component since the signal is going to return to 0. So we can take it will remove DC component and also overcome the problem of synchronization. So E is true. We will go with option number 1. A, B, C and E only as the right answer. Next question. This is assertion reason question. Let's start with assertion. Asymmetric key cryptography is significantly slower than symmetric key cryptography. Let's see the reason. Asymmetric key cryptography is based on complex mathematical structure to secure data. So let's start with the assertion. Symmetric cryptography like AES, DES uses simple mathematical operations. What kinds of operations? Substitution, permutation, XOR. And this is computationally efficient. Asymmetric cryptography like RSA, ECC relies on heavy mathematical operations like large integer factorization, modular exponentiation, making it much slower. If you have gone through previous year question, you could have come across AES and DES. There we have used substitutions, permutations and XOR operations. And we had certain number of questions from RSA where we were using modular exponentiation. Compared to symmetric cryptography, asymmetric cryptography is relying on heavy mathematical operations like exponentiation, factorization and all. So when heavy mathematical operations are involved, definitely it will work much slower than symmetric cryptography. Assertion is perfectly correct. Because here heavy mathematics is there and here simple maths operations are there. Now let's check the reason. Asymmetric cryptography depends on hard mathematical problems like factoring large primes, discrete logarithms. This complexity is exactly why it is slower compared to symmetric methods. So what did they say in reason? Asymmetric key cryptography is based on complex mathematical structure to secure data. So this is using complex mathematical structure is also true. So what can we conclude? Asymmetric cryptography is slower because it is relying on complex mathematical structures. So R is definitely the correct explanation of A. Once you know A and R are correct, we can rule out 3 and 4. And since we found R is the right explanation, we will go with option number 1 as the right answer. Next question is again assertion reason question. Assertion states one persistent CSMA provides low delay under low load conditions, and the reason is when the channel is free, stations transmit immediately without any random delay, ensuring quick access and minimal delay. Just check the reason. When the channel is free, the station will transmit immediately, that is right, without any delay. This will ensure quick access and minimal delay. This is definitely right. So what about the assertion? Low delay means sending in 1 second. High delay means sending after 5 seconds. So when there is no load, the delay is reduced. So obviously assertion is also true. So let's take a learning now. Carrier sense multiple access requires that each station first listen to the medium or check the state of the medium before sending. This question is discussing about one persistent method. In the one persistent method, after the station finds the line idle, it sends its frame immediately. This method has the highest chance of collision because 2 or more stations may find the line idle and send their frames immediately. It is not about only one station listening, it is about multiple stations listening. So when all think the line is idle and they start sending the frames, definitely at one point high chance of collision will occur. Let's take the assertion. In one persistent CSMA, if the channel is idle, the station transmits immediately. So under low load, collisions are rare, so minimal delay will be happening. It means if only 2 or 3 stations are going to be involved, so definitely collisions will not occur so easily. If only one station is going to involve, then no collision is possible. So as long as the load is going to be low, the number of stations or the number of frames are going to be low, collisions will be rare. So that's why we can say the delay is also going to be minimized. But when there are going to be high load, collisions will occur. Due to collisions, the delay will be more. So A is definitely correct. What about the reason? This is exactly how one persistent CSMA works. Stations will sense the channel. If it's free, they transmit right away, thus ensuring quick access and minimal delay. Reason is also correct. So 3 and 4 are ruled out. The reason directly explains why delay is low under low load conditions. So they say when the channel is going to be idle, it is going to send it immediately. This will ensure quick access and minimal delay. When it is free means it is denoting low load. Under low load conditions, the delay will also be low only. So definitely R is the correct explanation of A. We will go with option number 1 as the right answer. Along with one persistent method, do learn the other methods also. It might be useful for you in another question paper. Next question, match the list 1 with list 2. They have given IP addresses in list 1 and the class to which it belongs in list 2. These are the classes of IP address. So let's start with A. A is having the IP address of 190.10. So 190 means it is in this particular range between 128 and 191. So definitely A will be mapping to class B. So A will be mapping to 2. What about 230? 230 is in the range of D. B will be mapping to class D. B is mapping to 4. A to B4 is available here. What about C? 242. It is in the range of E. So C will be mapping to class E, C1. What about D? 127.10. What does 127 mean? It means 127.255.255.255 till the extreme you have to take, because B is going to start from 128 only. So anything with 127 will fall under class A. So D will be for class A. D will be mapping to 3. It is given here. If you are sure about C and D without getting confused on A and B, you can complete this question. If you cannot list this particular range 0 to 127, 128 to 191, then at least with the help of A and E, you should be able to answer this question is what I am trying to tell you. We will go with option number 3 as the right answer. A2, B4, C1, D3. Next question, match the list 1 with list 2. We are given the protocols in list 1 and the respective layers in list 2. So we have to map which protocol belongs to which layer. We have SMTP, BGP, TCP and PPP. From this, one is very sure. TCP means it is transport layer. So C will be mapping to 2. C2 is available only in one option. Actually, even if you have no idea about A, B and D, still you will be able to answer this question. That's why I mapped TCP to transport layer now. In application layer, we have SMTP, FTP, Telnet. So here SMTP is in A. So this belongs to application layer. So we definitely know A is mapping to 1. Okay, why did I give this diagram now? You have to learn about the other protocols and where it is present. It will be useful for you in another question paper. Now we will get into this question. What is SMTP? Simple Mail Transfer Protocol. Application layer will be the right layer. This is used for sending and receiving email messages. Already we have mapped A to 1. Next we will go for TCP. What is TCP? Transmission Control Protocol. This is available in the transport layer. This provides reliable and connection oriented communication. So C will be mapping to 2. What is the connectionless protocol here? It is UDP. You need to know even that. The next protocol will be BGP protocol. the border gateway protocol. When we talk about border or when we talk about gateway, what comes into your mind? Network layer. Routing protocol for exchanging network reachability between autonomous systems. So BGP belongs to network layer. B will be mapping to 4. Regarding border gateway protocol, this will operate at the application layer in the OSI model, but it will serve the network layer in the TCP/IP model. In the OSI model, routing protocols like BGP, OSPF and RIP are considered application layer protocols. They exchange routing information between systems. In TCP/IP model, however, they are often described as a part of the network layer functionality to determine paths for data packets. Please do note this difference in both the models. These things can turn out to be a question. So here we are sticking to the context of TCP/IP you can take, or you can also say SMTP has already booked application layer for its answer. That's why we are going with network layer. What about PPP? It is point-to-point protocol and here we are mapping it to data link layer. D will be mapping to 3. This encapsulates network layer packets for transmission over point-to-point links. Option number 4 will be the right answer. Next question, arrange the following interframe time interval in increasing order. It's like giving all Sanskrit terms in logical reasoning in paper 1. I do understand that. So let's see the options. PIFS, PCF interframe spacing, DIFS, DCF interframe spacing, SIFS, short interframe spacing, EIFS, extended interframe spacing. They are asking you to arrange this time interval in increasing order. It means from small to large. IEEE 802.11 defines two max sublayers. What are the two sublayers? The distributed coordination function called DCF and point coordination function called PCF. In IEEE 802.11, this is actually Wi-Fi. Interframe spacing refers to the time gap between consecutive frame transmissions on the wireless medium. So the gap between one frame transmission and another frame transmission that is going to happen consecutively. These gaps prevent collisions and ensure fair access to the channel. Different types of interframe spacing are defined to give priority levels to certain kinds of transmissions. So here we are not getting into this priority part and all. I'll give you a diagram. This will help you arrange it in order. Categories of interframe spacing. The first one is short interframe space. From the gap itself you can understand it is having the shortest gap. So interframe spacing is nothing but gap. Just understand it is the time gap. This is used for high priority transmissions like acknowledgements, CTS and data fragments. Ensures quick responses without waiting too long. So the gap is really short here. So this will be first in the order. It will start with C. Then we have PIFS. This is slightly longer than SIFS. So instead of marking there, we can mark here C, A, next we will have B, then D. So the order will be C, A, B, D used by the point coordination function mentioned here, typically by the access point to control medium access. In order to say what is PCF and DCF only, I mentioned this point first before starting the question. The next one will be DIFS. This is longer than PIFS, used in distributed coordination function. DCF, that is normal stations before sending data frames. This ensures fairness among multiple users. So this is typically by the access point and this is for normal stations. You can differentiate it. What about extended interframe space? This has the longest gap, as you can see in the diagram, used when a station detects an error in a frame. allows time for ongoing transmissions to finish before retrying. Now just understand the words in the diagram. Control frame or next fragment may be sent here after this particular timeline is over. PCF frames may be sent here. DCF frames will be sent here. BAT frame recovery will be done here. When a station detects an error, it will allow time for ongoing transmissions to finish before retrying. Means before sending it again, it will allow time for ongoing transmissions is what we can understand. So this will be the order. So we have C, A, B, D. Option number 4 will be the right answer. Even if you have no idea about all those things, just using something called short and something called extended, you can start with C and end with D. Use this kind of strategies during examination. Option number 4, CABD will be the right answer. Next question. Arrange the following steps for pulse code modulation, PCM. The most common technique to change an analog signal to digital data is called pulse code modulation. The change of analog signal to digital data is what we call as digitization, and one common technique to do that is pulse code modulation. A PCM encoder has 3 processes. The analog signal is sampled. We can take this to be A. The sampled signal is quantized. This is D. The quantized values are encoded as streams of bits. This is C. Let's take only these 3, A, D, C. Does any option have A, D, C? Option 3 has A, D, C. Based on these 3 points, we can rule out the 3 options. And also, when you bring low pass filter between the sequence, using that also you can rule out 1 and 4. I'll give you 2 diagrams from the reference book. These are taken from the older versions of the book. The new versions have encoding first and quantizing next. So what is being passed here? The analog signal is being passed here and we get the digital data here. So analog to digital data. This is about PCM encoder. What about PCM decoder here? Here we have something called low pass filter. Now you take it in this particular order. We will use the low pass filter and then bring it to the analog symbol. From there we will undergo sampling, quantizing and then encoding in order to make the data digital. Can we take it in this way? So low pass filter will be applied for the analog signal to be produced. We are placing the low pass filter part in the front, B. So the order will be B, A, D, C. So let's take sampling. The continuous signal is sampled at discrete time intervals. Quantization means each sample is approximated to the nearest value within a finite set of levels. Encoding means the quantized values are converted into binary code for digital transmission. So what does the low pass filter do? This will remove high frequency components to prevent aliasing before sampling. This particular step is done before sampling. So in order to justify that only, I have just connected both the diagrams. Option number 3, BADC will be the right answer. Before sampling, you have to remove the high frequency components. In which you will remove the high frequency components? In the analog signal only you have to remove the high frequency components. So low pass filter will be working with the analog signal. It will remove the high frequency component and then the analog signal will be passed to sampling, quantizing and encoding steps. Next question. Match the list 1 with list 2. List 1 has the protocols and list 2 has its functions. Just with A and B, you should be able to complete this match. What is ARP? Address Resolution Protocol resolves an IP to its corresponding MAC address in local network. So MAC address is what we can call it as physical address. That's why it is mentioned as hardware. Resolving IP to physical address is ARP. A will be mapping to 4. A4 is available in two options. RARP, reverse address resolution protocol, maps a device MAC address back to its IP address, often used by diskless machines. So physical address to IP address is available in 1. So B will be mapping to 1. B1 is available in two options, but already we ruled out option 2. We are going with option 4 only. We will even rule out option 3. What about C? Internet Control Message Protocol, ICMP. This sends error messages and operational information like pinging the network we will say, to diagnose network issues. Network issue means some problem with the datagram. So we can take it as used by the host and the router to send notification of datagram problem back to the sender. When a router or host detects an issue with the datagram, it sends an ICMP message back to the sender. So what can be the issues with the datagram? Destination unreachable, time exceeded, all these are issues with the datagram. These issues are network issues. So used by host and router to send notification of datagram problem back to the sender will be ICMP. C will be mapping to 2. Next we have Internet Group Message Protocol, IGMP, manages devices in multicast groups for efficient group communication. Helps a multicast router identify host in a LAN. It will be managing all the devices. Obviously, it will be used to identify a particular host in a network. So D will be mapping to 3. Option number 4, A4, B1, C2, D3 will be the right answer. With this, we are completing Unit 9 solutions. Let's solve Unit 10 questions. Which planning approach is used for environment with no observations? What is planning? It is the process of generating a sequence of actions that an agent should take to achieve a goal given a model of the environment as well as constraints. So it is just a sequence of actions with which an agent can achieve some goal. Let's see about the types of planning approaches. The 4 types are listed in the options. We'll start with hierarchical planning. Hierarchy means we definitely know there will be some structure. A parent, a child, it will be in such multiple level structure format. This breaks down complex goals into smaller sub-goals and tasks. Useful for structured problems where tasks can be organized at multiple levels. Say for example, if this is going to be one goal, it will be split up as goal 1, goal 2 and goal 3 subtasks. And this can not be only in one level. It can be goal 1 can have another 2 sub goals. Goal 2 will have other 2 sub goals. So this will be split up in a hierarchical manner. So here it is not talking about the environment with no observation. So we will move on to the next type. It is reactive planning. This focuses on immediate responses to changes in the environment. There is no long-term plan here. Instead, it will react dynamically to the stimuli. It means when something happens, the response will be made immediately. This is reactive planning. Just get the term here, reaction. Whatever happens, we are just reacting. So such kind of planning is reactive planning. The next planning will be conformant planning. This is used when there are no observations or sensing during execution. Plans must guarantee success despite uncertainty in the initial state or environment. Uncertainty means anything can happen. Something can go in favor, something can go against us. So whatever happens, despite the uncertainty means in spite of these things, it must guarantee success. So this is used when there are no observations or sensing during execution. It means only when you observe or sense, you will be able to change your actions. But these plans will be confirmly working. Whatever happens in the environment, it will be going on towards success. This must guarantee success means there is no use of any observation. There is no need to sense while executing the plan. So the planning approach that is used for environment with no observations will be conformant planning. Option number 3 will be the right answer. Now we will see the final type, contingency planning. This will create plan that includes conditional branches depending on possible observations. This is useful when some sensing is available but outcomes are uncertain. For some extent we will know these things will happen. So all these constraints will become branches. That's why they are called conditional branches. When some sensing is available, you can list out the conditional branches, but again the outcomes are uncertain, means anything can happen. So contingency is taking all ways into consideration or taking the maximum possible ways into consideration. After taking them into consideration, even then you cannot make sure that the outcome will be success. So here you can use this for your learning. When it is of no observation, then it is conformant planning. When it has some observation or when there are possible observation, it is contingency planning. What about reactive planning? It is about immediate response. And what about hierarchical planning? It is the structured breakdown of tasks. Next question. Which logic is designed to address the problem of referential opacity in propositional attitudes? They have given about 4 logic: regular logic, model logic, first order logic, predicate logic. First, understand the options. First order logic and predicate logic are the same. First order logic will contain quantifiers. What does predicate logic contain? It also contains quantifiers. So option 3 and 4 are same. When same options are given, it definitely means that is not going to be the answer. If they say first order is going to be the answer, then definitely predicate should also be the answer. Maybe if they have given A, B, C, D and they have asked A, B combo, B, C combo, then you can take a possibility of first order and predicate. But for this question, you can directly rule out option 3 and option 4 because both are same. Now the competition is between regular logic and model logic. What is regular logic and what is model logic? If we know this particular difference, then we can address this question. So let's understand what is the meaning of the question first. So the question is, which type of logic is specifically designed to handle the problem of referential opacity in propositional attitudes? So this logic is not about true or false. It is based on belief, knowledge, necessity and possibility. What do we know about regular logic? Regular logic is about and or not operations, not more than that. Do you think and or not will decide belief, knowledge, necessity and possibility? Definitely no. From this itself you can rule out even option 1. The only option that is left here is model logic. So this must be the answer to this particular question. If you are new to these types of terms, then you have to go with this particular strategy in handling such questions. So let's get into the terms now. What is referential opacity? We know transparent opposite word is opaque. So this opacity is hiding something. We would have come across this term in computer graphics. So first we will understand what is transparency and then we will see what is opacity. What is referential transparency? You can replace one name with another if they refer to the same thing and the truth of the statement does not change. that is being transparent. I'll take a very usual example. What is idli actually? It is fermented rice batter. We say a statement, idli is healthy. And we have a statement called fermented rice batter is healthy. When you substitute idli with fermented rice batter, the substitution preserves the meaning. So this is called transparent context. I can say either idli is healthy or fermented rice batter is healthy because idli means fermented rice batter. So whichever term I substitute here, it is going to preserve the meaning. This is transparent context. Now, what is referential opacity? In context like belief, knowledge or necessity, you cannot freely substitute names even if they refer to the same thing. Let's take X believes that idli is healthy. So let's take this as X point of view, idli is healthy. But X may not know that idli is equal to fermented rice batter. But X does not know what is fermented rice batter. I mean, it does not know idli has another name. If we substitute idli with fermented rice batter, we will get X believes fermented rice batter is healthy. You cannot say both these statements are the same. Take a person and we have a clone of that person. I am telling I will believe this particular person. This person knows this one is the clone of himself only. But I don't know that this particular person is a clone. If you say that I believe this person, I will deny the fact stating I don't know who he is. The similar way, from X point of view, X does not know idli and fermented rice batter are same. So when you bring belief, knowledge or necessity, it is restricted to somebody's point of view. You cannot generalize it. This may be false because X might not believe that phrase. The reason is X does not know idli is equal to fermented rice batter. I hope you understand what I am trying to tell you. Here, substitution will change the meaning. This is opaque context. When it comes to beliefs, you cannot freely substitute. But here in referential transparency, you can freely substitute because this substitution will preserve the meaning. It will not change it. If idli is healthy, then definitely the rice batter is also healthy. This is transparent context. They say the truth of the statement does not change when you are able to replace one name with another if they refer to the same thing. But here, even if they refer to the same thing, you cannot freely substitute. That is referential opacity. Now they are asking which logic is designed to address the problem of such referential opacity when we express a belief or knowledge or necessity. This propositional attitudes is what we can say belief, knowledge or necessity. Which logic is going to address or handle this particular opaqueness in such beliefs? We know two logic, propositional logic, predicate logic. Do you think both these logic will handle this? No. We will say X is happy or we will say X is not happy. We will say idli is healthy or idli is not healthy. We will say some people will like idli and some people will not like idli. This is what we will say. We never said somebody believed that this is going to be healthy or somebody doesn't believe that this is healthy. So here regular logic or the predicate logic will not be of any use. Let's see the logic types given in the options. Regular logic is the basic classical logic with standard truth functional operators and or not. They do not address referential opacity. So regular logic is out of the race. We already did that. What about modal logic? We know this must be the answer. Logic of necessity and possibility. These two terms are here. This is used for beliefs, knowledge and referential opacity. This will extend classical logic with operators like necessarily and possibly. This symbol is for necessarily and this symbol is for possibly. It is specifically designed to handle propositional attitudes and referential opacity. What is this propositional attitude? X believes that idli is healthy. This is a propositional attitude. The attitude of X regarding idli. The substituting part is what we call as referential opacity. So definitely we can mark option number 2 as the right answer. Next option is first order logic. Logic with quantifiers and predicates, reasoning about objects and their relations. This deals with quantifiers, universal quantifier and existential quantifier, and relations between objects. Powerful for reasoning about structures but not sufficient for opacity in attitudes. What does first order logic involve? Predicate as well as quantifiers. Then what about predicate logic? This is a synonym for first order logic, emphasizing predicates and quantifiers. So both are going to mean the same. You have to know this particular thing in order to rule out option 3 and option 4. Do you understand why I say to rule out 3 and 4? Both are going to mean the same. How can you choose only one as the answer? Just based on this idea only, I am asking you to remove 3 and 4 for this question. And regarding regular logic, you must know these 3 operators cannot deal with beliefs and knowledge. So definitely 1 is also ruled out. Apply this strategy while answering questions with completely new terms. This strategy is called surviving using the options. Even when you don't know the context of the question, in this strategy, mostly you can get the right answer just by eliminating the wrong option. Next question. What is the space complexity of the CYK algorithm for the P table where N is the number of words in the sentence and M is the number of non-terminal symbols in the grammar? This is a mix of TOC and data structure. But why have I placed this in artificial intelligence? It is because of NLP. CYK can be TOC or algorithms topic, but its major application domain is natural language processing. So we are placing it in artificial intelligence unit. CYK is strongly relevant in NLP because parsing is central to understanding the sentence structure. Nowadays, instead of explaining context, I have to explain why I have placed this question in this particular unit. As per the unit, the thinking will differ. If you decide space complexity is going to be unit 7, you will not see this particular question, go for some random option. Only when you think in terms of NLP, you can apply some common knowledge for this question and answer this. What about the CYK algorithm? This is a dynamic programming algorithm used to determine whether a given string can be generated by a context-free grammar in Chomsky normal form. It works by filling a parsing table called P. So this is what they have mentioned as P table, where each cell represents possible non-terminal symbols that can generate a substring of the input. The algorithm builds solution in the bottom-up fashion. First for substrings of length 1, that is individual words, and then for substrings of length 2, 3 up to the full sentence. So let me elaborate this algorithm here. If the sentence has n words, a substring of length 1 means just one word. A substring of length 2 means 2 consecutive words. A substring of length 3 means 3 consecutive words. So this goes all the way up to length n, which will be the entire sentence. So this is how it will be working. So first for substrings of length 1 is this point, and substrings of length 2, 3 up to the full sentence will be these points. The question is asking about space complexity, and we know parsing table is involved here. So definitely the space complexity is for this particular table. The P table is a triangular matrix where rows and columns correspond to substrings of the input. there are about n square such substrings. So take it in this particular format, row and column format. So here this is going to be n rows and n columns. So this can be n square such substrings. Each cell stores a set of possible non-terminals that can generate that substring. Now we have to find the number of cells in the table. They have talked about n number of words. So we are going to place the substring only inside the matrix. So this is n words and n words we can say. So for 1 and 1 there will be one word. Then 1 and 2 we will have two consecutive words. Then in 2 and 1 two consecutive words but in another order. So all the possibilities will be in the matrix. So for the number of cells in the table, for substrings of length 1 to n, there are about n into n plus 1 by 2. The summation part we have to take. I is equal to 1 to n. We will have n into n plus 1 by 2, which is approximately big O of n square cells. When you have n into n plus 1 by 2, this will be n square plus n. Which part is going to dominate here? N square. So this will be big O of n square. You have to apply analysis of algorithm here and get it as big O of n square. So the number of cells here will be big O of n square. We are dealing with space complexity. So first we have to get the number of cells. After getting the number of cells, we have to multiply it with storage per cell. Say for example, there are 3 variables. Every variable is going to take 4 bytes. So what is the total space here? 3 into 4, which is equal to 12 bytes. Similarly, we are doing for this. For storage per cell, each cell can store up to m non-terminal symbols, since any non-terminal could potentially generate that substring. So we have m non-terminals and n square cells here. What will be the total space complexity? This will be the number of cells and this will be the storage for one cell. Big O of n square into big O of m. This will overall give big O of n square into m. It is available in option 3. Option number 3 will be the right answer. This is for the number of substrings and this is for the number of non-terminals. So from the question you can directly apply this. Let's go for the first option. They have given n cube. Here only the number of words are taken into consideration. Definitely it will not be the answer. What about n into m square? This algorithm is dealing with 1 word, 2 word, 3 word strings. Only the substring process is going to be repeated. So there is no need to have m square. And the entries are restricted to n, so 2 is also out of the race. Regarding n square and m square, this part is fine. But there is no need to square up the non-terminal symbols number. The non-terminal symbols can be present as it is in every cell. So definitely m square is not needed. So we will rule out even option 4. The space complexity for the table will be big O of n square m. So see the question, what is the space complexity for the P table is the question. So we are calculating with respect to P table. So the first part will be rows and columns where n square strings are involved, and the second statement is about the cell that stores m number of non-terminals. So only these two elements are involved in calculation of space for the P table. What about the time complexity? Regarding the time complexity, it is big O of n cube into m square in the worst case, or big O of n cube with respect to fixed grammar. When it is having fixed grammar, the m part may not be taken for the time complexity. So this is just for your reference. It might be useful for you in another question paper. Next question, in artificial intelligence, the term Turing test is primarily associated with. Let's see the options. Testing neural network convergence, measuring computational efficiency of algorithm, evaluating machine ability to exhibit human-like behavior, verifying correctness of AI search algorithm. Turing test is the basic concept that will be introduced in the artificial intelligence unit. Neural network is an advanced topic. It will not be a basic part. So definitely one will be out of the race. Regarding computational efficiency of algorithm, we have complexities and analysis part to do that. So that has nothing to do with Turing test. Taking the fourth one, verifying correctness of AI search algorithm. Just with a specific search algorithm, we are not going to define some term. So this will also not be relevant. The only option that can be relevant is statement 3. Think that you don't know statement 3 is the correct answer. This is how you have to think and eliminate the 3 options. Alan Turing, often called the father of modern computing, introduced the idea of machines performing intelligent tasks. So it is named after him as Turing test. Let's see the options now. Testing neural network convergence. Neural networks are trained using optimization methods, and convergence refers to reaching stable weights or minimal error. This is a concept in machine learning and it has nothing to do with the Turing test. What about the second statement? Measuring computational efficiency of algorithm. Computational efficiency is about how fast or resource friendly an algorithm will run. This is based on time or space complexity, as I told you. Again, this is an algorithms topic and not related to the Turing test. What about the third statement? Evaluating machine ability to exhibit human-like behavior. The Turing test checks if a machine can imitate human responses so well that a human judge cannot distinguish between the machine and a human. It is directly tied to AI and human-like intelligence. So we will go with option number 3 as the right answer. So what is the Turing test telling us? It is evaluating the machine's ability to exhibit human-like behavior such that even humans will believe that the response is from a human being and not from a machine. So the machine is allowed to imitate human in such a way that even a human cannot distinguish whether it's a machine or a human. So in that way it has to imitate. So this is about evaluating the ability of such a machine. So that is Turing test. Now the fourth option, verifying correctness of AI search algorithm. Correctness of search algorithms like BFS, DFS, A** is about whether they find valid solution. This is a search problem in artificial intelligence, but it is unrelated to the Turing test. So while learning about these 4 options, one is related to Turing test definitely, but you can also understand testing neural network belongs to machine learning and verifying correctness is belonging to search problem in AI. You can explore more on these options. Exploring more means you can learn about machine learning, you can learn about search strategies in AI. Instead of starting a unit from scratch and going topic by topic, sometimes if you have basic idea about all the AI topics, I am talking about the basics. From previous year question paper, from every option if you start studying, after completing all the previous year question paper, you would have at least completed 70% of AI syllabus. This is one way of learning. If you think that you can learn this way, you can adapt this strategy. Next question, this is assertion reason question. This question is talking about unsupervised learning. A similar question is coming with supervised learning statement. So whatever you learn about unsupervised learning here will be helpful in the other question too. Let's see the assertion. Unsupervised learning algorithms are used for tasks like data summarization and exploratory data analysis. Go for the reason. Unsupervised learning requires labeled data set to find relationships and patterns in data. This is actually wrong. When you give a labeled data set, it means you are giving the data along with the output. I mean both input and output are given and training happens. That is called supervised learning and not unsupervised learning. From here we can say reason is definitely not correct. What about assertion? That is correct. Unsupervised learning is used for clustering, dimensionality reduction, anomaly detection and exploratory analysis where labels are not available. This is the key point. So A is true but reason is false. What does the reason say? If this statement is not unsupervised learning, then what it is? R is describing supervised learning where labels are given. So let's see the detail. Unsupervised learning does not require labeled data. It works on unlabeled data sets, discovering hidden structures or patterns without predefined categories. Let's mark the answer. Option number 3, A is correct but R is not correct will be the right answer. Now let's see about supervised learning and unsupervised learning. Supervised learning needs labeled data. It means input-output pairs are given and training is taken. Example, training a model to classify emails as spam or not spam. This is a classification problem. So when you keep giving the mails and whether it's spam or not spam, on training it will understand how to classify the mails as spam and not spam. So where it is taking the learning from? It is taking from the input-output pairs, which is the labeled data. What about unsupervised learning? This works with unlabeled data. This will find hidden structures or groupings. We can say clustering. Example, clustering customers by purchasing behavior without predefined categories. What is clustering? It is grouping customers by purchasing behavior. So grouping means people who purchase this particular product are also purchasing this particular product. They can be grouped separately. Or people who purchase only on weekends and people who purchase on weekdays. They can be grouped. Or people who pay only through UPI and people who pay only through cards. That is a grouping. So you need not label the data and tell that this group is doing this way, that group is doing that way. It will automatically group. So this grouping is what we call as clustering. So it will automatically find the hidden structure during the training process and it will group them. Have this learning in mind. It will be useful for the next assertion statement that appears in 287 question ID. Next question. Consider the following statements about reinforcement learning. There are 4 statements about reinforcement learning and every statement is going to tell a different story. So first we will learn about reinforcement learning and then we will get on to the statements. What is reinforcement learning? It is about agents learning to make decisions in an environment modeled as a Markov decision process. This is more of a technical statement. Actually, reinforcement learning is where the learning takes place based on some feedback, either a positive feedback or a negative feedback. Say for example, take the rat in a maze problem. When the rat takes the right route, then it is given appreciation, and when the rat is taking a wrong route, then it is given some warning or some error messages. So it keeps learning from those appreciation and those error messages whether to take a particular route or not. This is reinforcement learning. Based on some kind of feedback, the training will be taking place. They say the agents learn to make decisions in an environment modeled as Markov decision process. What is Markov decision process? It is to model sequential decision making under uncertainty. It means the actions are based on the current state. Based on one point where you have to travel, that point you will take a decision and move. So this is Markov decision process. We are not getting into too much detail about reinforcement learning because these statements are going to give you lots of detail. Let's start with statement A. The adaptive dynamic programming agent leaves the transition model between states, utilizes to solve the corresponding Markov decision process using dynamic programming. This is talking about adaptive dynamic programming. This adaptive dynamic programming is a model-based reinforcement learning approach. Since we say it is model-based, it learns or uses the transition model and then applies dynamic programming to compute optimal policies. So the learning takes place through transition model. What is the model here? The probabilities of moving between states, whether you can take a particular transition or not. After learning from the transition model or after using the transition model, it will apply dynamic programming to compute the optimal path. This is too technical. Let us see in real-time example. This is like having a map of the environment and using it to plan the best route. Imagine Google Maps. Based on the position where you are standing, you know where you have to go and what are the different kinds of routes. You can plan multiple routes too. But based on the environment or the real-time road traffic, you will decide which route to travel. So this is what they say. It's like having a map of the environment. This is the transition model, and using it to plan the best route will be applying dynamic programming to compute the optimal way in the map. So this is the statement, and regarding reinforcement learning, this statement is perfectly true. The adaptive dynamic programming agent, it is not actually leaves, it should be learns the transition model between states, utilizes to solve the corresponding MDP using dynamic programming. Learns the transition model is what they say here, and then utilizes to solve the corresponding MDP using dynamic programming is what the second half of the statement is telling. So A is true. Let's move on to B statement. Temporal difference needs a transition model to perform its updates. What is temporal data? It is time related data. Temporal difference means difference between some time we can take. It needs a transition model to perform its updates. Is it a valid statement? Temporal difference learning is again used in reinforcement learning. This is a model-free reinforcement learning method. So the statement is claiming that it needs a transition model to perform its updates. It can be taken as false statement. It updates value estimates directly from experience without needing the transition model. So this is like learning shortcuts by trial and error without knowing the full map. So if you go to some places where you don't have Google Maps, some interior streets or some interior areas, Google Maps cannot help you. So in those areas, you have to travel multiple routes and see which is nearer or where is your destination. Everything will be learnt here by trial and error. Sometimes Google Map will give you the longest route, but when you take a local guide to travel someplace, they will take you through shortcuts. So this learning of shortcuts by trial and error is what they say as model-free RL method. In temporal difference, there will be no transition model involvement. So the statement stating that it needs a transition model to perform updates is wrong. So how the updates are done here is directly from experience. I go for a street and it goes to a corner and there the street ends. Just by my experience, I update the value stating that this path doesn't cover my destination. If I take another street, it gives another route to easily reach my destination. I will say this path can be taken. Usually the main roads, the very much traffic areas will be guiding the tourists. The internal routes will be known only by the local people. Having a map and using to plan the best route is sitting at your home and planning a place. Trial and error learning can be taken as getting into the city and going to the interior of that particular location. You can take like getting into a remote place and then learning how to travel from there. B is wrong. Any option that involves B can be ruled out. So obviously we know what is the answer now. Let's go for C statement. The prioritized sweeping heuristic focuses on adjusting states with successors that have undergone significant changes in utility estimates. What is the statement telling us? It is talking about prioritized sweeping. This is a planning heuristic used in model-based reinforcement learning. So here they have mentioned about adjusting states and all. So definitely it is model-based. Instead of updating all states equally, it focuses on states whose successors had big changes in value. This is like fixing the most urgent parts of your plan first when something changes. Say for example, you find that many places in one particular area is marked wrong in the maps. Instead of going and applying edit to all the places, whichever places are visited by more people, example whichever places are needed by the tourist, you can update them first. So what is this tourist area? These are the areas where crowd will be there in weekends or in some days we can take. So here when something changes is when more people gather in that particular place, the change has to be done to that particular place. So taking that example into consideration, we can understand instead of updating all the states equally, we will focus on the states whose successors had big change. Means if there is a state here, namely Q0 and another state Q1, from here you can update the neighbors. Q2, Q3, Q4 are present, but only Q1 and Q2 are having change in their values. These two are not taken by the tourist we can take. So you need to update only those successors who had some change. As per our example, where crowd gather, only those places need to be updated. The rest of the places can be done at a later time is what they say. So the prioritized sweeping heuristic focuses on adjusting state with successors that have undergone significant changes in utility estimates. Significant changes means some important changes or some noticeable changes you can take. So when there are important changes done in successors, those successors can alone be focused. That is what C statement is telling. So the explanation is also stating the same. C is definitely true. What about D? The approach of modified policy iteration involves adopting a simplified value utility estimates following each change to the learned model. This is modified policy iteration. This is a hybrid between value iteration and policy iteration. Instead of fully evaluating the value function after each policy change, it does partial updates, what we call as simplified updates or simplified estimates. This is like updating your travel plan with rough estimates instead of recalculating everything in detail each time. You have started from your native, you have to reach some tourist spot. You are in some bypass road or you have taken some service road to travel inside. When you want to plan your travel from that point, what you should do is you have to start from there to the destination. It's not like you have to rearrange the plan from your native place. After coming to your native place or after reaching the destination, you can make adjustments in the complete planned route. But when you have to reach the particular destination, your focus should be on reaching there. This is what they say. It's like updating your travel plan with rough estimates. Take for example, you are having a plan, but a local guide is coming to you stating that that road is now used by local people for some festival. You cannot take it. So what you will do, you will rely on the local guide. After relying the local guide, you will take the plan given by the local guide. In technical aspect, we can call it as a rough estimate because you don't know the place, only that person knows the place, and whatever he does, you have to believe him. If that plan doesn't work, he is not the loser, you are the loser. He can only guide you, he cannot give you the optimal result. So that is taken to be rough estimate. So what does this approach say is, it involves adopting a simplified value utility estimate. So you are simplifying the update or simplifying the estimate following each change to the learned model. Take for example, you have 4 routes from here. You are taking this route, you are making changes only here. You are taking this route, you are making changes only here. If you take reinforcement learning on the whole, all these content together can give you a good story. But when you are starting with all these terms, This might sound Greek and Latin to you. I thought I can give you the meaning of these statements and make you relate it to reinforcement learning using maps plan. So that's why I tried this. D is true as per the explanation we had in modified policy iteration. Here we have a point that along with modified policy we have value iteration and policy iteration. So this is a hybrid approach, and this approach is stating that instead of fully evaluating the value function after each policy change, we are doing only partial updates, which is nothing but simplified estimates, which is equated to simplified value utility estimates here. So D is also true. We are going with option number 3. A, C and D only as the right answer. Next question. In a multi-agent system, what are the key characteristics of individual agents? They must be identical in their capabilities and goals. They are autonomous and act independently. They interact with each other and their environment. They are controlled by a single centralized authority at all times without knowing the background story. Start with B. They are autonomous and they act independently must definitely be true. So let's take B to be a true statement. Let's get into C. They interact with each other and their environment. Regarding multiple agents involvement, definitely interaction point is to be noted, so it will definitely be valid only. What are the options that involve B and C together? We have B and C here, B and C here. Based on general idea, we can rule out 3 and 4. Now the question is whether A must be true or D must be true. Which is true? The sad part of the story is A and D both should not be given as true answers. Only B and C are perfectly correct. Regarding A, they are true to certain extent. Some cases are there. Regarding D also, certain systems accept it. We cannot fully deny A, but we can fully deny D because of one phrase that has been given in the statement D. They are controlled by a single centralized authority. If they had stopped till there, we can claim that there is a possibility of such a scenario to happen. But what is the final phrase saying here? At all times. This is the wrong part. Generally, when they talk about autonomous characteristic, they cannot be controlled by central authority. That is true. But there are systems, multi-agent systems, they can be controlled by centralized authority, but not at all times. So this point is telling that D must be wrong, making you rule out even option 2. What about A? Generally, we will not expect all the agents to be identical in their capabilities and goals. Regarding a particular task where everybody should gather together and do properly, there the possibility is there. In that aspect, we can mark A to be true. There is a possibility here. And in case if the statement ends by authority, then the same ideology of A can be adapted even for D. It means this is possible but not at all times. Similarly, this is also possible but not in all cases. But here you don't have any phrase stating that in every case. So taking that point into consideration, A will be inside and D will be outside. Now we will get into the learning. A multi-agent system is a collection of autonomous agents that interact to solve problems too complex for a single agent to do. So B and C points are covered completely here. Autonomous agents as well as interact to solve problems. Agents can have local goals that differ, but they align or coordinate towards a global system objective. Why are multi-agents involved in a particular system? When one agent is not enough to tackle that particular system, we bring in multiple agents. So every agent will be given different tasks. That is not a problem. But ultimately they should work towards the goal of the system. So everybody's goal should be towards the system. So take Indian Army. Every army officer will be assigned a different task. But overall, what's their goal? To protect the country. Similarly, I don't know why I got this example suddenly. Maybe the movie that I saw recently made me think this. But you can relate this example to understand multi-agent system with a single goal and having different local goals. Let's start with A statement. They must be identical in their capabilities and goals. This is correct. How? In multi-agent systems, agents can be heterogeneous. It means they can have different set of skills, different levels of knowledge and even different goals. Here the different goals refer to the local goals. But they cooperate through communication and coordination to achieve system level objectives. This is global. In homogeneous multi-agent system like drones, agents may indeed be identical in both capabilities and goals. Imagine a set of drones. They are all agents. Do they have same capability? Yes. Do they have the same goal? Yes. Such systems are homogeneous systems where everything will be same. Taking homogeneous MAs into consideration, we can perfectly mark A to be true. We will get on to B statement. They are autonomous and act independently. This is also correct. Autonomy is a core characteristic of agents. They make decisions without constant external control, which is actually contradicting D. Each agent can pursue its objectives, react to changes and adapt its behavior. Now C statement. They interact with each other and their environment is perfectly correct. Interaction is essential because there are multiple agents involved. Agents communicate, cooperate or compete with one another. Compete means sometimes there can be a competition like which agent is going to give you more information or whose decisions are mostly correct. They also sense and act upon their environment, which allows coordination and adaptation. Irrespective of all differences, they have to coordinate and adapt. So C is definitely true. We'll go for D statement. They are controlled by a single centralized authority at all times is definitely false. Multi-agent systems are typically decentralized. A fully centralized authority contradicts the principle of autonomy and scalability. A centralized authority may have a limit of controlling only 10 agents. If the number of agents are going to increase or the capabilities are going to increase, the centralized authority cannot manage everything. So in that angle they say this will contradict the principle of scalability. What about autonomy? You are not allowing it to act independently and take its own decision based on the environment. So that is contradicting here. But apart from these, there are also centralized authority controlled agent system that are available in multi-agent system. There are examples. But here the problem is the statement is ending with at all times. Because of this, even though there are examples for centralized authority, we are marking it to be wrong. So the same thing I told for A. There are systems like drones whose capabilities and goals are identical. But here they didn't mention something like every MAS will have such quality. Instead, they have given such quality exists. So, we are marking it correct. But here, the possibility is extended to all places, all times, which is wrong. So, we are going with option number 1, A, B and C only as the correct statements. Next question. Arrange the following sequence related to fastest system. What is fastest system? The system consists of a series of small, efficient, finite state automata where each automaton receives text as input, transduces the text into a different format and passes it along to the next automaton. Actually, there are lots of research articles regarding faster system, but this question is taken from a particular material in NLP where they have all these stages which are available in certain universities exam material. So, I am presenting that content here. What is the first step? In lexical analysis, what we do? We will actually divide it into token. So, any NLP part will be starting with tokenization. This will be the initial phase of breaking input into strings of characters and token. After getting the characters and the token, you have to find complex words. Identifies multi-word fixed phrases, proper names and company names. Maybe you can identify people, location from that. You can take this as a group of characters and this is coming to word. What is the next step? This will be basic group handling, also called as basic phrases. This stage segments sentences into noun groups, verb groups and particles. So here after finding the words, you are starting with basic grouping of words, noun groups, verb groups and etc. So what is the next stage? It must be complex phrase handling. So this is basic phrase. After basic phrase we will have complex phrase. If you understand this group is nothing but the phrase, then you can easily arrange A, D in this particular order. So we are starting with C going to E, then we have A, D. Identifies complex noun and verb groups such as those involving appositives or prepositional phrase attachments. So what is a appositive? It's a noun or noun phrase that sits next to another noun to explain, identify or rename it. A noun explaining another noun. Data about data, metadata, that part only technically, but grammatically it is appositives. The final task will be structure merging. The final stage where structures, incident or event structures from different parts of the text are merged if they refer to the same entity or event. So merging must be done finally only. So we are initially breaking down, grouping them, finally merging them. So this will be coming in the final part. C, E, A, D, B. Option number 3 will be the right answer. Now you don't have any idea about faster system. You have to answer this in the context of NLP only. Definitely you should know it will start from tokenization. So after finding out tokenization, you can rule out 2. Now just see, it is A and E in the second part. What is A? It is basic group handling and here it is complex word handling. So there might be confusion between these two. In case if they have given basic phrase here, then you could have definitely placed E before A. After complex word only you will have complex phrase. So E should follow D. This order you can search. Here D is given before E. So you can rule out option 1. There is a tight competition between option 3 and option 4. Only with some idea you will be able to answer. It is option 3. So we will even rule out option 4 here. Next question. Arrange the following steps of natural language processing pipeline in correct order as per compiler phases. What do we know? It starts from lexical analysis. What is lexical? It means the morphology part. So it must start with B. We can rule out option 1 and 4. Then comes syntax analysis in A. Then semantic analysis in D. So B, A, D. This order is found in option number 2. If you place D before A, semantic analysis, then syntax analysis, compilers will never forgive you. So don't go for option 3. At least you should have the order A and D will come together. So the only place where A and D comes together is option 2. Just based on this you can mark option number 2 as the right answer. If you are not able to relate lexical analysis phase to morphological analysis, you can go with A, D order here. With the knowledge of compilers only, they have developed NLP system. So those phases should be like foundation concepts for NLP. Let's start with the first stage. Morphological analysis breaks words into their smallest meaningful units called as morphemes. Say for example, if you find a word called cats. Cat is the meaningful unit. S is the plural form. So it will take cat from the word cats. So that is breaking words into meaningful units, that to the smallest meaningful units. What is the next stage? It is syntax analysis. This will check grammatical structure, arranging words into phrases and sentences. The parsing occurs. Then comes semantic analysis. This will interpret meaning of words and sentences, resolving sense as well as the context. Then comes pragmatics. So I have talked only about 3 stages. I didn't talk about C at all. Did you think why? Because I was comparing compiler phases to NLP. I didn't bring pragmatics. Actually, pragmatics will be the next stage. This considers meaning in real world context, including speaker intention and situational use. So this will be the order as per the question. But there are actually 5 phases in the NLP pipeline. Let me give you. It is morphological analysis for breaking words into morphemes, syntax analysis for checking grammatical structure, semantic analysis for interpreting the meanings of words and sentences, discourse analysis, and pragmatics come in this order. Some articles give the order of pragmatics and then discourse analysis. They go with pragmatics first and then discourse analysis next. So let's first understand what is discourse analysis and pragmatics and then check which is first and which is next. Discourse analysis will link sentences together to understand overall text meaning and coherence. After linking the statements together only, you will be able to apply real world context and the speaker intention, which is pragmatics. So here real world context means, say for example, a person may ask you why you are late. Why you are late can be based on 2 emotions, a normal emotion, angry emotion, or even in tearful emotion, like in a very pathetic situation they can ask you why you are late. So this is pragmatics. So how will you apply the real world context and the speaker intention based on the sentence alone? The sentence before it and the sentence after it. The story before the scene and the story after the scene will decide the real world context. So discourse analysis will come first. You have to link sentences and understand the overall text. Maybe they will say X has to reach office by 9. After X reaches, the time was 9:30. The boss asked, why are you late? Here can you apply emotional feeling? No. It is out of anger. Why are you late? Only when you combine these sentences together, you will get the context of the situation. From the context of the situation, you can apply the context and get the speaker intention. Here, this is considering the meaning in real world context, including the speaker intention. To understand the intention of the speaker, one statement is not enough. The previous story or the previous context or the previous statement at least is necessary, is what I am trying to tell you. So this is the overall pipeline, but this question has considered only 4 stages in the pipeline. Next question, it is an assertion reason question. Assertion states, neural networks are capable of approximating any continuous function to an arbitrary degree of accuracy. Reason states that this is explained by the universal approximation theorem. So let's take A in a plain context. Neural networks are capable of approximating any continuous function to an arbitrary degree of accuracy. Neural networks part is to bring accurate results. After finishing the training, adjusting the errors, updating the weights, they have to bring accurate results. So neural networks are capable of bringing accuracy. We will take it in this context. The statement is true only. Now let's get into the universal approximation theorem. It states that a feed-forward neural network with at least one hidden layer and a sufficient number of neurons using a suitable activation function like sigmoid or ReLU can approximate any continuous function on a compact subset. So this is getting too mathematical. Let me take only the meaning of the theorem. A feed-forward neural network with at least one hidden layer and a sufficient number of neurons can approximate any continuous function. This is what they have given in assertion A. So definitely A is correct. The reason states that it is explained by the universal approximation theorem. Yes, this theorem is explaining that part only. So R is also correct. The theorem is precisely the mathematical justification for why neural networks can approximate continuous functions. So from this what you understood? R is the correct explanation of A. So from this we can rule out option 2, 3 and 4. We can go with option number 1 as the right answer because the theorem is stating what is given in assertion. We will get into the theorem part. We saw something like it can approximate any continuous function on a compact subset of R power n. What is this? Compact subset of R power n means any closed and bounded region in n-dimensional space where the function is defined. Why do they talk about compactness here is neural networks can't approximate functions over the entire infinite space R power n. But if you restrict the function to a finite closed region, then approximation is guaranteed. But this statement doesn't talk about whether it is closed region or infinite space and all. So generally the statement is correct. But universal approximation theorem is giving you the approximation will be done on a compact subset of R power n. So here you can relate to discrete structures group theory. When we were learning about every integral domain is a field, I said it is false. And when it was finite integral domain, we said it is a field and the statement is true. Similar context you can apply here. When it is the entire infinite space, you can take it as the entire integral domain statement. And when they say it's finite closed region, this is like finite integral domain is field. We learnt this in Unit 1 Discrete Structures and Optimization solution videos of December 2025 exam. So that example I am applying here. So they say neural networks can't approximate in the overall space. Instead, when the space is restricted to finite and closed region, then they say the approximation is guaranteed. Here, neural networks capability of approximation is only given here. It is not given with respect to open space or closed space. Neural network will do well in finite and closed region. So whenever there are statements about neural networks, it will talk only about the space it is involved in. But when mathematics is involved, there they will stress it is on a compact subset of R power n. Next question. This was the question I was talking about in unsupervised learning assertion recent question. The question ID for unsupervised learning is 281. Assertion states, in supervised learning, the model is trained using labeled data. This is perfectly true. The reason states, supervised learning algorithms find patterns in data to predict outcomes without any prior knowledge of the correct output. This is totally contradicting. This is false. We already saw about supervised learning and unsupervised learning point. So supervised learning needs labeled data while unsupervised learning works with unlabeled data. When they say labeled data, it is nothing but input-output pairs. If the reason states without any knowledge on correct output means in the input-output pair, they are saying the output will not be present. So this is definitely wrong. A is correct. Supervised learning requires input-output pairs. Input will be the features and output can be equated to labels. So based on these features, you are labeling the input you can take. They require input-output pairs to train the model. A is definitely correct. What about R? R is describing unsupervised learning here, where no labels are given. When they say there is no knowledge about the output, it means no labels are given. So it has to find patterns to predict outcomes automatically, means their unlabeled data is referred. So unlabeled data is for unsupervised learning and not supervised learning. So we will go with option number 3. A is correct but R is not correct as the right answer. Why R is not correct? In supervised learning, the correct outputs called as the labels are already provided during training. The model learns the mapping from inputs to outputs, from features to labels using this prior knowledge. So when they say there is no output, there is no mapping, obviously there is no knowledge which can be equated to unlabeled data set. So we are marking R to be incorrect. Next question. Match the list 1 with list 2. We have some fields of artificial intelligence listed in list 1 and the real-time application listed in list 2. Let's go for NLP because this time already 3 or 4 questions are from NLP. NLP is going to be regarding text. So text summarization will be for NLP. What about machine learning? Just now we saw it is for giving predictions on the data, whether it is supervised learning or unsupervised learning. It is for predictive analysis, and so ML will be mapping to 4. Just check whether B2 is available in any option. It is available in 2 options. What about machine learning? It is available in all the 4 options. So you cannot rely on it. What about computer vision? There are 2 more options here. Medical diagnosis and image classification. You can equate vision to eyes. When you want to classify images, you look and do it. So taking this into plain context, you can connect computer vision to image classification directly. C3 is also available in 2 options. What about expert systems? Expert systems will be for medical diagnosis. A1 is available only in 1 option. So we have A1, B2, C3, D4 as the right answer. Option number 1 will be the right answer here. Now let's learn about them. Expert systems are used in medical diagnosis to simulate the decision-making ability of human doctors. NLP techniques are applied in text summarization to automatically condense large documents into shorter, meaningful summaries. Imagine you are given 1 page as input and NLP engine will give you the summary of that particular 1 page in 3 or 4 lines. That is what actually we do in search engines also now. So imagine that as NLP engine. Next we have computer vision. This is used in image classification to identify and categorize objects within images. Imagine you have some kind of sensor in your eyes. Just looking at an image, you will be able to identify which are humans, which are furnitures, which are other living beings. So sensors working with images can be equated to computer vision and image classification. Just based on real world context, if you are able to map it, you can understand why computer vision is matching to image classification. What about the final one? Machine learning powers predictive analysis by finding patterns in data to forecast future outcomes. When you keep training for a set of mails as spam and not spam, when a new mail comes, it will be able to predict whether it is spam or not spam. When they keep giving a group of people's behavior to the machine on analyzing and on getting trained with the given data, it will be able to predict a new customer's behavior. So this is what we call as predictive analysis. So list 1 is all about AI technologies we can take because ML, NLP, expert systems all are part of AI only. So this is AI technologies and their applications. So if you want to have extra learning, what you can do is you can go for applications of expert systems, applications of NLP, applications of computer vision and applications of machine learning. It might be helpful for you in some other question paper. In matching list or even in some assertion and reason statements, it can help you. Next question, match the list 1 with list 2. List 1 is the types of clauses or inference taken from logic, and list 2 will be the properties or methods used we can take. So let's get into the learning. Definite clause. A definite clause is a special kind of horn clause that contains exactly one positive literal. When we have A or negation of B or negation of C, here only A is positive. This makes it useful for representing rules like if B and C are true, then A must be true. I'm not getting into the detail. A will be mapping to 4. A4 is available in 2 options. We will rule out the other 2. What about horn clause? A horn clause is a disjunction of literals with at most one positive literal. This generalizes definite clauses which always have exactly one positive literal and goal clauses which have none. Horn clauses are central in logic programming and Prolog. If you take the meaning of horn clause, it should have at most one. What is at most one? Not more than one. So horn clause is about at most one is positive literal. So B will be mapping to 2 here. What about the goal clause? So we already had a clue here. It has no positive literal. A goal clause is a horn clause with no positive literals. It represents a query or condition to be satisfied, often written as a conjunction of negated literals. Example, asking is A true can be represented as a goal clause. So goal clause is mapping to 3. And how goal clause is written? As a conjunction of negated literals. It means no positive literals are there. And the final one, inference with horn clause. This often uses forward chaining, a reasoning method that starts from known facts and applies rules to derive new facts until the goal is reached. It means from whatever you know, you are trying to derive something new, applying those knowledge. Inferring the known fact and then applying the rules to derive new fact. If we know B and C are true, we will have the rule B and C implies A. Forward chaining lets us infer this A. A general example I have given. Inference with horn clause will be mapping to forward chaining. D will be mapping to 1. A4, B2 is here in both the option. C3 is available here and D1 is available here. We will rule out even option 2. We will go with option number 4. A4, B2, C3, D1 as the right answer. Take this as a beginning level knowledge in clauses and try to explore more on this, so that it will be useful for you in some other question paper. With this, we are completing Unit 10 solutions.